Azure load balancing services you're expected to know about for the exam. And first of all, we have Azure Load Balancer. This is the most common one. This works at the transport layer, so think layer 4 in the OSI network reference stack. It provides network level distribution of traffic across instances of an application running in the same Azure data center. Now, in contrast to Load Balancer, we have Application Gateway. This works at layer 7, the application layer. It also acts as a reverse proxy service, terminating the client connection and forwarding requests to backend endpoints. And finally, we have Traffic Manager. Think global scale, globally distributed endpoints. This works at the DNS level, so we might have applications running in multiple regions and users coming in from multiple locations. That's where we would utilize Traffic Manager. Now, in more detail, let's look at Azure Load Balancer first of all. So as I mentioned, it's layer 4. It's important to know that there's basic and standard SKUs now available. Now, the standard SKUs are in preview. They're not required for the exam, so you're only expected to know about the basic one, but just know that's coming out, and we'll certainly update the material when that actually happens. You have something called service monitoring as a feature. This allows Azure Load Balancer to probe the health of various server instances behind the load balancer. When a probe fails to respond, the load balancer can stop sending new connections to the unhealthy, let's say, virtual machines that are behind the load balancer. We have something called automatic reconfiguration as well. So this can reconfigure itself automatically when you scale instances up or down, perhaps when you add new web server instances as an example. Next, we have something called hash-based distribution, and this is how Azure Load Balancer distributes its traffic. And by default, it uses a 5-tuple hash composed of a source IP, a source port, destination IP and destination port, and protocol type to map traffic to the available servers. It also provides stickiness only within a transport session. So this means that if a client comes back, has the same session, they will continue to connect to their same, say, web server behind the load balancer as well. And finally, there's internal and public options. And you'll see some of the examples in a minute, but just know you can configure an internal load balancer for traffic to hit it and then disperse for internal applications, or it could be people coming over the internet and you want to expose a public IP, and then, once they hit that load balancer, then we pass traffic to the servers behind the load balancer. So let's look at some of those examples. First of all, look at an internal example, and in this case we have our internal load balancer at the top there, which has a private IP associated with it. That can be dynamic or static as well. You can decide how you configure that. And then we could have, say, 2 database servers behind the load balancer. Traffic will hit the private IP and then be sent over to one of either DB1 or DB2. Now let's look at a public example where, if we look at the load balancer, which is in the center of the screen, the traffic would come through the cloud at the top there over TCP port 80, and then we would pass the traffic down to one of the 3 available web servers that are behind the load balancer there. Now you're also going to get multi-tier examples as well. So in this case, you might see traffic come in and hit one of the 2 load balancers. First of all, traffic from the public cloud would come in and hit that web load balancer at the top, and then that would pass the traffic down to the web tier. Now those virtual machines that are perhaps the websites would then pass traffic to another load balancer when they want to query the database. So in this case, the second load balancer there goes in front of the database servers, and the web servers just query the database server. Now it's also possible then that people internal could just hit that database server if they wanted to from other applications as well. Could be coming from the website. It opens up a host of options for you there. So let's shift our attention now to the App Gateway, the other load balancer that's available to us from Azure. And first of all, it's layer 7 app load balancing, as I mentioned before. So just keep that in mind the whole time. When we want application load balancing, we need App Gateway. When we want just layer 4 load balancing, we can get away with just Azure Load Balancer. But a couple of unique features as well are important. So cookie-based session affinity, this is a common requirement for many web applications. And this is required so that a user can maintain the same user session on a backend server. It also supports SSL offload, so all those decryption tasks, etc., that web servers would normally have to deal with. They don't have to deal with that now. They can offload that to App Gateway, and it can take care of it for them. We also have end-to-end SSL, so App Gateway supports end-to-end encryption of traffic. It does this by terminating the SSL connection at the App Gateway, and then applies routing rules to all of the traffic, and then it re-encrypts the packet and forwards it to the appropriate backend based on the routing rules that you've defined. In addition, one of the most popular new features that they added recently was around web application firewall, and this has become a key feature. When you enable this, it provides protection for web applications from a lot of common web vulnerabilities and exploits. This can include like SQL injection, cross-site scripting, things like that. And you also have URL-based content routing, and this allows us for directing traffic to different backend servers based on the content that the user is actually requesting. Different server can serve that content up. And finally, one very important thing is App Gateway does require its own subnet, and you need to create that subnet before you can create your App Gateway, and you'll see this in the upcoming demonstration. In addition, there's a few things you need to know around App Gateway sizes. In the following table, this shows you an average performance throughput for each application gateway instance, and this is shown with SSL offload enabled. And Microsoft does make a caveat on their website for this. These values are approximate values for an application gateway throughput. The actual throughput depends on various environment details, such as your page size, the location of the backend instances, and the processing time to serve up a page. So just keep that in mind as well. Finally, if we just take a look at a comparison overall, we covered Azure Load Balancer, we've covered App Gateway, and we've covered Traffic Manager just very briefly there. So just think at the top level technology, what am I trying to do? So if I need layer 4, Azure Load Balancer, if I need layer 7, App Gateway, and if it's something more geographically dispersed, think DNS level, think Traffic Manager in that context. As far as endpoint monitoring, it's worth noting at the bottom, it's all supported via probes for Azure Load Balancer and Application Gateway, but Traffic Manager is supported via HTTP and HTTPS GET requests. As far as endpoints go, that's the other different feature there. Azure Load Balancer supports Azure VMs and Cloud Services role instances. Application Gateway supports any Azure internal IP address, public internet IP address, Azure VM, or Azure Cloud Service. And Traffic Manager supports Azure VMs, Cloud Services again, Azure Web Apps, and external endpoints as well. So that's just a brief summary there of all the different load balancing technologies for you. But that's it for this tutorial section. I encourage you to check out the subsequent demos. In this demonstration, we're now going to go about configuring a load balancer in Azure. So let's head straight over to the Azure portal. Okay, and in the Azure portal, just to set the stage for everything, if we go over to virtual machines, you'll notice that I have 3 virtual machines for this demonstration. I've got a jump box that I can RDP into over a public IP address. I've got 2 virtual machines, SL Test VM01 and SL Test VM02. Both of those VMs are running a simple IIS website. So if I just go into, say, Test VM02, and I'll connect in there. And if I open it up and just type in HTTP localhost, on each VM I've just got a basic web page that's been served up and just identifies the virtual machine. So we'll go back to the Azure portal, and let's now go ahead and create our load balancer. So let's go to create a resource, select networking, select load balancer, and we first have to go about creating the front end portion of the load balancer. So in my case, I'm going to call this SL-internal, because we're going to create an internal load balancer -LB, and I can select here between public and internal. So we're going to choose internal, but let me just go back and show you public for the moment. When I choose public, I can choose a public IP address. This could be one I've already got created, and it can't obviously be associated with another machine already or another load balancer already. And if I want to, I can just go in here and create a new public IP, much like I would anytime I created a public IP address. But I'm going to do this internal for the moment, so let's hit internal. And when I do it as internal, I get a choice of the network. So I'm going to choose my VNet, and I'm going to choose my subnet. In this case, I'm going to choose subnet A, and you can see then I can choose how the IP address is assigned. So I can choose to statically assign the IP and just type it in this box, or I can choose dynamic, and Azure will assign one to the load balancer. Then I've got my subscription and my resource group, much like every other service we create. So I'm going to use SL-network for my resource group, and I'm deploying this in North Central. So that's the front end portion of the load balancer. And if I hit create, and we'll fast forward while that creates, should take just under a minute for it to complete. And that's completed, so we'll go to that resource. And now I can start the back-end portion of the load balancer. So you can see the configuration screen. On the left-hand side, if I select front-end IP configuration, you'll see the IP that's been allocated 10.0.0.7. That's because we made it dynamic. But now I can start configuring these 3 things underneath: the back-end pools, health probes, and the load balancing rules. And I'll do them in that order. So we'll start with back-end pools. And the first thing we need to do is click Add, and give it a name. So we'll just call this SL Web Backend. And now I choose how I want to associate this. So I can select this drop down, and I can associate it with a single virtual machine or a virtual machine scale set, or in my case I'm going to choose an availability set that I already have. Select that drop down, we'll select SLAS-web, that's my availability set with my 2 web servers running in it. Select that, and now this is very important, you need to add your target network IP configuration. So you're going to need to do 2 of these, one for each virtual machine. So we'll select this box, scroll down, choose our target virtual machines. I'll do number 1 first of all. And you can see it's got 1 network interface. And if you hit this drop down, select the IP, and then we'll select add again. And now we will do number 2. select its IP, and go ahead and select OK. And that will now create that backend pool. Just hit refresh. You can see SL Web Backend already there. It's still actually provisioning. So it's got one virtual machine in there now. Refresh again. And there you can see we have two virtual machines. If I expand it out, both of those are running and are in the backend pool. The next thing we need to do now is add our health probes, which essentially monitor the virtual machines and check they're healthy and available. So let's go over to health probes, select add, give it a name, and then choose the protocol that you wish to check for. So in my case, I'm actually going to just select HTTP, and then I could select port 80, give it a path, but these parts are really important at the bottom. The interval is the amount of time between probe attempts in seconds. So every 5 seconds, it's going to check health status. And unhealthy threshold, this is the number of failures that have to occur before it considers the VM behind the load balancer unhealthy and will then take it out of the pool. And that's all that there is to the probe. Go ahead and click OK. Take about 30 seconds or so, wait for this to update before you go on to the next piece. Okay, and as you can see, our probe is now there. It's still updating, so we'll just give that a few more seconds. There we go. And now we go over to load balancing rules. So in load balancing rules, this is where it all comes together. Select add, and now we give it a name. So I'll just call this SLLB rule. And I can choose my IPv version, so 4 or 6. In this case, we're using version 4. But now I select my front-end IP address. So in this case, I choose that one I created previously, 10.0.0.7. I choose my protocol, so in my case, I'm going to use port 80. And then I choose my backend port, followed by my backend pool. So in this case, I'm using that backend pool that I created, SL Web Backend. If I expand that out, you can see that's the only one I've got there, followed by my health probe, which is for port 80, HTTP. Now, if we scroll down, there's a few more settings. For example, session persistence. This allows me to maintain session state based on either the client IP or the client IP combined with the protocol. In addition, I have my idle timeout. And finally, floating IP. This is really for SQL, always on availability groups that you would use this. But if I go ahead and select OK, this is now going to update the load balancer configuration. So again, we'll fast forward here. It's probably take about a minute. Okay, and we can see that that load balancing rule was created successfully. Let's go back to the overview and just grab our IP address, in this case 10.0.0.7, and let's head over to our Jumpbox machine to test it out. And so I'm just going to fast forward here as I RDP into the Jumpbox. It's a VM in the exact same subnet as our test VMs. So we're now in the Jumpbox itself, and let's open up a web browser. And if we type in 10.0.0.7, and that is all there is to it. Both of those VMs are now successfully in an availability set that we created previously when we built the VM, so they're highly available across 2 fault domains, and they are successfully behind a load balancer as well, so traffic is being dispersed between both of them. And with that, this concludes this demonstration. In this demonstration, we're now going to go about configuring an application gateway in the Azure portal. In the portal, much like with the traditional load balancer we configured, go ahead and select Create a Resource, select Networking, and you'll find App Gateway just below Load Balancer there. Now we need to put in our basic settings. Let's give it a name, followed by our tier. So you've got Standard, and then WAF, which stands for Web Application Firewall. Choose your SKU size, depending on the traffic you're expecting, followed by the instance count. The minimum recommended for production workloads is always 2 to ensure high availability. Select your subscription, and select your resource group. One thing we need to take note of though is our location. In this case, we're selecting North Central US. It has to be in the same location as our virtual network and public IP address. So go ahead and select OK. And now we choose some of the more specific settings around our network. So if we choose our virtual network, we'll choose our SL70533-portal that we've been using, and notice that it only gives me the option of subnet B, and this is because we already have systems configured in subnet A, and it has to be in its own subnet. We then choose our IP address type, so we can have public or private again, and if we want to choose our public IP address, we select it here, and we can go ahead and create a brand new public IP address directly from that screen. Our listener configuration, whether it's HTTP traffic or HTTPS, and again we have the option of selecting whether we want to use the web application firewall, but we need to obviously select that tier for that to happen. And with that, simply select OK, confirm the summary, select OK again, Okay, and after a while, if everything's successful, you'll see your application gateway completed and listed on the application gateways. It does take a while. It can take, 15 plus minutes for this to provision. And if we go into this gateway that's provisioned, you'll see this one is actually still updating. So it's still provisioning some of the configuration there. On the screen, you'll get the overview, much like with any Azure service. There is a monitoring pane. You can scroll down. You can see the throughput for the past hour directly on the screen. On the left-hand side, I'll just point out a few configuration areas that are worth noting. One, you can turn on your web application firewall later on if you wish. You can add your backend pools in this location. So I go to backend pools. This is where I can add those. I've got HTTP settings. So I mentioned this is a layer 7 load balancer and gives us some of that extra functionality. So this is where, for example, in this HTTP setting, I can go in there and I can actually turn on cookie-based affinity for HTTP just by selecting this box on the screen. And so there's a number of settings there. If we scroll further down again, you've got your listeners, your rules, and your health probes. All of that is configurable from the section in the Azure portal. And with that, this concludes this demonstration, and hopefully that gives you some insight into how to create and configure your application gateway. Let's begin our journey down domain services now by looking at the three major options you have available when you're trying to deal with authentication in Active Directory. To begin with, we have the new service that Microsoft released with Azure and Office 365, which is Azure AD, also known as AAD or Azure Active Directory. This is the primary mechanism now and should be your first choice generally when trying to develop any new services and use their authentication mechanism. If Azure AD is supported, that is the way of the future. Then we still have Active Directory domain services. This is where you might install a Windows Server 2016 or Windows Server 2012. You might already have one running on premises and you do a DC promo on that server and it sets up your directory service. So if you're in an enterprise, you probably used to log in on your laptop and you authenticate. You're authenticating against Active Directory when you do this. Then we've got Azure Active Directory Domain Services, AADDS. Now this is a little bit different. This is where we actually have a managed version of Active Directory Domain Services. And we'll go into all three of these in a little bit more detail, but it's very important to be clear about which one you're talking about whenever you're dealing with Active Directory services in Azure. So let's take a look at Azure Active Directory in a little bit more detail. Again, that's AAD and has the icon depicted on the right-hand side. This is the modern AD service built directly for the cloud. It's often the same as your O365 directory. So if you have O365 already, you probably already have Azure AD and a tenant there. That's probably what you're going to use in your enterprise. You don't have to necessarily create a new directory service. It can sync with the on-premises directory service as well. And it's very important, as you'll see when we cover AD Connect Sync shortly. Then we've got Active Directory Domain Services. So again, this is a Windows server with Active Directory Domain Services role installed on it. This is legacy Active Directory since Windows 2000. It's your traditional Kerberos and LDAP functionality that you might need. And it's deployed on Windows OSs, usually on virtual machines. So, it can be still physical in some environments today, but for the most part, most people deploy it on a virtual machine. Then we go into Azure Active Directory Domain Services, AADDS. And this is a managed version of the predecessor we just looked at. So Active Directory Domain Services, if we want that fully managed for us, Microsoft will build that domain controller and maintain it. That's what Azure Active Directory Domain Services are. It allows you to consume domain services then without the need to patch and maintain domain controllers. So that's the single best benefit of this, is maintaining a whole directory services infrastructure can be quite a bit of work. Yeah, that's taken care of for you. The one thing to note, this does allow then domain join, group policy, LDAP, Kerberos, NTLM, all of that is supported. Again, you don't have to manage it. So this is especially good for people that aren't familiar with Active Directory Domain Services. They can simply go in and set up AADDS and get that functionality provided to them as a PaaS service in Azure. To begin our journey down identity, let's take a quick look at Azure AD as a whole. And you might have seen this image before, which you can find at the link below, where Microsoft has a pretty good write-up on Azure AD fundamentals. But to begin with, Azure AD is really becoming the center of the identity world. You can kind of see it there in the middle of the picture. On the left-hand side, we have on-premises, because people traditionally had Windows Server Active Directory, sometimes known as Active Directory Domain Services, on-premises, other directories and things that they may have historically used. A lot of those directories are on-premises, and now in the public cloud, SaaS-based world, we've got all these other solutions running out there, whether it's ServiceNow, Salesforce, etc. And, identity sprawl was just becoming a big problem. People had identities in their business and then had that same identity in another business. Take an example, when you onboard somebody from a customer and you create a new user for them. Well, what if you could just trust the identity that they've already got and the authentication mechanisms that they're already using? And so Azure AD ultimately was a solution to that. How do we sync up with our identity on premises, as well as, enable collaboration from a consumer and a business perspective with identities securities, with other businesses that we deal with and consumers that we deal with. And at the heart of it also is three things: simple connection, self-service, and single sign-on. In fact, if we look at the Azure AD features in a little bit more detail, aside from being that enterprise identity solution, that single identity to keep, users and groups and everything all in sync across your enterprise, that's point number one. Adding single sign-on provides the ability to have single sign-on to apps and services. We don't have to go sign on again and again every time we want to access something. If there's applications we access, we've been given permissions to access them. We've already signed in when we logged in with our laptop, and maybe we use some kind of Face ID and other authentication on top of just a password. That's kind of there for you. And then we've got multi-factor authentication, as I was kind of just alluding to there. It's one thing to have a password. That's something I know. What about something that I have? Maybe that's a cell phone where I get the text message and I can key in that code. Maybe it's some biometrics, things like that. That just enhances security. So when we think of single sign-on, multi-factor, they're both great things because I've got multiple ways to authenticate. And then once I'm authenticated, I'm signed on, and now I can access all my apps and infrastructure services that I need. And finally, just that self-service empowerment to the users. Nothing more annoying than getting password reset calls day in, day out. We can empower users to do self-service password reset, but also empower them to, access the apps and the services they need. They can go to like a My Apps portal and request what they need. And so all of this comes together and is ultimately why Azure AD is so important, and particularly as it relates to Azure. You're using Azure AD potentially for Office 365 and other things already. When it comes to Azure, now we're able to use that same identity solution and give it permissions in the Azure world. And so you'll see in the upcoming demo, we'll create a new Azure AD tenant and then go from there, show you how to create users, groups, etc. In this demonstration, we're now going to look at creating a brand new Azure Active Directory tenant from the Azure portal. So let's head over there to begin. And in the Azure portal, the first thing to note is on the top right, when you log into Azure, you're logging in with your account, and you can see it's associated with AZ Exam. If I click this other icon, Directory plus Subscription, and I go to the bottom here, I can see all the directories that I have access to with that account. So in my case, this account originally was only associated with this one directory, the default directory, ncolialive.onmicrosoft.com. If you create a brand new account, you'll see something similar based on your name that you've keyed in. And I've gone ahead and created this additional AD tenant, AZ Exam, which is what I use for a lot of the demos now going forward, as well as other domains that you may have seen in previous demos. But if I go ahead and go over to Azure Active Directory on the left-hand side, and if you don't have it in your favorites bar, the other way you can access it is by clicking All Services and then searching for Azure Active Directory. But in a moment, it'll pop up with our Azure Active Directory menu blade. Okay, and once that's up, you can see, again, azexamdemo.onmicrosoft.com, the domain AZ Exam, and I'm currently using the free tier of Azure Active Directory. And you will notice for some services that you try to do, if you're playing around with them, there's also the concept of these Azure AD Premium P1 or P2 licenses, and you can grab a free trial if you're experimenting with things in there. But for right now, if we want to create a new directory, what I need to do is on the right-hand side, scroll down, and you'll see an area, Create a Directory. If we click that, that allows us to give a new organization name. So perhaps I'm going to call this AZ Exam Test, just to distinguish it differently from the one I already have. And I'm going to call it AZ Exam Test.onmicrosoft.com, and that is available. Now those are globally unique, so if you try to do something that somebody else already has, it's not going to let you do that. It does need to be completely unique on the onmicrosoft.com domain, and then choose the country that we will create it in, and then go ahead and click create, and that will take about a minute to get that directory created. So we will fast forward here while that completes. Okay, and after a while that notification pops up and the directory is created. Now what I need to do, if I click the directories and subscriptions filter and scroll down, might have to just refresh it if it's not showing correctly. So just refresh your portal and then click that again. And you can see we now have AZ Exam, which is the current one that I'm in, and this new one, AZ Exam Test. Now, something important to bear in mind, if I click AZ Exam Test, it's now going to switch over to that AD tenant. I'll need to log in with my account. And then if I go in here and go down to subscriptions, which I might need to add back, so go back to all services and just add subscriptions back to your favorites and click subscriptions. And what you'll notice straight away is I don't have any subscription yet, because that original subscription I've got is only associated with that other Azure AD domain. Now that's not to say I can't give, additional subscriptions to additional domains. I can certainly have lots of domains with lots of subscriptions, but the subscription has one unique domain that it is associated with. If I want to give somebody access to that subscription from the other domain, they could be a user in this domain. I would need to trust them and grant them access to the other subscription, but I can't reassociate that subscription with this domain. So something, again, just keep in mind of and really, hit home on is subscription is a one-to-one mapping with that Azure AD tenant specifically. The other things to just keep in mind, if we go back to Azure Active Directory, you will see users and groups, which we're going to cover in the next demonstration, but there is a role, an administrator, that is created already for you. If I go down to Global Administrator, this user is created automatically, and this is, my user account. That is the global administrator for that specific domain. That's essentially, the ultimate rights for that domain, and you can, give out additional global admin rights to other people as needed, but that's created for you automatically, which makes sense. The first person to create the Azure AD tenant needs to be the global administrator. Think of that as just as important as if you have legacy Active Directory. That was kind of your AD administrator. You had very few people you'd give those rights to because they, need to be kept very, very secure. But with that concludes this demonstration. If you need to head back, simply click the directory and subscription again, go back to your other domain if you've got one, and then if you want to delete that other domain, just go back there and delete it directly from Azure AD as well. But that's how you go about creating your new Azure AD tenant. In this demonstration, now that you know how to create an Azure AD tenant, it often makes sense to then know how do I create users and groups in that tenant. So we'll head over to the Azure portal to get started. And in the portal, let's head straight over to Azure Active Directory. So we'll click that. If you don't have it in favorites, again, just click All Services and type Azure Active Directory and it will come up for you. And you can see we're in azexamdemo.onmicrosoft.com, the short name being AZ Exam. Now I can go ahead on the left-hand side and click Users, and this is where I create new users in my directory, and I can see the users that are already in there. So I can go ahead and click New User, and let's call this one John Smith. Very unique, I know, and that can be J Smith at. Now this is important. If you just do azexam.onmicrosoft.com, you'll notice it won't actually work. It'll give us a little error, and that's because if we again go back to the directory, you'll see it's azexamdemo.onmicrosoft.com is the full name for that specific tenant. So if we just add demo to that, we will then get the green check and everything is good to proceed. For profile, this is just work data, first name, last name, job title, department, etc. Properties you won't need to go into. That's just around the source of authority. So in this case, Azure Active Directory, nothing you need to configure there. And groups will come back to after we've created the specific user here. And this is important, the directory role. So what role do we want to give them inside of Azure Active Directory? They can be a user, or they could be a global administrator or limited administrator. And you can learn more about directory roles, by clicking the link right here, and that'll get you some more information on the different role types available to you. Then we go ahead and you can look at the password if you're just trying to give it to somebody that's, say, right next to you, or if you're going to email it off. But you can see it there and you can copy it and paste it out to give to that person. They will be prompted to change it after logging in for the first time. But you click create and that goes ahead and creates that user, and then we see John Smith, is there and, ready and available. If I refresh now as well, you'll see the source isn't updated straight away. If we go back into users now, John Smith, you can see the source is Azure Active Directory. And you also see that some other sources can be like a Microsoft account. In fact, if I do a new guest user, I can give an email address here, and I can also say invite somebody, perhaps my Gmail, so nickcollier@gmail.com, come join my AD tenant, and that will actually send an invitation out to me personally at my email address and allow me to log in as a guest user as well. And you'll see that user type then appears as a guest. But that's it for users specifically there. That's how we create them. If we go back to the AZ Exam tenant and click groups now, this is where I can go ahead and start to create groups of users. So perhaps I want to create a Azure Administrator group. I'm going to create a security group. I'm not going to create an Office 365 group. This is for security access to Azure AD. I'll call this my Azure Admins team, or the Azure Admins as an example. And then I can go ahead and say this is assigned, click the members, and basically you'll see them all listed here along with other service accounts that are there as well. I can simply type in John and you'll see John Smith is there. Click that name, click select, click create, and that's going to go ahead and create that group and include John Smith already in there. Well, how do I actually assign permissions to that person? Well, that's all done using RBAC, as you might have seen already if you jump to that section. So we can go back to, say, our Azure subscription. If I click it down here, go in and select the Visual Studio Enterprise subscription I have, click access control, and then go ahead and add a role assignment. So this is where I assign rights and scope them to specific objects again. So I can scroll through here and I can choose the Azure Admins team, or I could still choose John Smith directly if I wanted to. But let's say I just want to assign it to the group. This way, every time I want to give somebody access, let's say this could be subscription owner access. So click the role. I would choose owner. This is, complete rights to the subscription. I'm assigning it to that group, and anybody I put in that group will be given access to the subscription. So certainly something You wouldn't want to just give out, randomly to people. The subscription rights are obviously very, very important, but you also saw from resource groups, you can assign rights specifically at a resource group. You might want to group people by department. You might want to group them by, geography. You might want to group them, by their business division, all sorts of things that you can basically do to, carve out the rights and roles that make, the most sense for your organization. And with that, that concludes this demonstration and hopefully gives you an insight into how you create users and groups into Azure AD. Okay, it's time for us to look at configuring self-service password reset in Azure. So let's head over to the portal. And the first thing you'll notice is I'm not in that same Azure AD directory that we created previously. And that's because you do need a P2 premium trial in order to do this demonstration. I've already used up my trial there, but I do have a P2 license in this particular Azure AD. Now, you can go ahead and just create one trial that should work fine for you. It'll prompt you when you try to do this. But if I go to password reset, in this directory, you can see, first of all, this section is around who do I want to configure self-service password reset for. I can choose none, select it, in which case I select specific groups, or everyone. So I'm not going to do that right now. I want to show you more around just the methods and the options available for it. So this is really, really important because let's say you give somebody the ability to reset their password, well, you can choose the number of methods they're required. So 1 or 2 here, and you can see the options. So mobile app code, it's in preview, and mobile app notification, both need preview options there that work with a mobile app. But the common ones are email, mobile phone, office phone, security questions. And you can say, okay, 1 email is enough. So, they'll get the email to click confirm to make sure they're authenticated, or you could require 2. So email and perhaps a text message to a mobile phone. That's what this is all about at this point. In addition, we've got this registration section, so require users to register when signing in, which we would want, obviously, and a number of days before users are asked to reconfirm their authentication information. So you want to make sure that authentication information is up to date. People change email addresses and things like that they might be using for authentication. Phone numbers, all that kind of stuff is really what that's about. And that's really all there is to it. Once we've kind of got that configured, then we have a web page that the users can go to in order to reset their password. Essentially the user will get a prompt when they're trying to log in. They can click the link, or you can simply go to aka.ms/sspr, and that will take them to a page where they can put in their user ID, put in some characters here. It'll prompt them for those questions and allow them to reset their password. Now, flipping back to the portal and clicking properties, you can see here I've enabled self-service password reset, and I want you to see what it looks like when you actually go ahead and do that, and what the user's prompted for the next time. If I go over to this other tab that I've already gone ahead and selected, you can see more information required. And so I'm required to go in here and actually set up authentication. I've already done my telephone there, so I'm just going to blur that out, and I just need to do my email as well. So basically I type in an email address, it'll send me a code, and then I punch that code in here once it comes through on my phone. By phone, I mean I'm receiving an email on Gmail on my phone there, so I'm going to input that code. And then both of those authentication methods are verified, so I click finish. And now I've actually set up self-service password reset for my account. So now I can go to that web page and do the reset, and it will actually work for me. A few other quick settings though, just notifications. Notify users on password resets, always a good thing to keep on. And if you're having trouble in particular, with admins or something going on in your environment, you can also notify all admins when other admins reset their password. So if you just want to be in a very high security profile for a while and just know anytime an admin resets, if you're concerned about an attack or something, it might be good to turn that on. Otherwise, it's honestly just a lot of noise otherwise for most people. There is lastly a customization section here, so you can customize that help desk link if you want to, and the help desk email as well. And with that, that concludes this demonstration and hopefully gives you an idea of where you go to do self-service password reset. Before we end off this lecture series, we do need to understand the different editions that Azure Active Directory pricing comes in, and you can use this link on the top of the screen that you can see we're already in, and it will also be noted in the accompanying study guide as well. But it comes in 4 editions: free, basic, premium P1, and premium P2 that you can choose between. Now, the big differences between them that you need to be aware of, first of all, the free version has a 500,000 object limit. There's no object limit in the basic premium P1 and P2 versions. If we scroll further down, under single sign-on, you can note that the free version only allows 10 apps, as does the basic one, 10 apps per user. And the P1, there's no limit, and the P2, there's no limit. So as soon as you get into the premium ones, single sign-on can go more than 10 apps is the way to kind of think about that. If we scroll further down again, you will see that the free version does not give any of the group-based access management provisioning, self-service password reset, company branding, all of that. None of that's available in the free version. And now let's scroll down. You'll see the section called premium features. And you've got things like advanced group features, self-service reset, change, unlock with on-premises write-back. That's that password write-back we talked about in the tutorials. Device objects we talked about in the tutorials. Multi-factor authentication. See, all these features we were going through are mostly premium features. If we scroll further down, and definitely become aware of this list, but I want you to be aware of what's different in P2. And so we have things like identity protection. So this is where Azure is actually using threat intelligence to help protect your identity. Privileged identity management is the big one. And this allows us to give perhaps roles that we want people to impersonate when they want to elevate their credentials. So for example, perhaps we've got an administrator role in Azure, but we don't want to just give that out to everybody as standard. We give them a normal user role that they can't do too much with. And when they have a task that needs a role that gives more permissions, as you probably saw in the RBAC section of the course, well, privileged identity management allows that person to say, okay, I want to be this higher level role, do my work, and then when I'm done, it sets me back to my standard role. And so that's a key one there. In fact, those two are in particular are key: identity protection and privileged identity management, as well as if we need to integrate with third-party MFA partners as well would be another good one to remember for the exam. In the exam, you're going to get a lot of story questions, and they'll generally be around these particular limits. So I'd say look at the object count in particular, and then know the differences between premium and the standard versions, and then know the difference between premium P2 and premium P1. As you saw from the previous module, there are a lot of directory services to think about, and often we already have something on premises. We probably have that on-premises Active Directory controller running on Windows Server 2012 or 2016, and we don't really want to create a whole new source of truth when we move in towards Azure Active Directory. Perhaps we already have started some of this when we do O365, but if we're starting out fresh, we need to make sure they remain in sync, and that's where Azure AD Connect really comes in. And so Azure AD Connect has a number of components. First of all, it has synchronization services. This component is what's responsible for creating the users, groups, and other objects in Azure Active Directory. It's also responsible for making sure identity information for your on-premises users and groups is completely matching the cloud. What we don't want is a complete mismatch there, because then everything gets out of sync and gets very, very complicated. It also has an option for Active Directory Federation services. This is optional. And Federation really allows us to configure a hybrid environment using an on-premises ADFS infrastructure. And this can be used by organizations to address more complex type deployments, such as domain join SSO, or perhaps we have third-party MFA solutions. MFA is multi-factor authentication that you'll hear about soon. Perhaps with smart card solutions, things like that we need to integrate with. We might need to use Active Directory Federation services. And then finally, we have health monitoring. This is called Azure AD Connect Health, which you'll see in the third module in this section of the course. And this provides robust monitoring. It provides a central location in Azure for you to view all your health activity and making sure that your domains are all in sync and there's no issues. It helps now to take a look at some of those AD Connect sync features in particular. And first of all, we have the concept of filtering. And this is used when you want to limit which objects are synchronized to Azure Active Directory. By default, all users, contacts, groups, and Windows 10 computers only are synchronized. And you can change this filtering based on domains, organizational units, or other attributes if you want to. We then have the concept of password hash synchronization. And this synchronizes the password hash in your on-premises Active Directory up to Azure AD. So the end user can use the same password on-premises and in the cloud, but they only have to manage it in one location. Since it uses your on-premises Active Directory as the authority, you can also use your own password policy that you decide to implement in your on-premises Active Directory. And this comes up a lot when clients are sometimes using password policies that are in, say, Active Directory domain services from Azure. That's the managed Azure AD domain services, to be specific. It may not give you the same password policy features. Whereas when you use an AD Connect sync, if you've got a password policy on premises, that will carry over to Azure AD. We then have the concept of password write-back, which will allow your users to change and reset their passwords in the cloud, and this will write back to on-premises. We have the concept of device write-back, which will allow a registered device in Azure AD to be written back to your on-premises Active Directory, so it can be used for conditional access. We have prevent accidental deletes, which is turned on by default, and this protects your cloud directory from numerous deletes at the same time. So by default, it allows 500 deletes per run, and you can change the setting depending on your organization size. And finally, great feature, obviously, automatic upgrade enabled by default for all the express setting installations, and this ensures your Azure AD Connect infrastructure is always up to date with the latest release. You don't have to worry about going ahead and updating any of that. Now, before we wrap up, make sure you understand the different password sync options, and there are three major ones. So we have password sync, and this is where we're ensuring that user passwords are the same in both directories, Active Directory domain services and Azure AD. An alternative is we have pass-through authentication. This is where we authenticate, and instead of Azure AD Authenticate, it actually passes that request onto the ADDS server, gets the approval, sends it back to the user that way. So essentially a single source being ADDS. And finally, we have ADFS, which is using Active Directory Federation services to fully federate across ADDS and Azure AD, along with other services. So perhaps you might have ServiceNow as an example, as a SaaS service a lot of people use for ticketing, things like that. Perhaps that's using ADFS and is federated with your Active Directory domain service. So just make sure you understand these three. And with that, this concludes this part of the module. Okay, with the tutorials out the way, now we want to actually go ahead and connect a Active Directory domain services forest to Azure Active Directory. So to set the stage, let's go over to my domain controller that I've already created. So let's RDP into that. And you can see that we're RDP'd in here, and I've created a new user in this domain called student demo. So first name student, last name demo, and that's all running in here, and I'm just RDP'd into the domain controller. Setting up a domain controller is outside of scope for this course, but if you are having trouble with that, simply search for Active Directory domain services. You'll basically build a Windows server, and then you'll do what's called a DC promo to create your new Active Directory forest on that particular server. So let's go ahead and now and do AD Connect. So let's go over to Google Chrome on this machine, and you can see we're in Azure, and I want to now synchronize those users from my on-premises Active Directory up to this Azure Active Directory. So to do that, let's scroll down on the left-hand side, and you'll see a section called Azure AD Connect. Select that, and you can see that sync status not installed, but we can go ahead and click Download Azure AD Connect. Okay, that download's complete, so let's go ahead and run that. Okay, and after a little while that pops up. If we click this icon on the bottom, you'll see the wizard, and you can see there, welcome to Azure AD Connect, run this installation tool on the server where the synchronization service component will be installed. So I'm already on my domain controller. I accessed Azure through Google Chrome on that domain controller, so I downloaded it straight to the machine I want. So I agree to the license terms and privacy notice, click continue, and you can see that because I've only got a single Windows Server Active Directory forest, I can use express settings for that, and you can see that it's going to configure synchronization of identities in the current AD forest. So we'll go ahead and click use express settings, and then I need to give a global administrator. So this is a user in Azure AD, that's a global admin. So I created one before as well in this new domain called John Smith, so we will key him in here. And once complete, simply click Next. If there's any problem, it will let you know straight away there if that user isn't authenticated. And now I need to give some credentials for a local user that's a domain admin on the local machine, the domain controller itself. Again, click Next once you've inputted that. Now when we get to the screen, you can see we have Azure AD signing configuration. So I'm going to continue. I'm going to say, yep, I want to continue without any verified domains. Go ahead and click Next, and everything will continue and start synchronization as soon as configuration completes. We'll check that and click Install, and everything will go ahead and install now, and then it will begin synchronizing those users. So I should see that student demo user appear in Azure Active Directory when all is complete. Okay, and after 5 or so minutes that completed successfully, and I'm going to go ahead and click Exit, and let's take a look now at Azure AD Connect in the portal itself. Let's do a refresh here, so let's go back up to the top. Scroll back down to Azure AD Connect, and we can see that sync status is enabled. Last sync was less than an hour ago. Password sync is enabled as well. And you can see user sign-in though, federation disabled, seamless single sign-on disabled, and pass-through authentication are disabled. Now if I go over to my users in Azure AD, I should see that new user. There it is. Yep, student demo is now available in Azure Active Directory. And you can see the source there, which is Windows Server AD, as opposed to these other user accounts which were created directly in Azure Active Directory. So you can see very easily, installing AD Connect, great way to simply synchronize all your users from Azure Active Directories that you might already have on premises, or even ones that you may provision directly in the cloud because perhaps you have some legacy applications that rely on Active Directory domain services and they don't fully support Azure AD domain services or Azure Active Directory. So with that, this concludes this demonstration and hopefully gives you that good insight into AD Connect. In this demonstration, we're going to now take a quick tour of Azure AD Connect Health so we can get status on our sync and our domain controllers that we're syncing with Azure AD. So to begin with, we'll head back over to our domain controller that's connected to Azure AD via AD Connect. So here we are in that domain controller again, and we're still logged into Azure through our Chrome browser on that domain controller, and you can see our sync status is still enabled. I last synced less than an hour ago, so everything's still in working order there. But if we want to get some more detail, we can scroll down and see at the bottom there's this feature called AD Connect Health under Health and Analytics. And this allows us to do two things. It allows us to monitor the synchronization service as well as the on-premises infrastructure as well. So if we click AD Connect Health, this will take us to the dashboard, and you'll see there this quick start item that we'll go to in a minute. But also here's the status of our Azure Active Directory Connect sync. So providing we did that AD Connect that we did, we get in status there, and if anything is wrong, we'll be notified at this point. If we had federation services, we would need to install an additional item, and that would give us results and analytics around AD federation services. And same for Active Directory domain services. If we want more information, we do need to install an additional piece for that. At the bottom, there are some other settings like general settings for auto update and users and groups as well. From a role-based access control perspective, you can get here also. But if we go back to Azure AD Connect Health and scroll to the top, and let's hit this quick start item, and on the right hand side you'll see, if we scroll further down, this option to download and install Azure AD Connect Health agents so we can get health and usage information for our on-premises services. So first one, download Azure AD Connect Health for ADFS. We're not going to do that in this demo because we don't have ADFS configured. We've already done the download of Azure AD Connect, which we used when we did the sync, but we can go ahead and grab this one, download Azure AD Connect Health for ADDS. So let's grab this one. That will now download, and we'll go ahead and run that. And click Run, and click Install. It'll validate all the prerequisites there. Okay, and that setup is successful. Let's go ahead and configure it. You'll see a bunch of PowerShell scripts execute. We will get an authentication window for us to sign into Azure. So we'll go ahead and do that again. And then once complete, you should get this message at the end, started agent services successfully, and then agent registration completed successfully. And so that's all now in working order. So now if we go over to Azure AD again, let's close these down and have a look at Azure Active Directory. Go down to AD Connect. Okay, everything's still synced there, and scroll to the bottom, select AD Connect Health. And if we scroll to the bottom now, we can see we also have health status for our Active Directory domain services as well. And if we click into that one, we just get some details. We've only got the one for us. And we can see things like replication status, operations, alerts, etc. We can go and click into alerts if there were any there. They would appear over here, and then we can give a time range. And if we want to send notifications out, we can do it from this notification section as well. So as you can see, AD Connect Health, really three things to it. Monitors the AD Connect sync, Active Directory Federation services, and Active Directory domain services. It can give us health for that as well. And with that, this concludes this demonstration. So in the previous demos, we looked a lot at Active Directory domain services, which we traditionally set up on a Windows VM, essentially in an IaaS configuration. But what if you need the features of legacy type domain services but don't really want the effort of managing a domain controller? Well, to some extent, Azure has a feature called Azure Active Directory Domain Services that includes probably about 80 to 90% of the features that you'll probably need from the legacy AD domain services options. And this is essentially that managed service that Azure provides for you. So instead of us having the VMs that we have to provision and build the domain and then sync those users up, we're going to do something slightly in reverse here. We're going to take our Azure Active Directory and create Azure Active Directory domain services from that. So to begin with, let's head over to the portal and take a look around. And in the portal, the very first thing we need to look at are our networks. So if I go into virtual networks, you'll see I've just got one VNet, but if I go into that VNet, you'll see there's a default subnet. If I go down to subnet, and I've got the default subnet, and then you can see I've already created one for domain services. So I've got a 10.0.4.0/24 for all of my VMs I'm using for this demo, and then for domain services 10.0.5.0/24. And that's because it's recommended that you put Azure AD domain services in its own subnet. You know, this is all going to be managed all directly from Azure, so they like it to be there. So to get started, I've got a VM that's just built. So if we go to virtual machines, you'll see we have generic VM01, which is the VM we will join to the domain once we provision Azure AD domain services. But to get Azure AD domain services up, I simply select create a resource, and we'll type in Azure AD, We can see Azure AD domain services are there. Let's go ahead and select create. And we're going to use an existing resource group, which we have for identity, and put that in Central US and go ahead and click OK. Select our network. So we've only got the one network, and then we will select that domain services subnet that I've already created. Click OK. Administrative group. So if we select this, you can see this is the AADDC administrators group, and they will have privileges to manage this domain. So if I click this one, you can see I've got myself in there right now. I'm going to be the member that has the domain admin rights to the domain. So we'll click OK on that, but I could add additional members if I wanted to. But with that, that's everything I need to type in, and I can go ahead and click OK, and it will go ahead and start provisioning that managed domain services environment for me. And I'll fast forward here while that completes. Okay, and after 20 minutes or so that's completed, that domain is provisioned. The last step you do need to complete is grab these DNS servers. I've got 10.0.5.4 and 5.5, and we just need to go over to our virtual network and update those DNS servers. So I can click configure DNS servers, go into custom, and go ahead and put the first DNS server in there, put the second one in, and click save. And that's now saving and updating the network. So DNS for those networks will point to these domain controllers. And that's it for setting up AD domain services. The last thing we need to do is simply go over to a virtual machine and join it to the domain. Let's take a minute now to talk about single sign-on, which you probably use a lot in your everyday life, particularly in your IT world. And in Azure, this is provided by Azure AD Connect for users using password sync or pass-through authentication. It does require a company device with a modern browser in order for this to actually work. But essentially what it's allowing you to do, if you turn this on, is you can authenticate to your laptop with your Active Directory domain services credentials, and then you're no longer required to authenticate with Azure AD. It's associated that Azure AD account with your ADDS account. And so when you're in your browser already knows, okay, this person's already logged on locally onto the machine. I don't need to prompt them again in the web browser. I can just pass through that authentication. Now, it's important not to confuse single sign-on with multi-factor authentication, as they serve two different purposes. Single sign-on is about signing on once and then being allowed access to all of my services. Multi-factor authentication is about checking to make sure I am who I say I am. And it works by requiring two or more of the following verification methods. So your common one, something you know, like your password. You go to a website, you type your password in, that's something you know, that's something you remember, and that authenticates you. But that's not necessarily enough on its own. In fact, in modern security practices, we just assume that passwords will get compromised at some point. So we move on to something else. Something you have is one example. So perhaps a cell phone that you have on you where you can get a text message or a phone call, or perhaps something you are. So biometrics are a really good security mechanism here, where perhaps you use a fingerprint reader and that verifies you are who you say you are. But one alone is not enough. Multi-factor authentication is all about what it says, multi-factor. So you might have your password plus the biometrics, or your password plus the text message, and then that will authenticate you onto the system. And then you're signed on. Now you have access to all of your services via single sign-on. It's important then to understand the different verification methods available. First of all, we have a phone call. This is where a call is placed to the registered phone number of the user. They might be required to enter a PIN or just press pound on their phone to verify they are who they say they are. That's one option there. Text message, again, the common one we talked about, Google being classic example, sign in, get the text message, enter the code, move on. Mobile app notification, this is a great one where you might, instead of getting a text message, just go onto an app, approve the request, and everything moves forward. Mobile app verification code, this is where the mobile app, which is running on a smartphone, displays a code that changes every 30 seconds, and the user finds the most recent code and enters it on the sign-in page. So a little bit different to the text message. The app is actually spinning through, and every 30 seconds it shows you a different code, and then you put that code in, and then finally this third-party solutions you can integrate with as well. So with that, this concludes this section on MFA and single sign-on. I definitely encourage you just turn on MFA in the portal and it'll show you very easily how it works, and you can set it up to just get a text message on your phone when you're signing into Azure, and that should make it pretty clear for you. It helps to also understand some of the other mechanisms for securely authenticating users. And these could be from a business-to-business perspective or business-to-consumer perspective. And we'll start here with the business-to-consumer. And this is where a user tries to log into, say, an application. Perhaps you've designed a new web app, but instead of requiring, a whole new identity to be created, you might still offer that, but you could offer them, log in as Google, log in as Facebook. Those are things you've probably seen as you browse the web. Well, Azure AD B2C is the mechanism by which you do this. It's a cloud identity solution built for web and mobile applications, and it's highly scalable to hundreds of millions of identities. It works by enabling authentication for social accounts and enterprise accounts. And so you can bring those accounts into Azure AD B2C and then associate them with your application. So you can use those authentication mechanisms you see on the right-hand side without you having to manage, that user saying they are who they say they are. You rely on those services to do it. You then decide what the user can access once they've authenticated with one of those services. And that's B2C. So that's a consumer-driven option. Then we've got B2B, which is business to business. And this is a little bit different. And this really allows us to work with other partners. So it allows us to collaborate with partners outside of our organization. Users basically receive an email with a confirmation link upon invitation. And then imported users are Azure AD external user objects. So that's the difference. The authentication is all happening at the other, company's Azure AD. But now there are external user objects that we've imported in because we've got this trust relationship with our partner. Then they have access to shared apps, resources, documents, etc., whatever we decide once they're authenticated. A little bit similar to the B2C option, but again, we're using a partner relationship here to do it. Partners access with their own credentials. So again, we're not managing that identity. They own the credentials, we don't, but they get enterprise level security because it's still Azure AD. They're still using Azure AD on their side. We still have the ability to decide what they can do once they're in our system. And that's B2B and B2C in a nutshell for you.
Let's now look at one of the security features that we highly recommend people implement in their organization, and it's known as Privileged Identity Management, also known as PIM for short. And the way it works is as follows. Essentially, you have your users in your environment and they access various things. They could be accessing Azure AD for user administration. They could be accessing Azure resources in your subscription. There's a whole bunch of things, SaaS apps, Office 365, etc., that are all tied to that identity. Well, the key thing with a privileged identity is this is a user that essentially has some admin roles. They're a privileged user. They have a lot of access and essentially create a risk for the organization. And so privileged identity management is a way that we can manage these privileged users, put some control around them, put some visibility around them so that we know what's going on with those users. Now, the key features of Azure PIM are as follows. It gives us visibility into users with privileged access. So the first time you turn it on, you can then do a discovery to see, well, who in my organization has a lot of access? Who should I be concerned about? This can be for Azure resources or Azure AD. So we always make that distinction. Azure resources are things in your subscription where a lot of RBAC roles are applied, like subscription owner. Azure AD is things like our global admin, for example, that has a lot of rights to administer our directory service. We can enable things like on-demand administrative access. We can view administrator history, so that includes not just what they accessed, but the rights they gave out and things like that as well. We can set up alerts, and finally, we can also do something which is really cool, which is require approvals via workflows. So when somebody requests additional access, it can go to a workflow. Perhaps a certain person in security has to approve that access, review it, check the reason they submitted, and then things can move forward. Now, the PIM process is as follows. Essentially, again, you've got your user that has some level of access by default, but we don't give them that full subscription owner or global admin rights initially out of the gate. They have to go through an activation process, and we can decide what's required as part of that activation. For example, they could be required to authenticate via multi-factor authentication. So a token comes to the phone that they will authorize, or perhaps they'll get a text message, etc. They could also go through an approval workflow. And this means, again, we could send that, requirement onto a manager or somebody in security for approval to say, yep, okay, I'm going to authorize this. And we can also put time restrictions on this. So this might just be, hey, I need access for a couple hours to do some work in Azure AD as a global admin. And then once I've completed that, that access can be removed. But once the activation process is completed, essentially I have my activated user ready to do their work, either, in Azure with RBAC roles or Azure AD, as potentially a global admin or some other role that they might need, in Azure AD. Now, there are some PIM requirements you need to be aware of. Well, first of all, you do need an Azure AD P2 license. Now, if you are following this through and trying to do this yourself and you've got a trial account, you may have some different mileage depending on, any restrictions on your account. But let's just say you have a normal trial account. You will be able to select to start a free trial in the portal itself. And then it will prompt you for these two options, enterprise mobility and security. That includes the P2 license, as well as additional features that Microsoft will let you try out. Or you can just do a free trial for the Azure AD Premium P2. Either way is fine. You can click the more information pieces there, and that will, give you more information on those different licensing models. But essentially, this is licensing that is related to Azure Active Directory that you need to be concerned with. Now, you might be wondering, well, who needs a license? Because you don't have to assign a P2 license to every user, but essentially anyone that's going to be assigned the privileged role admin that you'll hear more about, anyone that's going to be signed as an eligible admin, so if they want to elevate into a role, anyone that's basically going to use just-in-time access or direct time-based assignment, or users that need to approve and reject PIM requests. So even if a user maybe doesn't need to elevate permissions, but they're on the approval workflow, then they will require the P2 license. So just something to keep in mind there. Now, when we look at the roles, there's two new roles essentially that you need to be aware of. You have a privileged role administrator. That person can manage role assignments in Azure AD and everything to do with privileged identity management. And then we have the security administrator as well, and they can read security information, reports, configuration, etc. Now, it's key also to remember here, when you start this off, you have to be a global admin in order to set up PIM, which you'll see in the subsequent demonstration. Now, that global admin will become the security admin and will inherit the privileged role admin role as well. Now, this account that enables PIM is the only account that can manage PIM unless you give it out to other global administrators. So it is really important, not to basically just create the PIM role and then forget about it in your organization. You want to make sure that you give this out to somebody else so somebody else can manage PIM as well. And only privileged role administrators can manage Azure AD directory role assignment of users. So it's a very important role. We got a global admin today, and now we're sort of adding this new role around PIM. We have to make sure we manage the people that can manage privileged role administration as well. Now, you've heard me mention a few times this concept of assigned roles, and we have directory roles or resource roles. Well, why do we draw this distinction? Well, the directory roles are Azure Active Directory roles. These could be your global administrator. These are roles pertaining to Azure AD, and they can be eligible or permanent roles. So an eligible role, again, is a role where somebody can elevate into that permission, or a permanent role is, you sign the role and you make it permanent or potentially even time-based as well. Now, the resource roles are Azure RBAC roles. These can be your built-in roles, such as subscription admin, virtual machine administrator, contributor roles, etc. They can also be custom roles that you've defined in Azure RBAC that you want to allow users to have, and then you can have users elevate into those particular roles as well. Very common one is obviously the subscription admin. A lot of times people turn on PIM, and the very first step is to see, well, who has access to subscription admin. Same on the directory role. How many global admins are out there? These are the roles that you really want to get your hands around very, very quickly. Now, on the Microsoft documentation for privileged identity management, they do have a recommended process that you follow when you're starting out with PIM. And that's essentially these 4 stages. Stage 1, 24 to 48 hours. You want to take care of the critical items that you need to do right away. These are things like that subscription admin, global admin, doing an audit of accounts, getting some visibility into what's going on in your environment. Take care of anything critical where you think, hey, I've got some major security holes here. Then we move on next 2 to 4 weeks, mitigate the most frequently used attack techniques, maybe starting to expand the number of users that you give privileged identity management to, start organizing groups of users that you think this applies to. Stage 3, 1 to 3 months, continue to build visibility and build full control of admin activity throughout your organization. And stage 4, 6 months and beyond, just continue building defenses to further harden your security platform. And this is just something, again, just to think about. A large enterprise, you might turn this on and find, okay, I've got lots and lots of subscription admins, lots and lots of global admins. I need to remediate those. I need to update all my processes around my enterprise to make sure that this is something that's built into security administration, user administration, help desk, etc. And so think about the process as more of a journey and something you will go through, to set up PIM and run it successfully in your enterprise. And with that concludes the lecture on privileged identity management, and I encourage you to try it out and check out the demonstrations. In this demonstration, we're now going to go about configuring Azure Privileged Identity Management, and we'll begin in the Azure portal. So in the Azure portal, I'm in my Azure Active Directory section. If you're not familiar where to get there, again, just click Azure Active Directory on the left, or if you didn't favorite it, just go ahead and click All Services and type Azure Active Directory. But you can see I've already got my trial enabled. I've got Azure AD Premium P2, and this is on my domain, azexamdemo.onmicrosoft.com. So I'm going to go ahead and look at my users first of all, and we can see in here that I've got Bill Adama, that's my test user I'm going to use later on, and then my account that I'm basically signing into this Azure AD with. Well, first of all, I do need to make sure that I've got a location in the details for my particular user. So if I edit my user and I scroll down, I should have a location option. So you see the usage location, and I have to go in here and make sure that I have set this to my location. Otherwise, it won't let me continue on with assigning the license. So I've got my P2 enabled on Azure AD, but I do need to assign the license to my account, and that's why I'm making sure that that usage location is listed there. If I go to licenses now, it will let me assign an Azure AD Premium license. You can see I don't have one assigned yet. I click Assign. I choose the product. I'll choose Azure AD Premium P2, click Select, and then go ahead and click Assign. Licenses have been assigned successfully. If you didn't have the location set, you would have got an error at that point. So if it does come up, that's why you're getting it. So now that license is assigned, I've decided, okay, I want to enable privileged identity management. Well, to do that, we click All Services and we type in privileged, and it'll already pop up, Azure AD Privileged Identity Management. You can favorite it now as well if you want to, as we'll be coming back to it, and click that, and this opens up the quick start for privileged identity management. And to get started, I have to click Consent to PIM on the left-hand side. It'll now do an assessment and tell me in order for me to do PIM, I do need to open up multi-factor authentication to verify my identity. So I'll go ahead and do that. And it'll prompt you for various things as part of the MFA setup, because you need to set that up on your account if you haven't already done that from previous work you did on MFA. So I'm going to go ahead and fill this in and then come back to you once it's all completed. Okay, and after I've completed MFA, you can see status checks completed, and I can now click consent to basically continue that on, and we just click the play consent button at the top here to consent to privileged identity management. Now again, make sure you are doing this in a trial account. If you're actually doing this in your enterprise, you need to definitely talk to the team that manages your environment. This is purely something you do want to be careful doing and know what you're getting into before you continue. And now we can see some things on the left-hand side like my roles, requests, application access, approvals, and review and access. And then I can manage my Azure AD roles. Remember in the lecture we talked about Azure AD roles and Azure resources. Those are the two different areas we can manage there. And then I've got my audit history and any support I need from Microsoft at the bottom as well. So let's say I want to do something around Azure AD roles. I can click Azure AD roles here, and I can basically see I can assign, I can activate, approve, and audit. But before I can do anything, you'll see on the left-hand side, sign up PIM for Azure AD roles. Now if I click this one, this now signs things up here. If I click play, click yes, and now I can manage Azure AD roles with privileged identity management. And you'll see how it's discovering privileged role assignments such as global administrators in your tenant. So now that's completed. On the right, you can see eligible roles. Nothing there right now. If I click active roles, you can see I've got security administrator permanently assigned, global administrator permanently assigned, and the privileged role administrator permanently assigned to myself. Now, if I go back to Azure AD roles, I can see assign. I can assign eligibility to different users. So I could say, let's look at the global administrator, see the members, and I can choose who I want to assign that to. So I can add a member to this as well at this point. So we'll choose our role for Bill. So Bill Adama, this is our test user. I can select Bill, click OK, and I've now added Bill to that role. So if I refresh, I can see Bill Adama, but you see the difference here. My role is permanent. Amy's role is permanent. We were already global admins. And I've got Bill Adama, who is now eligible for that particular role. And if I click the three dots on the right, this is where I can make it permanent if I want to, or remove that assignment. Same for the other one. I could go to Amy's role now, and I can change it from permanent, because she was already a global administrator, and make her eligible instead, or remove that. So you can see a lot of power now, because now we're at the point where I'm saying these are the users who are eligible for global admin, and you can see it at the top. These are global administrator members that I'm looking at right now. I can go back a level. I can look at all my Azure AD roles. Here they all are. Again, all their Azure AD roles are available to you, and you can decide, who can elevate into them or who gets permanent access to those roles. So again, the difference between eligible and permanent is what you need to understand there. Now, before we move on, there's a few other things just to be aware of as well. If we go back to the overview for Azure AD roles, you can see I've got this concept of my view again that we saw early on, my roles, my eligible roles. Again, I've got permanent roles, so I'm in the active roles category as permanently assigned security admin, global admin, privileged role administrator. But I've got an admin view as well, because I am the administrator of privileged identity management, and I can see additional information here around the roles and views and directory, activation history, etc. On the left-hand side, if I go down a bit more as well, I've also got this wizard, which is a really good place to start out, because first thing you can do is discover the privileged roles, convert members to eligible, and then review changes to your members in privileged roles. So if we do the first one, discover privileged roles, this will actually do a scan and say, okay, here's our global administrator, security admin, and privileged role administrator roles. And you can see there's 2 permanent assignments to global admin, 1 eligible. That's because Bill Adama is eligible. Nick and Amy are permanent right now. So I can click this global admin, and on the right-hand side, it will show me, exactly who has that permanent, assignment and who is eligible. And then I can take some action on that. So I can click next on this one and convert those members to eligible if I want to. So I don't want them to have global administrator all the time. It's telling me straight away, hey, these are the people in your environment that have global admin. And let's say I want to take Amy, click next, and convert her to eligible. It'll ask me to review those changes. Go ahead and click OK. And that's the same process that we did manually, but the wizard makes it really easy to go through and do it in bulk, especially when you're just getting started as well. Another thing to be aware of are all the settings that you can apply to the different roles. So if I click the settings button on the left-hand side and choose the roles, so if I go in here, select roles, and then say choose global admin, let's just find it here, there we go, global administrator, you can see here that I can tweak various things like maximum activation hours if I wanted to, send emails notifying admins of activation, incident tickets, multi-factor authentication. Some roles require that to always be enabled, so it'll be grayed out, and then require an approval. So approval is really interesting because I can click enable, scroll down, and then select an approver that needs to approve, who can basically activate or authorize that activation of the role. And then I simply select them from my Azure Active Directory as to who those people are. You can also use groups as well there. But that's basically it for right now for the setup. In the next module, we will look at how we go about assigning RBAC permissions as opposed to just Azure Active Directory roles that we've been looking at here. In this demonstration, we're now going to look at assigning resource roles with privileged identity management. So we'll continue on in the Azure portal. And in the portal, I'm back in Azure Privileged Identity Management. And on the left-hand side, I'm now going to select Azure Resources as the area I want to manage. So when we select that, the first thing you'll see is nothing below when it comes to resources. No resources are found yet because nothing is being managed by PIM. So what we have to do first of all is discover resources by clicking Discover Resources at the top. And then it'll show us our subscriptions in our account. So I can select this one. This is my Visual Studio Enterprise subscription, and I can go ahead and select Manage Resource. And this will basically put management of the resources, all the child objects in that subscription under PIM, and I have to confirm to do that as well. Again, make sure you're doing this in a trial or know what you're doing, or you're working with someone in your enterprise to basically do this. And now it says the onboard resource succeeded. So if I go back to the main page and click refresh, what's already there actually, Visual Studio Enterprise, and you can see 102 roles and 4 members there right now. And I can go ahead and click this one. And just like in the Azure AD side, you'll see various options on the left-hand side. I've got my tasks, my roles, pending requests, approve requests, review access, and then manage. So again, I've got roles, members, alerts, access reviews, role settings, and I can do audits as well at the bottom here. Now, if I click roles, first of all, this is where we manage the various roles that we assign out. So again, if I click my contributor or owner role, you can see here they've got 2 active assignments in the owner and 1 in the contributor. We'll go ahead and select the owner role for right now. And I can actually add a member to this role. So if I click add member, I can select a role, which is owner. Now I select the member, and I can choose, we'll pick Bill Adama again here. So there's Bill Adama, our test user. I'll select him. And now I choose the assignment type. So you need to understand the difference between these. I've got the eligible type and the active type. So let's start with eligible. So eligible is when they elevate into that particular role. And then I can choose the allowed eligible duration. What is the maximum they're allowed to do that for? And that's where I choose my start and my end time for that particular assignment type. Now it's a little bit different when we select active assignment. If I choose active, you can see the maximum allowed assignment duration is 1 month. Now we can go ahead and change that in the settings. I'm not actually able to make this a permanent assignment, as you can see here, but that is something we can look at, and I can show you where you modify that. But we can choose your assignment starts and assignment ends. So I previously selected a longer date in here, and so that's saying, well, that violates our maximum allowed assignment, which is 1 month. But now if I go back to, if we look at January 21st here, that's going to work, and I can put, user needs access for contractor work on project XYZ. That's just your justification there. And that's where I basically am assigning a time-based assignment for Bill Adama to that particular role. But I'm not going to assign that yet. I'm going to close out of this for right now. And I'm going to go back to role settings, which you can see here. There's two ways to get to this. I can click role settings right here, or I can go back to that main screen and choose the settings for the role. And you can see I can edit the settings for this role. So here's my owner role, and I can choose things like allow permanent eligible assignment. I can allow permanent active assignment. This is where I can choose what we're allowing in those options. If I choose not to allow permanent, I can also choose this active assignment, 1 year, where we say it kind of just automatically goes away, and requiring multi-factor authentication on active assignment as well if I want to. Same on activation. So these are all things I can tweak. I can add an approval, select this, then select my approvers. Plenty of options here in terms of the role. So just consider that you've got settings for each role. If we go back to the roles themselves, I'm just going to jump back a few blades here. Again, here's all my roles, which I got to from the left-hand side. Click in roles here, and I can select them in here and give various access to members into these roles. Or I can go to role settings. That's the other place where I can get into the settings for my role. So again, it's going to come up with my roles here in a second. Click the owner role. And this is where, again, those same settings that you saw from the different pane, it's the exact same thing. Role settings and assignments are the key things to keep in mind. But if we go back, let's go ahead and give Bill an eligible assignment. So if we go back to not the role settings, but to the roles themselves, where I want to manage them, and I want to add a member to the owner role. And again, I can click add member right at the top here, or I can click the role first of all, and then add member from there, and it will simply put in the role for me automatically. You see it select a role, it says owner there. Now I click the member. Let's go ahead and choose Bill Adama, click select, and choose the membership settings. And I'm just going to say this is an eligible activation that we want to do. Yeah, so we'll click OK, click add, And now we know that Bill can amplify his rights to become an owner when he wants to. I can also look at the active roles. So if I click active roles here, I can see that Amy Roush is there. Subscription A, if I click this one here, is actually a permanent role. It's basically assigned to subscription admin. So this is a group-based assignment that we have here, and that's where my N Collier account is basically in there already, and that's a permanent assignment, currently that exists. I can also look at expired roles if I wanted to as well, and again, I can choose between eligible and active roles that have expired. So a lot of visibility into what's going on in the environment itself. Well, this now concludes our demonstration on PIM for RBAC roles, and in the next demonstration, we'll log in as Bill Adama and show you some of the ways he elevates his rights. This demonstration, we're now going to build upon what we did in the previous demos and activate a role using Bill Adama. So we'll switch over to the Azure portal, and you can see here that I'm actually logged in now as Bill Adama and logged in separately into his account, and everything is ready to go. Well, if we go over to Azure Active Directory first of all, and we look in here, we'll see that a lot of things are just kind of grayed out, for Bill, and that's because he's not a global admin. He's eligible to become a global admin, but right now is simply not one. So the way we elevate those rights is we go to All Services and we go over to Privileged Identity Management. And once we're in there, we can see My Roles on the left-hand side, and we can see Eligible Roles. Global Administrator is one under Azure AD Roles. If we go to Azure Resource Roles, we should see that the Owner role is eligible as well, and I can choose to activate either of these, and we'll start with the Azure AD role. So we'll click Azure AD Roles, look at our Global Administrator, status not active, no pending requests, simply click the Activate button on the right-hand side, and you'll notice the first thing, we have to verify our identity before proceeding. And that's because multi-factor authentication is required for that global admin role. So we'll go ahead and set up MFA just like we did before, and I'll fast forward here as we do that. Okay, that verification is successful, and now I have the option to go ahead and click Activate, which I will do. Click Activate there. Choose my activation duration. Remember, the settings only allow a certain maximum time for activation, and that's something you can tweak back in the settings as part of being a privileged role administrator. But for right now, I'm going to say I'm going to activate for 1 hour. I could start this 1 hour a little bit later on if I wanted to. So I could start it in the future. Perhaps I'm going to do some work at 8 p.m. that night. I could say, okay, 8 o'clock, I want to start, and I want to make sure that access is ready for me. That's where I would do that. So great feature there. But for right now, I'm just going to say, nope, I just want to activate it right now for 1 hour. I have work to do that requires global admin, and then simply go ahead and click Activate there. And it now is activating the role. So you can see it's processing the request and activating the role. It will validate that it's successful, and then I'll get a activation complete once everything is completed. Okay, and all of that is completed. Now I do have to sign out and sign back in to start using my role. So I'll go ahead and click Sign Out. Sign back in, it's Bill Adama. And now if we go back over to Azure Active Directory, we can see everything is available to me now because I am now a global admin. And if I go ahead and select users on the left and select my name, Bill Adama, click directory role, we can see right now that role is global administrator. Okay, so that was for Azure Active Directory roles. Well, what about those Azure subscription type roles for resources running in Azure? Well, again, I click All Services, choose Privileged Identity Management, go to My Roles. In fact, if I look at my Azure AD role, you can see right now that it's showing this role as access until January 20th at 4:06 p.m. If I click Active Roles, you'll see that there as well. And I can also choose to deactivate manually when I'm done. If I go over to the Azure AD Resource role now, again, we'll see I'm eligible to become the owner for that subscription. So I will click Activate. Choose the start time again, the scope being that particular subscription. How long do I want it for? Again, this is controlled by the settings for that particular RBAC role. So let's say I just want it for a couple hours. I need to do Azure work. That requires owner permissions. I click Activate. And a slightly different process. Your request is queued for activation. And once it's completed, if I go back here and refresh under Active Roles, we can see that I'm now the owner of that subscription, and I can deactivate it when I need to as well. Now, if I log back out and log back in and choose subscriptions, I can now see that subscription. In fact, it just popped up to tell me the remaining credit, but I can now see it, tied to my account, and I can go ahead and build resources. I can build, virtual machines and other things now. In fact, we'll just show by doing a storage account very quickly. And you can see that I'm actually able to do it now. If I didn't have permissions elevated, I would simply get one of the error messages saying that I don't even have a subscription in this account right now, because this is actually the only subscription he has rights to, so it wouldn't let me provision any resources at all. And with that, this basically concludes the demonstration and hopefully gives you a great overview of PIM, how to set it up for Azure AD roles, RBAC roles, and then activate it with the user as well.
Managing access is naturally one of the most important things in Azure. Given that there's so much infrastructure that we're putting out in the public cloud, we need to find a way to secure it and lock it down so only the right people can access it and have the appropriate rights. And the way we do that is using RBAC, also known as role-based access control. And in Azure, the way it works is we have Azure Active Directory. So we create our users, our apps, our groups. You saw in the previous module around service principals, we can give an app a permission set as well if we want to. And then we scope it. So we assign the apps, the users, the groups to specific objects in Azure with a specific role. And the way that works as well is there's a number of built-in roles in Azure. So for example, we have owner. This one has full access to all resources, and this also includes the right to delegate access to others. Then we have the contributor role, and similar to owner, the only difference being that it can't grant access to other people. So it has all the permissions in Azure. If you gave the contributor right to somebody in the subscription, they could still do everything in Azure, but they couldn't give new access out. Then we have the reader role, and this is often used by monitoring tools and other third-party tools like that as well, where they can view existing resources but cannot perform any actions. Perhaps you've got a managed service provider that just needs read access to your environment. That's where you might use the reader role for that. And then there's a whole host of other roles, and you can click the link here. In fact, we've got a summary on this page, and you can see there's a whole bunch of roles for things like automation operator, backup reader, etc. And so Microsoft has created this subset of roles to kind of match a lot of the things that you might do in your department. Virtual machine operators is a good example. You might just want to have a VM admin from an operations side, have a role on a specific resource group so they can manage those VMs. That's a great example there. But if you select this link, and you can see if you scroll down, we have all those roles listed out. And if you select one of them, we'll just select contributor, and it will show you all the various actions and not actions available for that role, which we will get into a little bit later on. But know that this page exists for you. The next thing is, how do we define how the roles work? And you may have seen briefly on that page, there's the concept of actions. So the roles include various actions that people can perform. Essentially, they define what type of operation you can perform on a resource type and what actions you cannot perform. So there's not actions and actions you're actually granted. Write enables you to perform put, post, patch, and delete operations on a resource. So think of it from a REST-based stance. You can make REST requests against the resource providers in Azure. If we've got write access, we can do all of these kind of updates and posts and etc. And read enables us to perform just get operations. So we can do any get operation against any of those resource providers. You can use PowerShell to get the latest roles, so they're certainly available on the Microsoft website, but I encourage you to know this command, which is get Azure RM role definition. You can simply type that in PowerShell against your subscription, and it will tell you all of the roles available to you there. Now, the resulting user rights is always a combination of the user plus the role. So just think of it in this context. We've got our user, we've got our role with its various actions, and the resulting rights obviously overlap somewhere in the middle there, depending on what you scoped for that particular user. Now, if none of the roles work for you in Azure from the built-in list, you can go ahead and create custom roles. And essentially, these are just roles with your own actions and not actions available to you. Each tenant can have up to 2,000 roles associated with it. Like I said, it uses the same actions and not actions, and you've still got assignable scopes that you need to define in the custom role. So as opposed to when we you'll see in the demonstration, assign a role to a specific area, when you define the custom role, which is a JSON template, you do give it an assignable scope as well. So this could be subscriptions, individual resources, or resource groups that you'll allow this particular custom role to be assigned to. And if we look at one of these in Visual Studio Code, you can kind of see the layouts that we have here. So on the top, we've got our name of our roles. We give it a description. So in this case, this one can monitor and restart virtual machines. And if you look through the actions, all of them come from the resource provider. So things like Microsoft.storage/star. So that's everything in Microsoft Storage. We've got read access, everything in network, read access, everything in compute, read access. And in addition, we're given the options to start and restart virtual machines in the compute section as well. Then you've got some others there like authorization, subscription read access, insights, alert rules, and diagnostics and support. And this is because, it's not just a virtual machine. We decided we wanted the user to be able to monitor as well, so they need these additional pieces. There's no not actions in this example, and you can see that concept there of the assignable scope. In this case, it's just a particular subscription that this role is allowed to be assigned to.
So hopefully that gives you an overview of the roles in Azure, and I encourage you to kind of just put this in practice and do this in the upcoming demo. In this demonstration, we're now going to go about implementing role-based access in our Azure environment. So let's head over to the Azure portal. And in the portal, the first thing we need to do is go over to Azure Active Directory on the left-hand side. And let's just look at the users that we have. If we select users, and you can see I've got 2 users there plus a built-in user. So Nick Collier, Brett Bosick, these are 2 member users in Azure Active Directory. If we go back, we can also see groups. And if we want to, we can create a new group and include various users in that group. So this way, if we want to apply permissions to lots of people, we don't need to go and do it on an individual basis. We can create a group type. So we'll choose a security group and choose the membership type as assigned. And in this case, I'm just going to select Brett as the user I'm going to assign to this group. So that's done. Go ahead and create that group. Takes a few seconds and that's completed. And now we want to go about assigning permissions to that user or group to resources. And we can do this at a couple of levels. So first of all, we'll go to subscription by typing subscription at the top and select, in this case, my pay-as-you-go subscription that we're using for these demos. And you'll see this tab appear on almost every service in Azure, which is IAM, Access Controls, Identity and Access Management. And if we go in there, you can see we already have our users there and we're owners on the subscription already. So we're not going to fully create the read writes because, like I said, we're already owners. But if we select add, and we can choose the role. So in this case, if I wanted to choose reader, I could simply select that. Or if I wanted to choose one of the other built-in roles that we talked about in tutorial, they are all here ready for you to use. But we're going to choose reader on this occasion. And then I can assign access to an AD user group or application. But no, I can also assign access to a virtual machine if I want to. And then I simply choose the people I want to assign access to. So I could choose them by name. And you can also see that the group appears there. So I could simply select Skyline readers and assign read access to the subscription to everybody in that group. And that's basically it from a scoping point of view. You can go and do this. If I discard from the subscription level, and let's say I want to go and do this at the resource group, I can simply select the resource group, pick SL identity, and again, you've got that tab, access control. Go in and click add on the top. And again, same screen appears. I can select my role, reader if that's what I wanted, and choose who I want to assign it to or the group of people that I want to assign it to. And that's pretty much all there is to it. Like I said in the tutorials, if you want to, you can create a custom role, and then if we cancel out our permissions, we would see those roles appear in our roles list. And then the same thing, we would just assign the custom role much the same way as we do a built-in role. It will just show up in the list now that we've created the custom role. And with that, this concludes this demonstration on role-based access. One of the questions I get a lot from customers and anybody using Azure in general is just around governance and how do they restrict things? How do we make sure people can't make mistakes in the environment? And Azure policies are really a tool that allow us to enforce governance. We can say this is our policy around Azure and we want it enforced so nobody can go out of the boundaries we've set in the portal or just via their ARM templates as well. And so Azure policies allow us to do that. They're either built-in or custom coded. So you'll see in the demonstration, there's a number of built-in policies you can simply apply, or you can go ahead and custom code one yourself, or just, look on GitHub and look at what the community has to offer. Now they can be assigned to subscriptions as a whole, so they'll affect everything in the subscription, or they can be more granularly assigned to specific resource groups. So if we've only given somebody permissions in a resource group and we want to put some policy around that specific resource group, we can do that as well. And finally, the way we do this is we first create the policy and then we assign it. So when you look in the Azure portal, or if you're doing it via PowerShell, you'll create the policy first and then you'll scope it to those specific subscriptions or resource groups. In this demonstration, we are going to implement an Azure region policy, and this will allow us to restrict the specific regions that we will allow users to deploy into, whether that's via the portal or whether they're using ARM templates. This is applied at the Azure level. If we switch over to the portal and simply select a resource group or create a new one for testing out, I'm just going to pick one from a previous demonstration. And in here on the right-hand side under settings, you can see policies. If we select policies, we have this choice of assignments or policies. And we'll get to assignments in a moment, but first let's select policies and see what's available. These are all the built-in policies, including ones that are in preview. And if we scroll through these, you'll see various ones like apply tag and its default value, not allowing specific storage SKUs, not allowing specific virtual machine SKUs. The one we want for this demonstration is allowed locations. And if we select that, we will see the details along with the JSON tab. So we can actually copy this. I'm going to take it over to Visual Studio Code so you can see it a little better. We'll paste it in there. and change it from plain text to JSON. And you'll see the way the syntax works. It's a bunch of if conditions. So if not field location in the parameters that we're going to pass in when you see us do the assignment, then effect deny. So you can see very quickly you can grab some of these and start to construct your own policy templates if you want to. But let's say we like this as is and we want to go ahead and apply it. Let's go back to the portal and go to assignments. I'm going to zoom in a little here and select add. And what will come up is our add assignment screen, and we can select policy first of all. So in our case, if we scroll all the way to the bottom again, we should see it here, allowed locations. And now I simply need to select the locations I want. So I can open up this drop down, and I'm going to choose only North Central US. So everything else I wanted to deny. And I need to go give it a few more things. So again, it's scope to SL-arm counts. And we'll just give it a basic ID. And hit OK. And that assignment is now created. It only takes about a second for it to complete successfully. And if I go to the top of my resource group and I try and deploy a new resource into it, so we'll add something like a storage account. And let's give it a basic name. And scroll down, we'll keep all the defaults for the storage account. We'll say use existing for our resource group and choose SL-arm counts. And we're going to change the region to something else. We'll choose West Central US and hit create. Some validation errors, let's select those. And you can see there the error type, the template deployment failed because of a policy violation, and the details of the policy are there. So you can see very quickly, this is a great way if you want to just put controls, if you don't want anybody putting data in other countries, if you want to make sure everything stays in your locations, if you want to restrict those large virtual machine types, using policy is a great way to enforce some very quick governance for your Azure environment. One of the features Azure provides to prevent accidental resource deletion is the use of resource locks. And these are essentially just a mechanism for locking down resources that we want to have that extra layer of protection before they can be deleted. So for example, when we delete in resource groups and storage accounts, etc., we've just gone in and deleted them. Often we have to type in a name or something to actually delete it. But a resource lock creates this additional layer that we have to kind of remove first before we can delete the resource group. And there's two options available. One is cannot delete, and this is authorized users can read and modify but not delete the resources, so they can make changes to them but not actually delete anything. Read only, authorized users can read the resource but cannot update or delete. So the one that's actually most restrictive is read only, because it's read only. You can't modify any of the resources in there or delete them. Cannot delete, you can't delete them, but you could still make modifications to them. So a lot of people often think cannot delete is the most restrictive, or no, it's actually read only. So if you just want to make sure no one touches it at all and modifies it, use the read only resource lock, and you'll see how to configure these in the upcoming demo. In this demonstration, we're now going to implement a resource lock in Azure on a particular resource group. And this is to help in case we had something like shared services infrastructure or some particular data services we wanted to make sure nobody could delete. So we'll head over to the Azure portal, and in there we're just going to pick a resource group. So in my case, I'm using SL-arm counts. This is one from a previous demo that we're going to delete eventually, but for now we're going to test it out with the lock. And you can see that this resource group has 5 storage accounts in it, so we don't want it to get deleted just yet. We'll hit the lock section, and we'll go in and click add, give the lock a name, and choose the lock type. Now if you remember from the tutorial, read only is the most restrictive, but in my case I'm just going to use the delete lock for this occasion. Select OK, and you can see that lock is now available on the resource group. If we scroll back up to the top and I attempt to delete this resource group, so I'll type in the name that it prompts me as per normal, and I hit delete, immediately we get that error saying the resource group SL-arm counts is locked and can't be deleted. And if I go back in and remove that lock, the resource has no locks now. Go back to the overview, delete the resource group, and at this point it's going to delete, hopefully if all goes well, all of those storage accounts in there. And you can see it didn't come up with an error this time, so it's now in the process of simply deleting that resource group and everything that was inside it. And with that, it concludes this demonstration, and hopefully that gives you a quick insight into resource locks and how easily you can just put them on your resources in Azure that you want to protect. You'll probably get 1 or 2 questions on the exam on this, just how would I protect resources, and there's obviously different mechanisms we've covered so far in this module.
It's pretty much become impossible to talk about Azure these days without first understanding about app services as a whole and where they fit. As opposed to a virtual machine, app services allow us to bypass that layer of OS management and IaaS infrastructure management and shift that focus up to running our applications. At its core, app services is a series of PaaS-based application services. So if you think about it, it consists of the following four. There are web apps, mobile apps, logic apps, and API apps, and all of these can run on the same underlying infrastructure of virtual machines that support them. So let's take a look at web apps in more detail. Well, web apps were formerly known as websites. If you're familiar with classic Azure, this is what we called them back then, and they allow us to host and build web applications using a variety of programming languages that we can choose from. They offer auto-scaling capabilities as well as high availability, and also include a whole bunch of DevOps features that enable us to automate deployments from things like GitHub, Visual Studio Team Services, and other sources as well. Then we have mobile apps, which also run on that underlying infrastructure, and they allow us to build a mobile device backend. Essentially gives the developers that mobile-friendly environment platform, still is highly scalable, highly available, and allows developers to build native apps for iOS, Android, Windows, and cross-core platform apps are supported as well. One of the biggest benefits, is really that this shares the same app service deployment to reduce those run rates and, bring the costs down. Then we have one of my personal favorites, which are logic apps, and these really allow us to automate business processes. Think of it like creating your own orchestration workflows. There's an orchestration engine under the covers that helps us out with various tasks that we want to perform. And think of these examples like, every time your app calls an API, I want to do some task, or every time there's some data in blob storage, I want to do some work on that, or maybe there's an external SaaS service I want to connect to. Perhaps I'm trying to do something more around the social media space, like checking tweets or checking Slack messages, and then I want to take some series of actions. So it's a very easy way to build automated workflows without really having to learn a lot of code. Then we have API apps as well, and so these allow us to easily create, consume, call APIs. We can basically use our own APIs as part of these, and these could also be from external API services as well. So then we get on some of the security features, and Azure App Services are highly secured. Any of the app service features that you consume will run on their own isolated virtual machine. They meet all the security standards, so ISO, SOC, PCI compliant, all the main ones are there. And Azure Active Directory is fully integrated as well, so it can be used to authenticate users along with social logins. And in addition, Microsoft recently added managed service identities, which are currently in preview, but a managed service identity from Azure Active Directory allows your app to easily access other AAD protected resources such as Azure Key Vault. The other things that are really important are some of the features that are supported from a security standpoint are custom domains, SSL TLS, custom certificates that includes wildcard or subject alternate name, supports multiple directory authentication protocols, so OAuth, OpenID, and Microsoft Active Directory. And finally, this is really important, with the release of Web Application Firewall, this can be integrated into your web apps and app services as well. So then we have DevOps features. Pretty much, you can't release a good development platform without having a lot of DevOps features. So Microsoft includes the most common ones here for you. So, CI/CD support is available through Git, GitHub, Bitbucket, Docker Hub, as well as VSTS as well. You can integrate with all your popular IDE tools such as Visual Studio. That could be the Community Edition, could be Visual Studio Code. That's all available for you there. And it also supports deployment from external folder sources such as Dropbox and OneDrive as well. So if you just want to get your application up that method, you can do that as well. App Service also has a unique feature called deployment slots, which allow us to stage environments. So we can basically have like a stage environment, a prod environment. We can deploy to stage and then flip it into prod. And you'll hear more about that, later on in the course. So if we look at app service plans now in a little bit more detail, app service plans represent the collection of physical resources under the covers that are going to host our apps. This is where our apps are going to run on top of. So first we have to define the following: the subscription the plan belongs to, the location, so it could be like North Central US, the pricing tier, so it could be free, shared, basic, standard, premium, or isolated, and we'll talk more about that one shortly, and the instance size. So this is the size of the VMs running under the covers, and you'll notice when you look at the pricing of these, they pretty much map to the VM sizes if you went and deployed a VM like you would just for IaaS. Once you've got that part set up, then you configure your settings. So it's around things like scale count, like how many instances do I want under the covers, what are my scale rules, allow for auto scaling if the plan supports it, scale up, you can increase the resources associated with the app service plan. This is essentially how you would switch the plan you defined at the start if you wanted to kind of increase the resources associated with it. So let's look at the pricing tiers in a little bit more detail. So first of all, we've got those shared tiers, the free and the shared one. So these run apps on the same Azure VM as other app service apps, and this includes apps of other customers. So here CPU quotas are allocated to each app that runs on the shared resources, and resources are not able to be scaled out. You'll need one of the other plans for that. And that brings us onto these, which are dedicated compute resource plans. So you've got the basic, standard, premium, and there's a premium V2 tier. These run your apps on dedicated Azure VMs. So only apps in the same app service plan share the same compute resources. The higher the tier, the more VM instances are available for you to scale out. And then we've got this isolated tier, also known as app service environments. And this tier runs dedicated Azure VMs on dedicated Azure virtual networks. So they provide additional network isolation on top of compute isolation for your apps as well. And these provide the maximum scale out capabilities for you. So there's some general guidelines that you need to follow. And first of all, you can select this link at the bottom, which will give you the subscription service limits and give you more details on that. But if we look at some of the guidelines in more detail, first of all, you create an app service plan for your specific applications. Then you deploy your app services to support that entire application. What you don't want to do is use a single plan for every single web app that you have. That's not going to scale very well, and it's just going to be very hard to manage. You do want to then combine app services versus mass VM creation as well. So this is a key thing, because if I'm going to go and create a whole bunch of app service plans and then put a whole bunch of app services then spread them out, that's not going to be very cost effective. So the more I can combine my app services for that application, the better, more cost effective it's going to be. And then you can combine other services in the same resource group. So you can mix your app service plan. If you say you got, IaaS SQL servers, but you want to have web apps running in an app service plan, you can do that in the same resource groups. Everything can still share the same life cycle. If you destroy the resource group, it could destroy everything, the IaaS services, the app services, plus whatever other services you've decided to utilize in Azure as well. Now, to wrap up, let's take a look at ASEs and app service environments and kind of talk through those in a little bit more detail. So app service environments, again, are that fully isolated environment. So it's a feature of Azure App Services that allows us to reserve that dedicated compute environment for securely running those apps at high scale. And ASEs can host web apps, mobile apps, API apps, as well as Azure functions on top of them. So your use cases really are around high-performing apps, high CPU, high memory. Service instances are generally good enough, but they are pulled from a common pool which is shared with other Azure customers. At very high utilization, this could result in some performance problems, as compute services are all suddenly requested from a whole host of people. Within that, though, you've still got individual or multiple service plans that you can put on top of your ASE. So there could be a mixture of, different plans that share different applications. And there are two ways we can go about deploying them, internal or external. So when we look at an internal ASE, this is where a VIP is created on an internal IP address. The internal endpoint is essentially an internal Azure load balancer. These are sometimes referred to as ILB ASE. And then you've got external ASE. Use this option when you want your ASE to be directly accessible via the internet. After selecting your VNet, you then select the number of external IP addresses you want to utilize. Again, something to stress here, this is created in a subnet of a VNet, which achieves isolation. And another note, these may take a few hours to spin up. These aren't things that are just click of the button and readily accessible. They are reserving compute specifically for you. It's dedicated for you. So there is a time period as these spin up. So with all of that, this concludes this part of the module and hopefully gives you the good background on everything you need to know about app service plans. Make sure you understand the different plans, the different tiers, the app service environment option, the fact is that internal and external option. And I encourage you to just check out the upcoming demo, which will guide you through, creating your first app service plan in Azure. In this demonstration, we're now going to go about creating our first app service plan in the Azure portal, and we'll use this to deploy our web apps on top of later on. So let's head over to the Azure portal. Okay, and in the Azure portal, on the top left, simply select Create a Resource, type in App Service Plan, and you'll see it come up. Simply select it once it's there, and that will give you the option to create the app service plan. Go ahead and click Create. And now we need to enter our details. So first of all, what's the name of our app service plan? I'm going to use SL-App Service Plan as my example. Select our subscription. I'm going to use my pay-as-you-go one. And I'm going to create a new resource group to put all of these objects in. So call this one SL-App Services. Choose your operating system that your web apps that you're going to put on top are going to run on. So if you're doing .NET apps for Windows, you would use Windows. If you're doing some kind of Linux-based apps, you would choose Linux as your operating system, and then select your location. So in my case, I'm going to use Central US, and then choose Price in Tier. Now this brings us up to a good point. If we go over to our web browser and pull up App Service Plans on the Microsoft site, and if we scroll down,
This is where you need to understand all the differences between the app service plans, and you can see Linux is called out specifically under app service Linux there as well. So if we look at these, we've got free, shared, basic, standard, premium, and isolated, as we mentioned in the tutorial section. So some of the key things we need to remember as we look through these. So first of all, there are limits on the number of apps you can deploy in free and shared. So it's 10 for free, 100 for shared. There are disk space limits as well, so 1 gig for those shared tiers. Then as we get up to basic, it's 10 gig, standard 50 gig, 250 gig in premium, and then 1 terabyte in isolated. And then we also have a max number of instances. So you may get questions on this on the exam, and you can see there under basic we can go up to 3, standard up to 10, premium jumps us to 20, and then isolated is 100. If we scroll further down, you'll see some other things like deployment slots are only available when you get up to the standard tier and higher. Development tools, everything's pretty much there, but things like cloning apps are reserved for premium and isolated, as well as some of the testing and production options. Those are for standard, premium, isolated, and app service for Linux as well. Most of the diagnostics and monitoring tools are there throughout, just some exceptions for app service Linux. And then for networking, you'll see there as well. If we want VNet integration, we have to be at standard, premium, or the dedicated isolated tier as well. For programming languages, if we drop down, pretty much good across the board there. You'll see though the difference between what you can deploy on top of app service for Linux and the generic Windows app services there as well. So that's important to be aware of. The one extra one you get there is Ruby on Linux, which you can't do on the Windows systems. And then as far as scale goes, that's the other important thing. You can see that auto scaling is only supported on standard or higher, as well as traffic manager is only supported on standard, premium, and isolated as well. So just be aware of this matrix. I think I've covered the major ones you'll get asked on the exam there. The big one that you'll see is probably around scaling and the sizes that you can scale up and down. There's definitely a lot of questions on those. So with that, let's jump back to our portal and go ahead and select a tier. So we'll scroll down and you can see there that these represent the price of the underlying infrastructure. So if I go ahead and select a standard, this is a 2-core, 3.5 gig of RAM, I've got that 50 gig of storage. I can scale up to 10 instances there. So you get a good summary there, and I get 5 deployment slots. So if I select that one, hit select, and then go ahead and click create, that will now spin up that app service plan, and should take probably a minute or two for that to be available. So we'll fast forward while that completes. Okay, and we can see in our notifications that deployment succeeded. So we'll go ahead and select that resource. That should take us directly to our app service plan. I'll take away these notifications, and we can see an overview there. We can see it's obviously not very much in use right now. The CPU percentage is low, but you've got this kind of good monitoring overview of your app service plan right at the front of the main screen. We can see that it's in Central US, status is ready, and then on the right hand side we don't have any apps deployed live or into any deployment slots at the moment. So with that concludes this demonstration, and let's move on to the next module where we'll start looking at deploying web apps themselves. In this demonstration, we're now going to look at creating and deploying our web apps to Azure. So we have our app service plan already created. Now we want to go ahead and deploy web applications into it. So let's start out first by deploying this from the portal. Okay, so in the Azure portal, let's select create a resource, and let's type in web, and then select web app from the drop-down, and go ahead and click create. This will take us to the web app creation screen. So first thing we need to do is give it a name, select our subscriptions, or use pay-as-you-go, and I'm going to change the resource group. It does create a new one for you when you create in a web app, but I want to just put everything together in my SL-app services resource group, so I can just delete everything at the end. And then I'm going to make this a Windows-based one, and then for my app service plan, I can choose to create a new one, or I can simply select my existing one that I created in the previous demo. So we'll go ahead and choose that one. Finally, you do have an option to turn app insights on. This is a monitoring technique, so if we wanted to get application insights, similar to like New Relic and App Dynamics, tools like that, you can turn this on at this point as well, but we're not going to do that right now. So we'll go ahead and click create, and that will begin deploying our web app, and we'll just fast forward here until that completes. Okay, and that deployment succeeded, so we'll go to that resource. And if we select this URL, you'll notice that they already put in a dummy website for us to kind of prove that the service is up and running. So we can see that that web app is deployed. So that's one way to deploy it, and we'll get into all the configuration settings a little bit later on. But what if we want to kind of do this from Visual Studio? What if we've got some code we actually want to deploy? So that's the other great thing. If we go to Visual Studio and start off with a new project, so we'll create a brand new .NET application. So I'll hit new project, and we'll choose web, we'll choose ASP.NET Core Web Application, and go ahead and select OK. That's going to create a skeleton web app for us. I'm going to select the default here. I'm going to use the model view controller model, the MVC model, and select OK. This is a pretty typical model for a lot of .NET developers. If I want to just check this locally, first of all, I can go ahead and run that. So I'll hit debug and select start without debugging. So I'm not trying to do any kind of monitoring or anything at this point, and that will open up this application. Let's just take a look at it locally first of all before we push it up to Azure. So there we can see they've also given us a sample web page. So what we'll do is go ahead and click About, and we're going to add some information to the screen. So it says, yeah, use this area to provide additional information. We'll go back into Visual Studio. Let me close this out and go to the About section. So if we go into www root and look for, might be under our controllers here. Yep, it's under our view, and go to About. And we can see there that your title is About. The message actually comes from the controller, but you can use this area to provide additional information. So we'll change this and we'll call this, Visual Studio Deploy. And we will go ahead and save that. And now we can go ahead and publish that to Azure. Now to do that, simply scroll back up on the right-hand side, right-click your web app, and choose Publish. Select Start. And then we have the choice of creating new or selecting an existing. So if we select existing and go ahead and select Publish, yeah, you'll see we've got a subscription, and in our resource group view, if we expand this out, that's the one we deployed from the portal earlier on. But you can see we can deploy into this, we can deploy into deployment slots if we create one as well. We'll come back to that a little bit later on. But hit cancel. Let's go ahead and create new. So if I select create new, click Publish, and then it'll ask me to create an app service, but I can choose my existing app service plan. So I can go ahead and select the one I've already got. So I can share both these web apps on the same plan, and that's there. That's going to work for us. Pay-as-you-go subscription, and in our resource group, we want to use the SL App Services resource group as well. And then I'll go ahead and click Create. Okay, and that's currently now publishing. It's created the web app on Azure, and now it's publishing, basically deploying directly into it. So we'll fast forward again here while that completes. Okay, everything completed successfully, and so now it's pulling up the website, and we can see that published successfully. Let's select the About page, and we can see that Visual Studio Deploy is there. And so that's it. We'll jump back to the portal very quickly just to show you the app service plan. So if I go back to Home, go back to App Services on the left-hand side, and both of them are using the same SL-App Service plan that we created in the first demo. And with that, that concludes this demonstration, and I hope it gives you an idea of the different ways you can create web apps either from the portal or from Visual Studio. You can certainly do it via command line as well, but these are very common ways to get things done. Alright, so we've deployed a lot of web apps, we've configured a lot of web apps, but as I say to a lot of my clients, nothing is real until we know how to manage and monitor it. When you start to put things into production, you have to know how to operate it. And there's a lot of management tools to cover and a lot of metrics and things we're going to go through in this module. So if we look at management tools, first of all, there's a number available to you. You've got the Azure portal, you've also got something called Kudu, which is System Control Manager. We'll see a demo on that a little bit later. And you can also manage and do additional diagnostics through Visual Studio. You probably saw those settings, enable remote debugging services. Visual Studio then can get additional insights into what's going on in Azure if you utilize that. In addition, you've got your CLI commands and PowerShell. Those are available. They can be used for automation or to just retrieve additional data about your service and how it's performing. So those are the tools, but let's start taking a look at it from the app service plan first of all. So the app service plan is what's running underneath that's supporting our web apps. We need to understand how the infrastructure is performing. So we have a number of metrics available to us here. First of all, we've got our CPU and memory. So these are the average CPU and average memory across all instances of the plan. So the instances can scale out, and you'll see that in the subsequent module, but this is the average across all those instances, so we know if we're maxed out or not. Then we have our data in and data out. So this is the average incoming and outgoing bandwidth used across, again, all the instances of the plan itself. We have our disk queue length. So this is the average number of both read and write requests that were queued on storage. So a high disk queue length is an indication of application that might be slowing down due to excessive I/O requests, or perhaps there's other apps that are performing a lot of I/O that are affecting your app because they're running on the same service plan. Then we got HTTP queue length. This is the average number of HTTP requests that had sit on the queue before they were being fulfilled. So a high or increasing queue length is a symptom of a plan that's also under heavy load. So this is another one that you definitely need to be aware of. There are some others as well, like average response time, the average time taken for the app to serve requests in Microsoft, the average memory working set. Don't worry too much about those. These are the core ones that you need to know for the exam. Then let's look at the free and shared apps, because they work a little bit differently. They don't so much look at CPU percent and memory. Those are really focused, on the on the standard plans that you have. When you look at the free and shared plans, you have these other options. So first of all, you've got the CPU short and CPU day. So this is the amount of CPU allowed for this application in a 5-minute interval for the short one, and then the day one is the total amount of CPU allowed for this application in a day. And those quotas reset every 24 hours for the day and every 5 minutes for the short one. The memory is the total amount of memory allowed for the specific application. Bandwidth is the total amount of outgoing bandwidth allowed for the app in a day, and that quota resets every 24 hours as well. And then finally, the file system. So you have this here, which is the total amount of storage that you're allowed. Now, the results of exceeding quota are as follows. So if we look at CPU first of all, so if you exceed either that short or that day quota, that will result in your application actually being stopped until the quota resets. So during all this time, the incoming requests from the user to the website, they'll just get a 403 HTTP error on their page. So obviously not going to be a good result for them. This is why you need to use the other tiers. For memory, the application will be restarted. For bandwidth, also a 403 error. The application is stopped until the quota resets. So during that time, they'll just get the 403 error. And if you exceed that file system limit, write operations, including writes to your logs, will basically fail. So I hope that gives you a good indication, on how the quotas work there. Now, what about the web app diagnostic logs? Well, there's two varieties these come in. So we have our application logs and our web server logs. And if we look at application, they essentially just come in the following login levels. So we have error logs, warning logs, information logs, and verbose login can be turned on as well. And those pretty much map up to, if you're familiar with Microsoft applications, those are the typical warning levels that you get for application. For the web server as well, though, you can enable or disable the following kinds of logs. So you've got web server login. This is information about HTTP transactions. This is useful when you're trying to determine overall site metrics, such as number of requests handled or how many requests, say, are handled from a specific IP address. You've got detailed error login. So this is detailed error information for HTTP status codes that indicate a failure. So this could be status codes 400 or greater. And then you have failed request tracing as well. So this is detailed information on failed requests, including a trace of the IIS components that we used to process that request and the time taken at each component. So this is useful if you're attempting to increase site performance or isolate what is causing a specific HTTP error to be returned. Now let's take a look more closely at those diagnostic logs and locations. So application logs, so these are all stored under /log files, then /application. This folder contains one or more text files containing information produced by an application login. Then we got those failed request traces, so they're under /log files /w3svc, and then there'll be a number following there. This folder contains an XSL file and one or more XML files. So you need to be sure to download the XSL file into the same directory as the XML files, as the XSL file provides the functionality for the formatting and filtering of contents for the XML file. It'll just be very hard to read if you don't have both of those. Then you've got your detailed error logs, so /log files /detailed errors. This folder contains one or more .htm files that provide extensive information for any HTTP errors that may have occurred. Then you've got your web server logs, so we've got /log files /http raw logs. This contains one or more text files formatted using the W3C extended log file format. And finally, we've got our deployment logs, which are under /git there. So just make sure you understand, as a whole, where these, log files can be found. For the most part, you shouldn't get too many trick questions on this. Everything's under /log files, app logs under application, detailed error logs under detailed errors, and deployment logs is one I have seen from time to time, which are under /git. Last, but certainly not least, is Application Insights. You've probably heard of this. It's kind of an application monitoring tool, very similar to the App Dynamics and New Relics of this world. And Azure Application Insights can alert you to changes in performance or usage metrics in your web apps. So there are three kinds of alerts. There are metric alerts that tell you when a metric is crosses a specific threshold value for some period, such as response times, exception counts, page views, things like that. You've got web tests, which tell you when your site is unavailable on the internet or if it's responding very slowly. And then you've got a very cool thing, which is proactive diagnostics, and they're configured automatically to notify you of unusual performance patterns. So it sort of determines what's the normal behavior for your website. And then, if things start to look like they're not behaving normally, or maybe user activity isn't what it's expected, or some other pattern that it distinguishes, then it can kind of, alert you to that as well. So that's a pretty cool one, because you don't really have to kind of go in and configure something. You don't have to necessarily know what you're looking for. It's going to determine that normal pattern and then see what's kind of different from it. So with that, this concludes this tutorial overview, and I hope that gives you a good understanding of all the diagnostic and monitoring tools. I encourage you to check out the demos that follow, so you know where to kind of turn logging on, turn diagnostics on, and access the Kudu management engine as well. We've talked a lot this far about all the app service plans that we've deployed. We've deployed web apps into those plans, but there are a lot of settings that you can fine tune to meet your needs, and you need to be aware of a number of these for the exam. So to begin with, let's look at the different framework versions. So for example, we got .NET, PHP, Java, and Python that are all supported, but .NET and PHP are on by default. The default setting for .NET is version 4.7, although you can change that to 3.5. The default setting for PHP is 5.5, or you can change it to the other versions as well. Java, like I said, is off by default, but you can make that Java 7 or 8 and turn that on. And Python, same thing, you can go to version 2.7 or 3.4 as well. If we look at the platform itself, the default is 32-bit, but you can switch to a 64-bit environment if you desire. However, the free and shared modes, if you're using one of those lower tiers, they only support the 32-bit option there. WebSockets can be set to on to enable the WebSocket protocol if that's desired. And this is an important one, the option for always on, because by default, web apps are unloaded if they're idle for a period of time. This lets the system conserve resources. However, in basic or standard mode, you can enable always on to keep the app loaded all the time. And finally, we also have this option of auto swap. You saw the deployment slots demo, but in the auto swap scenario, whenever I push code into the slot, I can have it automatically swap into production. So perhaps I've got a slot that I just want to push code in and then that becomes production immediately. I can do that if I desire. Then we got things like connection strings as well. So if we look at connection strings, number of characteristics here, connection strings allow us to specify database servers that can be utilized per slot. So again, perhaps you've got the staging slot that you want it to go to staging data, and the prod slot is talking to your production database. This allows you to kind of set that up. And just like a lot of app settings, these can be global or slot specific if you want to. The connection string is a variable instead of a configuration file. That's an important distinction there. So it's just a variable that you set for the configuration string. It is secure because it doesn't store information as a file at all. So it's purely the connection string stored in Azure there. The variable prefixes, you can see you've got SQL Server, so you would use SQL con str, and then the same for all the others. So if you're using MySQL, you've got a MySQL option. If you're using Azure SQL, you've got the option there, and then you can also do custom connection strings as well. Then we've got some other more advanced things like handler maps. So handler maps allow you to choose specific file extensions and then have them handled by specific script processes that you define. So these script processes can be external and instead must be local to your application that has mapped the handler. So you can have the extension, the file extension to be handled, example .py for Python, PHP, etc. The processor path, so this is the absolute path of the script processor, and then any additional arguments you want to pass to your script processor can be handled there as well. You also then have virtual applications and directories. So these allow you to configure virtual applications and directories where you specify each virtual directory and its corresponding physical path relative to the website root. So by selecting the application checkbox, this marks the virtual directory as an application. So using this feature essentially allows you to create subdirectories of your website that handle specific functionality. That could be content storage or specific execution. So you've got the virtual directory. This is the path users will take to access the application itself, the physical path to the physical directory or application, and then that application toggle box or virtual directory. By default, you must select this for web app. Then we've got something like custom domains, obviously a common thing. So if you don't want to use those built-in domains that you constantly get, you obviously want to register your own domain against it. Well, you can use custom domains, and all you do is go into the settings section here, select your custom name that you've got from your registrar, add your DNS record in your registrar, and associate it with the web app. It's actually a pretty simple process to get that all registered and taken care of. And so that concludes this tutorial piece. Hopefully that gives you an overview. Just make sure you understand certainly all those initial settings and the options you have around handler mappings, virtual apps and directories, and just know that the process to kind of configure a custom domain is a two-stage process. It can't just be done in Azure. You have to also go to your registrar and do some DNS work there as well. In this demonstration, we're now going to look at where we configure all these various application settings that we discussed in the tutorial. So let's head over to the Azure portal. So here in the Azure portal, let's go to one of our app services. And if we scroll down, you'll see a section called Application Settings under the Settings category. Select that, and this pretty much gives you all those settings that you configure. So if we scroll down and work through these slowly, we've got our .NET versions, so 4.7 and 3.5, the PHP versions, the Python versions. You can see the app server supports installing newer versions of Python as well, and you can expand that out. Java versions, there's Java minor versions as well. So once we select like Java 7, we can then choose the actual Java minor version that we want inside there, and whether we want the Java web container, what Tomcat version we want for that as well, or if we want to use Jetty. Scrolling down, this is where we select our platform, so 32-bit or 64-bit. Whether we want to turn WebSockets on or off, and that piece I mentioned around always on. Do we want the app to be always on? We can select that there, and it will never get unloaded when it's not in use. You've also got this option for managed pipeline version, so if you want to switch to classic, that's an option there for you as well. And this is a pretty key one, something called ARR Affinity. This is Affinity Cookie, which basically associates the cookie with a specific web app service, and that's on by default there. Then we've got that auto swap I mentioned, and then we've got remote debugging if you want to enable that through Visual Studio as well. If we scroll further down, we have some of those application settings and connection strings that we discussed. So if we wanted to add our specific SQL connection strings, that's where we would do that. And then we have our default documents for websites. And then finally, we have those other two items I mentioned in the tutorial. So we have the handler mappings that we can add at this point, or the virtual applications and directories as well. The other things to be aware of, if we scroll down again and we go to custom domains, let me click OK. I'm not going to save anything there. This is where I can add a host name, and I can add various app service domains. I can buy domains directly in here as well, and I can also have things managed from an SSL perspective. If I go to my SSL certificates, you'll see a demo in the security module later on where you can actually have all these certificates handled automatically for you as well. So that's pretty much it for the app settings. Like I said, if we go back to app settings for the moment, certainly know just these different framework versions that are available. Know the default behavior for 32-bit, 64-bit. You may get some questions around, which app service plan you're on, and you're trying to switch it to 64-bit and you can't, as an example. And then that always on feature, some questions often come up around that as well. And with that, this concludes this demonstration. Before we deploy our web app, one other thing we need to cover quickly is deployment slots. And deployment slots essentially allow us to deploy our app into non-production slots. So the default behavior when we want to deploy an application is that it goes into the default production slot. But with deployment slots, we have this option to kind of stage them in another slot. Now this applies to web apps on Windows, Linux, API, mobile apps. Those are all covered. The main benefits of using these are that it reduces risk and increases speed. And this is because the apps deployed in the staging slots are live run-in applications. Staging slot can seamlessly be swapped to production, and then we can seamlessly reverse back to staging if needed. App changes can be validated in a staging slot, for example, before we swap them production, so we can kind of do full testing again because they're live running apps there, test everything out, swap it to production. It's already warm and ready to go, swaps in, cuts over basically, and then if something goes wrong that we didn't account for in testing, we can swap it back. So with that, what is swapped versus not swapped? You can't swap everything, so it's important to understand this for the exam. So when we look at the swapped settings, general settings such as the framework version, the 32/64-bit, the WebSockets, the app settings, they can be configured to stick to a slot as well if you want to. Connection strings, they can also be configured to stick to a slot. So this is, for example, if you want to make sure that a certain slot, like a staging slot, is looking at some SQL dummy data, like some staging data, and in production, your connection string is for your prod database. You can stick that to the slot itself. Handler mappings are swapped, monitoring and diagnostic settings are swapped, and web job content is swapped as well. In addition, what's not swapped is publishing endpoints, custom domain names, SSL certificates and bindings aren't swapped, scale settings aren't swapped, and web jobs schedulers are not swapped as well. So it's important just to understand those, particularly the connection strings and the app settings. They come up a lot in some of the exam questions, so it's important to know those and check them out in the upcoming demo. In this demonstration, we're now going to use deployment slots in Azure with our web apps to swap a new deployment from staging into production. So to begin, let's head over to the Azure portal to create our deployment slot. Okay, we're in the Azure portal, and we're going to go back to our app service. And if we scroll down, you'll see a section called deployment slots. Select that. And the first thing we need to do is add a slot. So we'll select add slot and give it a name. We might call this one Visual Studio Staging as an example. Straight away then, I get a choice for configuration source. So I don't have to clone anything into the slot immediately, but if I wanted to, I could take what's currently in the production slot, clone that into the staging slot so it's ready. But in my case, I'm not going to do anything there. I'm just going to say don't clone. And I select OK. That will go ahead and create that deployment slot. And that's completed. and that deployment slot is now running. Now let's go straight back over to Visual Studio and deploy our second version of the application. So back in Visual Studio, we can go back to our About page, and we'll just make a modification there so we know this is version 2. So we'll call this Visual Studio Deploy version 2. Save that. We'll run that locally just to verify everything's okay. Okay, it's running. We go to the About page and we can see version 2 is listed there in our description. So now let's go ahead and deploy it. So back in Visual Studio, let's right click at the top of our web app. Click Publish. Okay, and the first thing I need to do here is create a new profile. If I simply select Publish now, it's going to put it in that production slot. But if I click Create New Profile, I want to select Existing, and I click Create Profile at the bottom. You'll see we're still in the same app service. I'm in my subscription, I see my resource group, but what I'm going to do is expand out these deployment slots. And you can see we have a new one there, Visual Studio Staging, which is the deployment slot I created in the portal. So now I can go ahead and select OK. It's a new profile now, so if you click this drop down, we have both our profiles. This is the production one, and you could rename these to make it more easy to understand, but this is our production one, and then this is our staging one as indicated with the dash Visual Studio Staging. That's the deployment slot it's indicating there. So if I select that one and go ahead and publish, okay, that's kicked off, completed, and as you can see it's taking me to a new URL with that dash staging on the end of it. So if I click the About page, I can see that I have version 2 of my application that we updated in the code. And if I go back to my other page, I've still got it up from the previous demo. And without the staging, if I refresh this, I can see this is still the original version of the application. Now, if I go back to my dashboard in Azure, and I scroll down in my app service to deployment slots, I can also select the staging slot. It'll give me more details of it, and just like the production slot on the right, has that same URL that Visual Studio took me directly to. But now what I want to do is swap the slot. So I want the production traffic now to be on the main slot, but I want it to be version 2. So what I can do is click swap and choose my swap. I have two options. I can do swap or swap with preview. So swap with preview, kind of like it warms everything up. You can check it one last time, make sure there's no changes you want to make before you go completely into production. But in my case, I'm not too worried about that for the cases of this demo. But my source is Visual Studio Staging, and I'm going to put it in the production slot. So I go ahead and select OK. And that is now swapping those two slots. So version 2 will become production, and the production slot will be put into the staging slot. So if I do want to swap back again, if I find something was wrong with my application, I can switch it again. But if all's going well, great, I'm in production, and I can then release my next version of my application in staging, and then swap it again, as needed to. So we'll fast forward here while this completes. Okay, and we can see that that swap operation completed successfully. So let's go ahead and refresh both of those URLs. So here's the production one. I'm going to refresh it. And we can see that is now version 2 on the production URL. And if we go to the staging URL and refresh that one, we can see that that is no longer at version 2. That's been reverted back to version 1 because we took that old information from the production slot and put it into the staging slot. And that's it for deployment slots. I hope you can see how powerful they are. You can have multiple slots if you want to. The different SKUs allow for a different number of slots, but it's truly a great way for promoting code into production and just staging things and get them ready and warm, and then swapping them in at the last minute. Something goes wrong, we can swap back. So it has a big effect on DevOps and the community around that.
It's time now to talk about one of my favorite topics, which is serverless computing, and a welcome addition to the Microsoft certifications. For one, what is serverless computing? Well, it's an answer to many people don't want to spend all their time managing infrastructure, managing servers, all those things. They want to spend their time building great applications. And serverless computing essentially allows us to do that. It's the abstraction of servers, infrastructure, and operating systems, and just takes that whole pain away completely for you. The way it works is it provides you with fully managed services, and you'll see the major three that Azure provides. You only pay for what you use, so it's very, very cost effective, very easy to scale as well, because you're only paying when you use those functions or those logic apps or the event grid, as you'll see coming up. And finally, it's the ability to stitch together applications and services seamlessly is what makes it so powerful. So just a great service in general. But something to keep in mind, there is a server running somewhere. Ultimately, you write the code, or you create the logic app, or you work with the event grid, but Microsoft has to execute that somewhere. It's going to take that service that you've written and run it on some compute somewhere. Now there's three major computing services that you heard me kind of mention. Azure Functions, so these allow you to write different pieces of code in a lot of the common programming languages that get executed somewhere. Logic apps, which essentially are workflow engines, more of an orchestration type activity, more of a if this then that type option, if you've seen that on the internet. And then event grid is, if we'll just kind of, we have multiple triggers, multiple events going on. How do we, react to these events and fire off, the appropriate services in response? So all three of these work really, really well together. If we start with Azure Functions though, a number of key features. For one, supports the following programming languages: C#, F#, JavaScript, and Java is now in preview, so you may not get asked that on the exam, but just so you know for the future. Pay-per-use pricing is a key feature of all serverless functions really, but in particular for Azure Functions is a great thing, and it can be used in two ways. One as part of a consumption plan or an app service plan. So an app service plan, as you'll learn about if you cover in app services, is where you can put web apps and other apps on the same compute infrastructure that you have a plan for. So you can combine your Azure Functions there. So instead of you going pay-per-use in the consumption plan, you can just use them as part of your app service plan itself, and more on that later on. It does have integrated security with major OAuth providers, Azure AD, Facebook, etc., and you can code in the portal or deploy via your standard DevOps tools. Now, Logic Apps, on the flip side, a little bit different. They're essentially a workflow engine. They used to orchestrate and stitch together functions and services just like regular orchestrations tools. So if you've used ServiceNow Orchestrator or VMware Orchestrator, you'll probably be quite familiar with things like this, or even System Center Orchestrator if you've used that in the Windows world. It's the ability to visualize, design, build, automate. So think of that a little bit different. Azure Functions is all about taking our code, putting that together, maybe connecting it to other systems, making calls, etc. But we write the whole code out. Logic Apps is more about this visual orchestration engine that you have there, and supports a lot of different services, not just Microsoft services, as you'll see in the demos. In addition, there's some key constructs to understand here. You have the concept of triggers and actions, and you'll see this throughout Event Grid as well. The concept is, we have a trigger, something that happens that we want to react to, and then that fires off the action. So think about this whenever you're doing Logic Apps. What do I care about that happens? And then, do I want to send an email? Do I want to send a REST call? Do I want to start a function? Do I want to connect to Dropbox or some other service out there? That's the general concept with Logic Apps. And that's it for this lecture. Look at the upcoming demos where we go through Azure Functions and Logic Apps, solidify your knowledge there, and then we'll move on to Event Grid. In this demonstration, we're now going to move on and create a Logic app. So let's head over to the Azure portal to begin. And here you can see I'm already in the Logic app section. If you don't have this favorited, the easiest way to find it is just click All Services, type in Logic. You'll see Logic Apps pop up. Click the little star here to favorite it, and click Logic Apps, and that will take you to the screen. And this is where you can go ahead and click Add to create our new Logic app. I'm going to give it a name of SL Logic App Demo. I'm going to put it in the same subscription I've been using for all the other demos. Existing resource group, I've already gone ahead and created one called SL-Logic App. We're going to put in North Central US, and I can decide whether I want to send events straight to Log Analytics. So if I do have an OMS workspace already, I could choose it here, but right now, not really relevant for the purposes of what we're covering right now, but just know that that option is there for you. Let's go ahead and click Create, and that will create our Logic app, and then we can jump in and start designing. Okay, now that's completed. Let's just hit refresh, and let's click into our Logic app. And the thing I love about this is it takes you straight into the designer, which if you've used the tool IFTT, it's essentially the same concept. So if we scroll down, we can start to choose all the different triggers that are available. So we're actually going to do one when a new tweet is posted. We'll take that as our trigger, but you can see it's beyond Azure. There's multiple options here. When you get a new email, when an HTTP request is received, when Event Grid event occurs, plenty of options there. So we'll start with when a new tweet is posted, and we'll basically start with anything with the hashtag Azure. And the first thing you need to do is sign into Twitter account. So I'm just going to fast forward here as I get everything connected up. Okay, and I've connected it to my Twitter account, so I'm going to go ahead and click continue. Now what I can do is decide what I want to search for on Twitter. So we'll search for the hashtag Azure, and I want to search that every 1 minute. So if I change that to 1, and frequency 1 minute, and that's basically that step completed. So every minute it's going to check, Twitter to see, if there's anything with hashtag Azure. If we go to a new step now I can choose the specific action I want to take. So there's a whole bunch of those built in again. So I can click all, and you'll see all these different actions available to us. What we are going to do in this case is simply send a Slack message to my Slack channel. So we'll type Slack, and I'm going to click Slack here, and I'm going to post a message. And first, again, I need to sign into Slack. So I'm signing into that service using my Slack identifier, username and logon, and I'll fast forward again while I complete that. Okay, while I was signing in there, I just flipped over to our Slack channel, and I've obviously blurred everything else here, but you can see I've got a channel in here called Azure Tweets that I've just created, nothing in there. I've joined it, and every time this Logic app detects the tweet, it's going to post a message in this channel. So we'll go back over to the Azure portal. So back in the Azure portal now, I need to click the Azure Tweets channel for my Slack message to post into, and then I can choose the message text. So you can see I've got message text here, and on the right hand side, if we scroll over, it's going to pull various options from Twitter itself. So I can say, okay, the name of the user or the tweet text. So I might just say the tweet text and perhaps tweeted by, name of the person who's posted the tweet. So if I scroll up again, you'll see here, that's what's going to post into Slack in response to that tweet being posted. I can put the name of the bot here if I want. So I can say, this is my Azure Logic app that's going to post it. It can post as other users and things if we want to, but you kind of get the idea. This is all we really need to know for right now. With that, let's go ahead and make sure that looks good. Let's save that. That Logic app is saved, so we can go ahead and run that. And now we can monitor Twitter and see what happens. So we've got our Slack channel there. Go into Twitter. And we'll just post a tweet. We'll do hashtag Azure test, click tweet, and then we will wait for that to appear in our Slack channel. And you can see while we're waiting for my one to appear, there's already been 2 that have come in, one at 11 a.m. here, and more will continue to come in. And you can see the next lot has come in a minute later, and we've got hashtag Azure test from vnexc, which is basically, I could have put a space in between there, but you can see it's got the text, which was test, and then the person that tweeted it, which was vnexc. So we go back over to the portal. That's essentially all there is to it. Again, I can stop running that if I want to. I can delete this when I want to. I can go back into my designer. I can make changes here, but just a lot of options for connecting Logic apps to other services. In this demonstration, we're now going to look at creating a function app in Azure. So we'll head over to the Azure portal. Okay, and in the Azure portal, I've already created a resource group, and I've called it SL-serverless that you can see here. And the first thing I'm going to do is go ahead and create my function app. So I go to create a resource, and I can type in function, click function app, and click create. And at this point, similar to a web app, I need to fill in a few major fields here. First of all, the app name. This has to be a globally unique name that's out there, and this is the name that identifies your new function application. So we'll call this SL function demo, and we'll get a green check to say that is globally unique. Nobody else has that name. We choose our subscription that we want to bill for when we run the application itself, and then choose our resource group. Again, I can create a new one here, or simply select an existing one. So I'm going to choose that SL serverless resource group that we've already created. Now I have the choice of operating systems, so I can use Windows or Linux, which is currently in preview and probably won't be on the exam, but worth noting because things do change pretty quickly. But Windows is the main option there. For hosting plan, we've got a consumption plan or app service plan, as we mentioned in the lecture. So the consumption plan is just pay-as-you-go pricing. When you run the function, you pay for it. The app service plan means you'll use the same app service plan as perhaps web apps and mobile apps that you have out there. Now, if you click app service plan, it will prompt you to select that plan or create a new one. In my case, I'm just going to choose consumption plan. For location, this is the region where your application actually is going to run. So your function app will execute on servers in that region. So I'm going to continue to use North Central US for now. Then I'll have my runtime stack. So again, I've got .NET, JavaScript, and Java is in preview. Now note, if you do select Linux, you'll get different options down here. So if you select the runtime stack, you've got .NET, JavaScript, but you also have the option to publish code or a Docker image. So just something to be aware of, because Docker and containers in general are making their way into the certifications. So just something to note for now, but otherwise just select Windows if you're just trying this out for the first time. From a storage perspective, you do need a storage account. It will fill out a name for you to create one. That's there for you. And then you have the option of application insights, whether you turn those on or off. So app insights aren't covered in the certification course at all, but is a way where you can do monitoring and telemetry of your function applications, at the application level. So perhaps like transaction times and things like that. I'm going to turn that off for right now, so I don't need to specify a location for that to be stored in. So with that, go ahead and click create. That will validate and then create your function app. And we'll fast forward here while it deploys. Okay, and once that's deployed, go ahead and click function apps on the left hand side, and you will see your function app here. You can see SL function demo, which I'm going to click into at this point, and you can see, you can start, stop, do all the various things that you would usually do with any, Azure service at this point. Now what I want to do is go ahead and create a function. So on the left hand side, you can see I've got functions, proxies, and slots. So I'm going to go ahead and click this plus sign next to the function, because I'm going to create a new function. And I'm going to do this all in the portal here, and you'll see you can choose development environment, Visual Studio, VS Code, any editor, plus core tools or in portal. So in my case, I'm going to select in portal and click continue. And then what type of function do I want to create? So there's a number of templates available to you. We're going to create one with a webhook API. So this will be something that is triggered, when we go to an HTTP trigger to basically initiate that, as opposed to a timer, which allows us to run functions on a specific schedule. So perhaps I've got a job which needs to go and grab a bunch of images from Dropbox or some other source at some point, or from a bucket. That could be some function I run on a timer, or maybe I want to run the face recognition software against images I've got in my blob store. That could be something that you would run routinely on a timer for a real business application. But in our case, we're going to check the webhook plus API. So click create. Now at this point, we have our C# run.csx function ready for us. Basically, it's created a language-specific template for an HTTP triggered function because we're in the .NET framework. We don't need to cover any code for the purposes of this certification. That's more of the AZ300-Architect developer certifications. But we do need to know how to basically look at a function URL and know how to look at the logs. So let's click Get Function URL. Let's grab this code and let's just go to another tab, paste that in. And you can see, please pass a name on the query string or in the request body. So what we can do is we can just put a name at the end. So we can say and name equals, we'll call Skyline Student. Hit enter and you can see it says hello Skyline Student. And if we go back over to the portal, close this down and click the logs, we can see it there. You can see we've actually executed it twice, once when we didn't put the name in, and then the second time when we put the name in as well. So that's all there is to it for Azure Functions for right now. You can go to the Manage section in itself. You can basically enable or disable the function. You can stop the function, but there's nothing else that you should really get questioned on at this point. Again, it's an infrastructure exam, not a developer exam. So hopefully that gets you through just fine. In this demonstration, it's time for us to take a look at Event Grid and learn how to configure it, and we'll begin this demonstration in the Azure portal. Here we are in the portal, and the first thing we need to do is go ahead and create our Event Grid topic. So we'll type in Event Grid, and the topic is exactly that. It's a topic where we want to send, it's a custom topic that we want to send our events to, and then we decide who subscribes to those events. So the concept of Event Grid is essentially we can send events to it, and then we can have multiple services that subscribe to it and maybe take various actions based on the messages coming in. Now we go ahead and click Add to create our topic. Give it a name. Choose your subscription and resource group. So I'm going to create a new resource group for this one. AZ Event Grid, and choose our location. So I'm doing everything now in East US2, and then we choose the Event Grid schema or the Cloud Event schema. Now you might be wondering what the difference is between those. Well, Event Grid was the default and essentially the one you would always use, but Cloud Events essentially is a JSON open specification schema that's come out, and so now you can basically choose either of those, depending on your preference. But we're going to go ahead and choose the Event Grid schema. Click Create. And that will initialize and create our topic. And that's completed successfully. And if we go back and refresh, select the topic, we can see it there. And you can see at this point, we also have the option of adding an event subscription. Now, before we go on and do that, what we need to do is create a viewer so we can actually, view events coming in for this demonstration. Now, the great thing is Microsoft actually created a web app that you can use. It's called Azure Event Grid Viewer. In fact, we'll just Google that. And it'll take us to a GitHub page. If we click this one here, and then you'll see you can browse on GitHub, but it'll actually show you the whole solution and details around it down here as well. But if we go browse on GitHub, further details here, and we also have this option to deploy the solution directly to Azure. So we'll just go ahead and click that. It's actually going to deploy an app service for us. So I'll log in. And essentially you can see it's a standard ARM template deployment. I'm going to put this in my same resource group, AZ Event Grid. We'll give it a website name, so I'll call this AZ Demo EG, and that's good to go. Hosting plan name, we'll do AZ Demo Plan. Our SKU, we only need a very basic service for what we're doing here. So the free tier, the F series, is just fine for us. This is our repo URL, branch location. You don't need to fill any of that out. That was passed across from the GitHub template. But if we're good with that, we'll agree to everything here and click purchase. And that will now go ahead and deploy that app service for us as well. So we'll fast forward here and come back when that's completed. And that's now completed. So we'll go over to that resource group. We should see our new web app there. So you can see we've got the app service plan. Those are the underlying virtual machines, if you remember from the app service plan demonstrations. And then this is our web app running on top here, our app service. So if we go ahead and click that, and you'll see we'll have a website address here. So azdemoeg.azurewebsites.net. And if I just click that, we should see our event grid viewer, hopefully all up and running successfully.
And there we have it. That's definitely up and running. Now what we need to do is actually trigger this. So we need to do a couple of things. We need to send an event to our topic and then make sure it gets over to this event grid viewer application. So let's go back over to the portal, go back to event grid, and select our topic. And now we will go ahead and add that event subscription. Give it a name. So AZ demo sub. Again, we're using that event grid schema. Subscribe to all event types, and then we'll choose the endpoint type. And we will choose webhook. And it will select an endpoint. And you can see we have to enter the subscriber endpoint. Now what we need to do is go ahead and get the URL from our web app. Grab this one here and pop it in. And then we need to add API/updates to the end. Click confirm selection. And then go ahead and click create. Now that's essentially the API that we need to call from the event grid viewer application when we're sending events to it, so they'll show up in that web app. So we'll go ahead and click create. And after a little while that completes, and if you're unsure where the subscriptions are, just scroll down on the overview page and you'll see your sub here. You can see this is the webhook that we have. If we click into it, we can get details, and we can actually look at metrics and do filtering and things like that, right here when we want to. But how do we go and send that message, our test message? Well, Microsoft does give you an option to do it via PowerShell. Actually, some code, that you can basically use. And so we're going to use that. It's from the same, tutorial they do in the quick start guide for these. You do need to change a couple of things though. So when you sort of look at the PowerShell script, the first thing is the endpoint itself. And what it's basically doing here is going in and PowerShell's getting the Azure RM event grid topic from the resource group. So this is our resource group name that we have here. And this is our topic that we want to basically, send the message to. It's got to get the keys so that it can authenticate. And then it's basically going to go ahead and create this random, event ID, event date. And then this is the message we're going to send in their demonstration. The subject is my app/vehicles/motorcycles. And then they've got the Ducati Monster here. That's basically going to be sent over. It's just a simple message. You could send more data if you wanted to. If you're pretty good with JSON, you can, modify this as you wish. After that, it converts the text appropriately and then invokes the web request to the event grid topic here. So remember, we're not going directly to the website that we deployed. We're going to the topic, and then the event grid is going to push it on over to the website that we deployed. So let's give this a go. We'll go over to our PowerShell client and run this. Here I am in PowerShell. I'll just do a directory listing. You can see I've got event grid demo.ps1. We'll run that, and we get an issue there. So let's see what's going on. So AZ event. Oh, I've got the wrong resource group name in here. So let's confirm our resource group name. So AZ event grid. So let's just copy that and paste it over here and save that and run again. Okay, I've got another error. Okay, just an error in the command. So get Azure RM topic key is not working. That's because it should be get Azure RM event grid topic key. And try one more time. And looks like it's churning away there. So there we go. So here is our message that's basically being sent over via the web request. And now if we go over to the portal and refresh our overview, in fact, it's already come up here, and we can see one published event came through in the last hour. Here's our event. You can see it spike up on the graph. And now if we go over to our event grid viewer, we can see that the record was inserted. Now if I go ahead and run that again, same thing here. We should send a message across, and immediately we get another record inserted, and we can expand these out and look at these events there. So hopefully this kind of it's a very simple concept when we think of event grid, because we've got the topic, we send events to the topic, and anybody that's subscribing to the topic is taking action or just receiving them. In the case of this event grid viewer, it's just receiving them as a webhook, but perhaps it's a logic app, perhaps it's Azure automation, a whole host of things that you could send those events onto to take various action. And that's one of the unique features about it, because you can send it to one place. It's essentially your grid that can then fan it out to all the services that you need to talk to. And with that concludes this demonstration. In this demonstration, we're going to take a look at event hubs, and we will begin in the Azure portal. Here we're in the portal, and if we go to all services, we can choose Event Hub. You'll see Event Hubs come up. Select that, and we can go ahead and click Add to begin and bring up our Event Hub configuration screen. Well, first thing, again, if you're not too familiar with Event Hubs, this is a place where we can push a lot of events. It's a very real time. You can stream data into the Event Hub. It's, very high performance eventing, and then other services can pick those events up from the hub. Classic example of this is SIM tools, things like QRadar, Splunk, etc. We can choose to send data into the Event Hub. They can come in here and pull everything out of it. So the first thing to do is give it a namespace. So in my example, I'm going to be AZ demo hub. And that's got to be unique, so because it's at .servicebus.windows.net. We choose our pricing tier, so we've got this recommended standard. I just need a basic one here. For most workloads that you would use, you'll probably use standard, and just know this is 20 consumer groups, 1,000 brokered connections. Basic is 1 consumer group, 100 brokered connections there, and then you can also make it zone redundant if you want to as well, but it has to be supported in your specific region. So you can see there, none of my regions currently at the bottom support it, but if I scroll up, East US 2 supports zone redundancy because it's essentially availability zone technology in that region, but I don't need to do that for this demonstration. We choose our subscription, we choose our resource group, so I'll give this a new one, AZ Hub demo, new resource group, we'll just throw that into. And now you have the concept of throughput units. So essentially on the ingress events, that's data coming into the event hub, you get up to 1 megabyte per second of ingress events, but no more than 1,000 ingress events. So if you need more than that, that's where you kind of go up. And on the egress side, you get up to 2 megabytes per second of egress events. So those are events consumed from event hub, potentially again, QRadar, Splunk, etc. But you can get no more than 4,096 egress events. So you can adjust this based on the requirements that you're going to have, how many events you're sending in here, and then how many subscribers, if you will, collectors are coming in and grabbing things. Now you can also do an auto inflate, so you can click auto inflate, and if we scroll down, so we could start at 4, but we can say, okay, well, if things get really high on the throughput side, you can scale up to a maximum of 10, because obviously you are going to pay for these throughput units. So if we go ahead and choose whatever settings make sense for you for this, if you're just doing a basic demo, the lowest settings are obviously fine. We go ahead and click create, and then that will go and create our resource group and then our event hub. But while it's doing that, I will just jump into another one here called test collier. We can see it's just a basic one with 1 throughput unit in the basic tier here. The next thing we need to do is scroll down, because this is our namespace. Now we have to create our event hubs themselves, and this is where you would do that. So you've got event hubs, and I've gone ahead and created one here called test space already, but you could go ahead and click add event hub, opens it up, and then you give it a name. So we'll call it test space 2. And this is where we do things like partition count. So depending on the amount of readers that we have, it might make more sense to increase that partition count. There's some best practices on that on the Microsoft site. If you actually sort of mouse over here, you can also see that you can increase the number of partitions beyond 32 by contacting the Event Hub's team. You just have to put a ticket in to do that. But the number of partitions in the Event Hub directly relates to the amount of concurrent readers you expect to have. So if you have, say, 3, 4 concurrent readers, then you're going to want to go to a 4 partition count. Otherwise, things are just going to become a very big bottleneck there. Then you have things like message retention. You do require a slightly larger SKU for that, so the basic SKU won't allow that. You'll have to upgrade the namespace to do that. So keep in mind here, I'm creating the Event Hub in the Event Hub namespace, which is that service that you provision first of all. And then if you've got the larger SKU, you can go up to 7 days on message retention and also choose to capture it in a storage account as well. So that's basically the Event Hub and the Event Hub namespace. Well, how do we get our events to it? There's a number of ways and a number of services that can stream to the Event Hub. What we'll actually look at, though, is go to Azure Active Directory, because there's a really cool new feature there. If we scroll down on the left-hand side and go to audit logs, because this is a common thing. A lot of security teams want to audit environments, who's signing in, what's going on. And you go in our audit logs, a new preview feature where they allow you to export data settings. So if we click this, and you can see I've actually already added it here, but I could go and click add diagnostic setting and say, okay, I want to stream this to an event hub, so send to hub as an example. And you can see I can take those events and choose to archive to storage account, stream to an event hub, or send to log analytics. Well, in my case, perhaps I want that sign-in data to be picked up by QRadar or Splunk. I stream to an event hub. I select my event hub, so I can select one here, select my namespace, select my hub name, and hub policy. There'll always be a root to manage shared access key that's created, but you can create additional access policies just like with storage accounts if you want to. But there's my stream to event hub, and I can do multiple, so I could archive to storage account and send to log analytics as well. But then I do need to choose a log. So if I want audit logs, sign-in logs, simply select that, click save. I've already got this configured. So essentially now if I go back to my existing one, click it right here, I can edit settings. You can see the same concept. It's streaming to that event hub, and now in that event hub I can pick up data, like I said, to those other services. If we go over to the event hub itself, you'll see a couple other things. If I click events, just like with Event Grid, I can essentially build reactive applications. So basically by subscribing to this namespace as well, I can also create event subscriptions right here. If I go into the hub itself that I had from before, choose test space, you can see if I scroll down, all the metrics here. So it is sending data, and that's all that data coming from Azure Active Directory that's being sent over to the hub. Now, it's not a very active environment. If you have a lot of logins, then your environment would be very, very active here. So, again, just a great place where you're going to find this useful. If you're new to Azure, or if you're already an enterprise using Azure, you might already be using this throughout. Just a great, great feature, and something definitely to be aware of.
Before we can jump into the containers themselves, we do need to have a mechanism for running containers on our operating system. So we're going to go ahead and install Docker as well as Git for Windows. So let's head over to our web browser. And in our browser, I'm already at the website here, docs.docker.com/Docker for Windows. And this is a tutorial which you can browse through about getting started with Docker for Windows. But if we go ahead and click C, install Docker Desktop for Windows, and this prompts us to download from Docker Hub. So we select that. You do need to sign in order to download. So go ahead and register for an account if you haven't got one already with Docker. Otherwise, just proceed to log in to download. And then once you're logged in, simply click Get Docker Desktop Windows. It's a free download, and that will begin for you. While that's downloading, we do also need to go ahead and get hold of Git, and we can go over to git-scm.com, and you'll see download version 2.20.1 for Windows. You can just get the latest release, that'll be fine. Go ahead and download that as well, and that will begin downloading, and we'll fast forward while these download and come back to you. And as you can see, they've both been downloaded successfully. We'll go ahead and install Git first of all. Feel free to change the options here. I'm just going with the defaults for everything here, so I'm going to skip through this pretty quickly, and that will begin installing Git on the computer. Okay, and Git has completed. Now we'll do Docker. Again, same thing. We're just going to accept all the defaults and download and install that. Now we'll create a shortcut to your desktop, and the first time you run it, it will prompt you to sign out and sign back in again as well. So I'll fast forward again while everything completes here. Come back to you in just a second and show you that prompt. Okay, and there you see it. We just have to close and log out. And once we log back in, we can see we have Docker Desktop available for us now. Now if we go ahead and double click it, you'll see a little Docker icon appear. If you click the little show hidden icons, and you'll see Docker Desktop is starting. And then what will happen is you'll see this prompt, Hyper-V and container features are not enabled. Do you want to enable them for Docker to be able to work properly? Go ahead and click OK, and then you will be prompted for another restart as well. Okay, and as you can see, our final restart is completed. And if I click the little show hidden icons on the bottom here, you'll know Docker's running when the Docker Desktop has completed starting. But while it's doing that, I can right click and you can look at and see switch to Windows containers. Now, I don't want to use Windows containers. I'm going to use Linux containers for this demonstration. But if you ever wanted to run Windows containers in Docker for Windows, I know it sounds a little interesting. Why is the default behavior Linux? Well, a lot of Docker containers today are on Linux. And so if you want to run them in Windows, you actually have to switch to that as your default behavior, because the default behavior is to run them as Linux containers in Docker for Windows. So just worth pointing that out there. And once that's completed, we can just click the little Docker icon here and says Docker Desktop is running. We're now going to go ahead and open up a PowerShell window. So we'll launch that as an administrator. So we'll click Start, type in PowerShell, right click it, and run as administrator. A PowerShell window pops up, and let's go ahead for these demonstrations that are going to follow and create a new directory. So we're going to just go to the root of C. I'm going to make a directory called AZ demo, and I'll just expand this out so it's easier to see. And once we're in there, we'll just cd into AZ demo. Okay, empty directory as you can see. And now let's just check that Docker is actually running. So we can do Docker -- version, and we can see Docker is running 18.09.1. And let's also make sure Git is running as well. So Git -- version, and we can see we've got Git version 2.20.1 for Windows running there. So we are now ready for the subsequent demonstrations. In this demonstration, we're now going to prepare our application for Azure Kubernetes Service, and we're going to begin by downloading a repo from the Microsoft samples that are available on GitHub. So if we go to this website, which is on github.com/azure-samples, you'll see a number of samples Microsoft makes available here, and we go to azure-voting-app-redis. And this is a simple application that we're going to use. It's a voting application between who likes cats or dogs more, so it proves pretty interesting for our demonstration now. But what we need to do is just go ahead and grab this link here so that we can clone this repo to our local machine. So we've got the link there. We'll go back over to PowerShell from our previous demonstration. You can see we're in this AZ demo folder. I'm just going to clear the screen, and then we're going to go ahead here and do a git clone of that URL. So we'll paste that in, and you can see there it's basically going to clone that locally, and you can see it did that. And now we have a folder inside here, azure-voting-app-redis, for us to basically use. So we'll cd into that folder, and if we do a directory list in there, you'll see there's a number of different files that come along with that. Now in particular, what we're going to do is a Docker Compose. So there's a Docker Compose YAML file that's included for us. And if we open that up in Visual Studio, Docker Compose, if you're not aware, is a way to automate the building of container images and the deployment of multi-container applications. I highly encourage you to check out all the Getting Started guides on the Docker website if you want to know more about building the containers themselves. But for right now, we're going to use this Compose file to build what we need. And essentially, you can see the container names there. We've got Azure Vote Back, Azure Vote Front,
This is the front end, which is basically built on top of Nginx and Flask image as the base, and then the Redis image is used to start a Redis image instance as well for session state. So with that said, that's really the file that is there. It defines the ports, defines basically what we're going to build, and as soon as we run this, you will see it goes ahead and downloads those images. So let's go back to PowerShell, and the first thing we need to do is do docker compose up-d, hit enter there, and you'll see it'll go ahead and it's going to go and pull those different files from the Docker Hub and download them locally for us. And now we can basically look and see what actually happens. So if we go ahead and click in here and type in Docker images, you can see that those images are there. We've got the front end, the Redis cache, and you can see also that because one of the images is based off Flask, that is listed there as well, because that serves as the base. And the Redis, just to confirm, that's the Redis image used to start the Redis instance. So we're basically going to have two instances that start up. Now, in addition, we can see the containers that are running. So we can do docker ps. And as you can see, we've got a couple of containers here. So this container ID, that's our front end container. This one is our ID here for our backend, which is our Redis cache, and it gives you the uptime here as well as the ports that they're running on. Now we can also test this locally now. Now we know we've installed this on our local machine. If we open up a web browser and just do localhost 8080, we should see our application. This is our container running on our local machine, essentially running as a Docker container on top of that Docker daemon for us. And now we can click through. We can say, okay, if we like cats more, we can increase that. If we like dogs more, we can increase that one there. We can reset. It's just a simple application. Doesn't do too much, but it's a great sample app for our purposes. And with that, that concludes kind of building the app. If we want to go and clean everything up, because we don't really need this to run locally all the time, we can go back into PowerShell and just do docker compose down, same as docker down concept there as well. So this will basically stop that Azure vote front, Azure vote back, and everything is stopped now. If we do docker ps, we will see the containers are no longer running. But if we do docker image, we can docker images, we can see that our images are still there, our front end, our Redis, and the Flask base image as well. And with that, that concludes this demonstration. In the next demo, we'll go about pushing them to our own Azure Container Registry. In this demonstration, we're going to build upon what we did previously and create our own Azure Container Registry to push our container images into. Now, to begin, we are going to need the Azure CLI to run locally for this to work. So we'll go ahead and download that first of all. If we open up our browser, just type in Azure CLI download. This will take us to the download link for that, install the Azure CLI, and we can choose Windows, Mac, etc. I'm going to do everything on Windows as I have been throughout this lecture and demo, and we'll go ahead and click download the MSI installer. That downloads, it shouldn't take too long, it's a pretty small download, and then go ahead and install that. Now, just to point out, if you do have it installed previously, you can use your existing one. There's no reason to go back and do this particular step, but you do need to make sure you have version 2.0.53 or later for the items we're going to run throughout this demonstration. Okay, and up the installation wizard comes, and all we need to do is accept the terms and proceed with the install. And now that's complete, we can proceed. So let's open up PowerShell again. And let's just do an AZ login. And this will open up our web browser to log into Azure. Up it comes, we'll select our login. It says we're now logged into Azure. If you tab back to PowerShell, and you can see we're logged into the Visual Studio Enterprise subscription there. Okay, great. So now we need to go ahead and start making a resource group for us to use and put our container registry in. So we can go ahead now and just do everything from the command line. We can do AZ group create -- name, and let's give a name for our resource group. So we're going to do this AZ containers RG. So that's the resource group we're going to create. We'll give it a location, and we'll put this one in East US 2. And that should only take a second to create. And that's created. You get confirmation there. We can also just go over to the Azure portal and just verify everything is there. And we're logged into the portal. If I go to resource groups, I can see AZ containers RG, and obviously nothing in there yet because we haven't created anything. So let's go back over to PowerShell, and let's go ahead now and do AZ ACR create. So that's for Azure Container Registry. Now keep this in mind, a container registry is a private registry for us to put our container images in that we can then deploy from. So as opposed to being a public registry that we want to sort of grab from, this is private to us. We're going to create our own registry as that's what we do. And we're going to do AZ ACR create -- resource group. And then we'll put in, so AZ containers RG is the one we want to put everything in. Give it the ACR a name, again ACR for Azure Container Registry. This has to be unique within Azure itself, and so let's go ahead and call this AZ demo ACR. And then let's go ahead and choose a SKU for this. So we're going to go ahead and just use the basic Azure Container Registry SKU. That will go ahead and deploy. It should take about less than a minute to get this one done. In fact, already completed there. And if we go back over to the portal, refresh, we now see we've got our container registry available for us there. Okay, so now we want to log in to that registry. So let's do AZ-ACR, login, -- name, and our name is AZ-Demo-ACR, and that logs us into the Azure registry, and we should get a login succeeded message once that's completed, and there we go. So everything looks good there. Now let's just verify our local Docker images. So if we do Docker images, we can see we've still got those images from the previous demonstration, but to use the Azure Vote Front container image with the Azure Container Registry, we need to tag that image with the login server address of our registry. So this tag is used for routing when pushing container images to an image registry. And so what we can do is we can do an AZ-ACR list first of all to get our login server. So if we pop this up, and we can see here is our actual login server. Now what we need to do is tag our local Azure Vote Front image with this login server address of the container registry. So to indicate the version number, we're going to go ahead and add v1 to the end of the image name. So let's go ahead and do that. So let's do Docker tag Azure Vote Front. We're going to need to put in our login server now. So we'll go ahead and grab our login server, paste that there, / Azure Vote Front : v1. Okay, so now if we do Docker images again, we should see that an image, here it is here, version 1, is tagged with the ACR instance address plus that version number as well. So now what we want to do is push those images to the registry as well. So we built our image, we've tagged it, it's time to push it up to the registry. So we do a Docker push for that, and we grab our login server again, / Azure Vote Front v1, and this is pushing it up to the registry. So there it goes, and as opposed to us pulling it down, we're now sending those images up there. As you can see there, everything is completed successfully. Now let's just verify they are actually in the registry. So we can go ahead and do our AZ-ACR repository list, and we can specify the name of our repo, which was AZ-Demo-ACR, and just hit enter, and we should see our images listed there. And there it is. We can see Azure-Vote-Front is there as well. Now, if we also want to, we can go ahead and show the tags. We can do AZ-ACR repository, show tags, choose the name. So again, that's AZ-Demo-ACR, the repository, which is Azure-Vote-Front. And let's output that as a table for easier read-in. And there it goes. And we can see our result. Version 1 is the tag assigned to that Azure Vote Front image. And with that, this concludes this demonstration. You now have a container image that is stored in a private Azure Container Registry instance, and this image is deployed from ACR to a Kubernetes cluster in the next tutorial that we go through. In this demonstration, we're now going to go about creating our Kubernetes cluster in Azure, and to begin, let's head back over to our PowerShell client. Now, just to make sure you're ready for this part, you do need to make sure you have that Azure CLI version 2.0.53 or later. Just do AZ-version. That will come up and confirm your version. If you scroll to the top, you will see your version number right here, and that's what you need to make sure is correct. But with that, first thing we need to do is go ahead and create a service principal, and this is to allow the AKS cluster to interact with other Azure resources. And we covered service principals already in a previous module, so if you're not too familiar with them, I encourage you to just jump back to that module and then come back here, when you're done with that. But to create our service principal, we do AZ-AD SP for service principal, create for RBAC, and we're going to skip the assignment for right now. And hit create, and you'll get a bunch of values on screen that we're going to basically just copy for right now and pop those into Notepad. Now the next thing we need to do, and I've just cleared the screen here, is to go ahead and configure our Azure Container Registry for authentication. So we need to do an AZ-ACR, Azure Container Registry, show, and let's select our resource group, which was AZ Containers RG, and then choose the name of our Azure Container Registry, which was AZ-Demo-ACR, and hit enter. Okay, and this comes up, and you'll see here a couple of things. We've got our login server that we found previously, but there's another object just slightly above ID that we want to capture. So if we go ahead and just grab this ID, copy this, and let's put that in Notepad as well. Alright, and now what we need to do is go ahead and grant the correct access for the AKS cluster to use the images stored in the Azure Container Registry. So we're going to assign permissions to that service principal. So if we go ahead and do AZ role assignment create, choose the assignee, and that's going to be our app ID that we had previously. So I'll go back over to Notepad, I grab the application ID, sometimes known as the client ID, grab that, that's our assignee. Then we're going to do scope, which is the ACR ID. So let's grab this ID and paste it in there and give it the role of a reader. Okay, we got a small error there, so let's just double check that, and looks like we just missed a dash right at the beginning. So let's add that in under assignee. Got to watch out for the double dashes in the AZ versus single dashes, and click enter this time. And now that is successful. So now that's completed, we can go ahead and create our Kubernetes cluster. And what we need to do here is do AZ AKS for Azure Kubernetes Service, create, choose the resource group, so AZ containers RG, the name of our AKS cluster, so we'll call this AZ demo AKS, the node count, so this is the number of nodes that are going to be provisioned that our containers can run on. So we'll just do 1 for now. Our service principal, so service-principal, and that is our app ID again. So if we go ahead and go back to Notepad, that is this ID that we have right here. Paste that one in. Then we've got our client secret. So this is the password that was generated. So again, if I go back here, you'll see there's also a password option here. That's our secret. Paste that in. And then last thing we need to do is generate SSH keys as part of this. And this will take a few minutes, and it will go ahead and provision our AKS cluster for us. As you can see, that's completed successfully. So now we want to connect to the Kubernetes cluster from our local computer, and so we do need to use kubectl in order to do that. Now, if you are doing this from the Azure Cloud Shell, kubectl is already installed, but to install it locally, it's pretty easy to do. Just do AZ AKS install -CLI, hit enter, and that will go ahead and install kubectl for you, which shouldn't take very long at all. And that's completed as well. And what you will notice one thing, it says please add the kubectl path to your path, the environment path. And I usually do it with this one. I just grab the $env::path plus equals, so it'll keep the existing path, and then just add up to the kubectl part right here. So I'll copy that, just going to paste that, and then you can do environment path, and it will show you all the things that are in your path in Windows, and I can see this is the one I just added here as well. So with that, we can now go ahead and get some credentials so we can connect to our cluster. So what we do is we do AZ AKS get credentials, choose our resource group, AZ containers RG, and then our name of our AKS cluster, which was AZ demo AKS, and hit enter. And there you see it's merged AZ demo AKS as the current context in our config, and now we can go ahead and run kubectl to get the nodes that are currently running. We should just have the one that we deployed, so kubectl get nodes, and we can see we have that one node there running and status is ready. With that, this concludes this demonstration. Our Kubernetes cluster is up and running, and in the next demonstration we'll now take that application that we pushed up to the Azure Container Registry and run it on our Kubernetes node. In this demonstration, we're now going to take our application and run it on the Kubernetes cluster that we created in the previous demos. But let's just quickly head over to the Azure portal so you can see the Kubernetes node that is running there. And in the Azure portal, if we go to our resource group, so my AZ containers RG, you'll see we've got our Azure Container Registry there, and we also have AZ demo AKS, that's our Kubernetes service. If I click into that, you'll see our overview section come up, and you can see on the right our Kubernetes version 1.9.11. Here's our API server address, total cores 2, total memory 7, and on the left you can see this is running in East US 2. Now on the left-hand side, we can go and modify a few settings. We have our usual things like activity log, identity, and access management if we want to give people permissions, tags, etc. That's all the normal stuff we've seen over and over again in Azure. But if we go to upgrade, this is where we can choose to increase the version of Kubernetes. So we can go from 1.9.11 to 1.10.9 or 1.10.12 at the moment. And this does take about 10 minutes per node to do the upgrade. If we go to scale, this is where we can see the number of nodes that we have here. So I can go in here and I can choose to, and you can see that's going to take it from cores 2 vCPUs to 4, memory from 7 gig to 14 gig. So this is one area that you can scale. You can also do it from the command line, but you can also do it here as well. We also have dev spaces. And dev spaces allow us to share the cluster with our team. If we want to collaborate in a dev space, it's basically an area where you can develop your code in isolation for testing purposes. We've got our properties, standard Azure properties. We'll just see our version, DNS prefix, API address, some details around the node, etc. there. Our usual resource locks that we've covered in other modules, automation script we've talked about in other modules, and then we can also go in and look at monitoring. We've got insights, and metrics is now in preview. This is a service they recently announced where containers went into Azure Monitor. Basically it was officially supported, and hopefully this will be GA pretty soon. But this way you can go in, get your AKS resource, choose your namespace, and then choose your metrics. So number of pods by phase, total amount of available memory. You can start to pull metrics just like you can for like OSs and, host-based metrics as well. But with that, let's go ahead now and deploy our application. And to do that, let's go to the folder we created on our C drive. And you can see I'm in this PC, local disk C, AZ demo. We've got our Azure voting app Redis there. And what we need to do is go ahead and edit our Kubernetes manifest, which is this file, Azure Vote All-in-One Redis.yaml. So if we double click that file, and if we scroll down, the important part that we need to change is this section right here where it says containers image. It says Microsoft/Azure Vote-front v1. We need to change that, basically update the manifest file to basically point to our ACR login server name. Now, if you don't remember how to get that, we go back to PowerShell and we do AZ ACR list -- resource group. That was AZ containers RG. And what we get is our login server name. So let's grab that, copy it, go back to Visual Studio where I'm editing my YAML file, update this part right in front, and you can see that's our AZ demo Azure Container Registry, and we're still deploying the Azure Vote Front v1 container. So we'll go ahead and save that and come out of this. We'll CD to that folder, and we will do a kube ctl apply -f Azure Vote All in 1-redis.yaml. And you can see deployment of Azure Vote back created. That's our backend there. And our Vote Front has been created. Now what we want to do is check the progress on this. So let's do a kube ctl get service Azure Vote Front, and let's just watch it. And you can see it's waiting for an external IP. It's going to basically use a load balancer with a public IP address on it. And right now we're just watching it, waiting for Microsoft to provision that external IP. And once that is available, then we can connect to the service. Okay, and we can see that external IP is there. So let's go ahead and grab that, put it in a web browser. And there we can see our Azure Voting app is up and running. I can click the cats, click the dogs, reset. That is all working just like it worked locally, except now we push the image to the registry, and now we've deployed the container on top of the Azure Kubernetes service. Now, the last thing before we end off this demonstration on Azure Kubernetes service is how do we scale out the number of pods that are actually running? So if we go back into the command line and we do a kube ctl get pods, you can see that we have one instance of the front end running, one instance of the back end running, and we can also scale these out so we can have additional containers basically spun up for us. And if we go ahead and do kubectl scale, and we can do replicas equal to 5 to deployment Azure Vote Front, and that is going to scale out the front end. If we do the get pods again, very quickly we can see, pretty much all of them are running. One is still creating there. Let's do it again. They do happen very, very quickly, and you can see all of those are running. We could do the same for the back end if we wanted to. You can also do auto scaling on pods as well. So if you want to automatically scale them up and down, say perhaps based on a CPU metric or something like that, you can do that. And there's documentation on the Microsoft website for that. We don't need to know specifically how to do it for the exam. Just know that
auto scale of pods does exist there for you. And you can do it based on requests, say, of CPU. You could say, when requests are at 0.25 CPU, you could do a limit of half a CPU. There's different sort of metrics you can play around with there. Now, in addition, we can also scale out the cluster itself, but here we do AZ/AKS scale. So you can see the difference. When we do in the pods, we're in the cube CTL. When we want to scale out the cluster itself, we're back in the Azure CLI. So we do AZ/AKS scale, and we do resource group, AZ containers RG, and name. So it's AZ demo AKS. And we just set the node count. Again, this is the nodes that the Kubernetes, again, these are the nodes that the containers will run on top of. So we'll do node count 3. Now this does take a little bit of time because it has to spin up those additional VMs that ultimately are available then for the containers to run on top of. But with that, nothing ready to see. Once it's completed, it'll just show you that there's three nodes running. We basically concluded this demonstration, and you've learned, how to create a container, how to use the container registry, how to run your application in Kubernetes, how to scale it up and down. Now that could be the pods or the nodes being the underlying architecture that needs to support everything, and the pods themselves being the containers that are running on top of it. And with that, this concludes this demonstration. Let's begin by looking at Azure Migrate, and Azure Migrate is a service for assessing our on-premises workloads for migration to Azure. It's an Azure service that's available in the Azure portal, as you'll see in one of the demos later on. Now what it does is it assesses for Azure readiness. So are my machines capable of running in Azure? Are there any specific compatibility issues that I need to address before I can bring that workload over to Azure? Now in addition to just looking at the workload, it also looks at the appropriate sizing for it. So can I get approximate sizing recommendations based on its performance on premises? An example of this is there's a lot of cases where virtual machines running on premises, say that might have 8 CPUs, but it's not really using all of that CPU value. Maybe it's only using 20, 40%. It was oversized when it was provisioned on premises. This is a good opportunity to resize it as you move it to the public cloud, because at that point, we can save some money as well. And the cost estimation is part of Azure Migrate. Based on the sizes selected, how much is it going to cost me to run in Azure? Now, the final part that's really interesting is dependency mapping, because you can visualize dependencies in order to plan waves of workloads for migration appropriately. Now, examples of that might be, okay, I've got this one workload, but I can't move it without moving this other workload because it contains the data that this workload needs. So workload A is maybe an app service that depends on the data in workload B, or moving them together makes more sense, and you can cut those over together when you move them into Azure itself. And so this dependency mapping, which does rely on an agent, so can't just do it agentless, but it does give that extra, detail and can sort of build this web mesh of what everything's connected to. And then in what you know about the business, and the application teams can help kind of figure that out and decide the appropriate waves. Now, how does this all work in practice? Well, first of all, if you look at this diagram, which we've got from the Microsoft website here, step 1 is to download and configure an appliance. So that's a virtual appliance that you'll actually deploy on one of your ESXi hosts and basically target your vCenter. Once that's in place, that data can start to be collected. Essentially you start discovery, and it sends raw metadata. It doesn't send any actual data from the applications or database servers, etc. It's just sending metadata to this collector VM. That metadata is sent in raw format up to the Azure Migrate service. It's then processed and made available to you in the Azure portal. And the final thing you just need to do then is create an assessment. And an assessment is essentially, say a group of machines that we want to assess and decide what the appropriate, recommendations are, and different things we can toggle around those recommendations as we put them into Azure. Now, there are some limitations for Azure Migrate. First of all, it's a VMware assessment only. So in order to assess Hyper-V, and this may be a question that you get in one of the exams, you do need to use ASR Deployment Planner, which is Azure Site Recovery Deployment Planner. It can do up to 1,500 VMs in a single discovery and project, but for large environments, all you need to do is just split the discovery into multiple assessments, and you can execute up to 20 projects per a subscription that you have in Azure. Projects can only be created in the US regions, and the metadata is stored specifically in West Central US or East US. Now, logically, you're probably thinking, what goes into an assessment? I've got all this data up there, this raw data, processed data from Azure Migrate. Well, there's a number of key things. First of all, you've got your target location. This is your target region in Azure, and this currently supports up to 30 of the Azure regions that are available for your assessment. Your storage type, that's whether or not using premium or standard disks, premium being the SSD disk, standard being the spinning disks, and performance-based sizing will actually give you a recommendation on this. It will pull that data from the I/O that it sort of detects from the vCenter data that is incorporated as part of the metadata that comes up.
The sizing criteria, so do you want to base it on performance history of the VMs or not? That is something you need to decide. This is really important, hybrid benefits. So if you've got Windows licensing that you can bring across to Azure, you can save additional costs with the Azure Hybrid Benefit Program that reduces your CPU and memory costs of that instance because they give you a credit for the licensing. So technically not the CPU and memory that's reducing, it's just the instance cost that's been reduced because you have existing licensing. Reserved instances, you can determine whether to utilize RIs, also known as reserved instances, to further reduce costs. So that's where I say, okay, I'm going to commit to this machine for say 3 years. I don't necessarily have to pay the pay-as-you-go pricing. I can pay the reserved instances pricing then. VM uptime, so the duration when the VMs will be accessible. If we don't need this VM to be on 24/7, typically on premises we do that because we've paid the capital for the VMware hardware already. In the public cloud, when we're not using it, we're saving money. So VM uptime is a factor there. The pricing tier, so for A series VMs as an example, you might have the basic tier or standard tier that you want to choose between. Performance history, do you want to go just for the last day? Do you want to go for a longer period of time? And finally, the VM series types that you want to include. So do you want to include A series? Do you just want to look at D series? Do you want to look at E and F? Those are all decisions that you can make as part of the assessment. The next really important piece to consider is the comfort factor. So this is very important. Azure Migrate considers a buffer, which is a comfort factor during assessment. Now this buffer is applied on top of virtual machine utilization data for the VM, so CPU, memory, disk, and network. So this accounts for things like seasonal usage, shorted performance history, etc. You're basically saying, okay, you've got this recommendation for me, Azure Migrate, but I want to be a little bit more comfortable with it. So for an example, a 10-core VM with 20% utilization, you'd be saying, okay, well, they oversized that on premises. Maybe I can get away with a 2-core VM. However, if you choose a comfort factor of 2x and you say, no, I want to go double, then it's going to recommend a 4-core VM instead. The default comfort setting is 1.3x. That's built into Azure Migrate by default. Now, here are some examples for you. A source machine, again, with 10 cores, 20% utilization, that 2x comfort factor would give us the 4 cores that we just mentioned. But take a look at the next one. If I say I've got 10 cores, that's 50% utilized. This is maybe what comes back from vCenter that when we're looking at the performance data. Recommended CPU would be 5 cores. We times that by our comfort factor of 1.3x if we're using the default. That would give us a 6.5 core recommendation. Well, that's not realistic because there's no 6.5 core VM in Azure. So it's going to round you up to the 8 core instances. So the recommendation would be 8 because you can't have a half core and no 7 core VMs exist. Next and final one in this example, 10 cores. Let's say they're 20% utilized. That would have been a recommended CPU of 2 cores for the instance type. Well, if we leave it at the default of 1.3x, we would get 2.6. Again, not realistic. We can't have a 3-core VM in Azure. You can technically have odd number of CPU counts on premises, but they don't offer them in Azure. It's all even numbers. So the recommendation would be 4 in that case. And this is very important. You need to look out for this on the exam. Make sure you take into account the comfort factor and know how it works. And it's common sense. 2x is going to give us 2 times, but make sure you know what the options are that you can actually use in Azure as a result of that comfort factor. Finally, we have port requirements. So we have things like the collector itself. That communicates with the Azure Migrate service that runs over port 443. The collector also talks to the vCenter server. That is over 443. If your vCenter was deployed with a different port number, you would need to change that as part of this installation. And finally, the on-premises VMs need to communicate with Log Analytics Workspace in some cases, and that is over port 443. With that, this concludes the lecture portion of Azure Migrate, and check out the subsequent demo that will help reinforce this knowledge, and you'll see how to deploy this and get that data into Azure and run an assessment. In this demonstration, we're going to perform an Azure Migrate assessment, and to get started, we'll head over to the Azure portal. And in the portal, I'm going to create a brand new resource group. You'll see I already have one already created called AZ101 Migration. That's my pre-completed one that we're going to come back to. But to show you the steps to get there, we'll start with AZ101 Migrate Demo. So that's just a brand new resource group we'll create in our subscription. And that's created. And now what I'm going to do is go to All Services and type Migrate. And you'll see Migration Projects comes up. We'll select this one. And you'll see I've already got that ready, pre-created one, but I'm going to create a brand new migration project first of all. So we'll click Add and give our project a name. So we'll call this AZ101 Migrate Demo. Choose our subscription and choose the resource group that we want to put that in. And that's going to go in that Migrate Demo one that we just created. And go ahead and click Create. That takes care of creating a migration project for you, and that's the repository that's going to hold all the data that we're going to assess from our VMware environment. So the goal of this migration project is to look at a VMware environment that we've got on premises, look at all the virtual machines that we've got in there, pull that data in, and look at the assessment that we can do that comes out of that. So that's completed, so we'll go to that resource. And the first thing you'll see on the bottom, it says Getting Started, Discover and Assess. So you click Discover and Assess.
and it'll say step 1, discover machines, and step 2, create assessments. So the first thing we need to do is discover those machines, and if you click this, what you will see is it prompts you to download a collector appliance. Now for the exam, one-time discovery is covered. Eventually they will add this continuous discovery, which is a slightly different download. But for now, we're going to focus on one-time discovery. Once we've downloaded that appliance, you basically create a collector virtual machine in your VMware environment. You configure the collector to start discovery, and you'll need these project credentials as part of that. Now to show you this, I've actually VPN'd into my VMware environment, and I've got an RDP session open here to a jump box. So in here, you can see I'm in a machine and I'm looking at a vSphere web client. So if you're not too familiar with VMware, it probably makes sense for you to download VMware Workstation and learn how to build a VMware environment, just so you know how to deploy ES6i, etc. Now that's not going to be covered in the exam. What you do need to know though is how to deploy the appliance itself, which we're going to show you here. So to begin, I've got a folder called Migrate Demo, and I'm going to go to Actions, and I'm going to deploy an OVF template. If I select that, this is actually deploying a virtual machine on VMware, and it prompts you for a URL for the machine, which we can't use, but we can use a local file, and click Browse, and select that Azure Migrate OVA file. Now you might be asking again, where did I get this from? Well, before we continue here, I will just go back over to the portal, and you can see under Download Collector Appliance, that's this OVA file right here. If I click Download, it takes me to a Microsoft Download link, and there you'll see it asks me what do I want to do with it, and all I've done is I've pre-saved it. It's quite a big file, 11 gig that you download, because it is an entire virtual machine that gets downloaded. So I'm going to cancel that for now, but just know that I've completed that step already. So back over to my jump box, and we'll click Next. Let me get rid of this download link here. And then I have to give it a name. So under this folder, this is where I'm going to put it, AZ Migrate Demo. I give it a name. I'm just going to leave it as Azure Migrate 10915. Click Next. Select a resource. So this is where you actually select the VMware hosts that will run this virtual machine. So in my case, in this cluster, I've got a management cluster and a resources cluster. I could select a specific host, or I could select the cluster itself at the top and let VMware decide which host to place it on. So click Next. I've clicked the management cluster. It's validating to make sure it's got appropriate resources there that this machine can actually run on. Okay, that's completed. I can review everything. I can see that it's got a download size of 11.7 gig. That's the OVA downloaded, but this is the size it's actually going to be on disk. And you have a couple of options. Yeah, not too important for the exam, but just so you know, thin provisioning is where it creates the blocks on the disk as it's needed, as opposed to thick provisioning where it pre-creates that entire disk for you and consumes that size from the storage array. But for now, I'm going to click Next. And then I'm going to go ahead and choose where I want to place it from a storage point of view. So we've got a tin tree storage array here that's connected to the VMware environment, and I am going to select thin provision for that disk format because I don't want to consume all that capacity now. And then go ahead and click Next again. Selecting the network decides which network the appliance is going to run on, and again, this will depend on your specific environment. So for now, I'm just going to click VM Network, click Next, and it's all ready to complete, and we click Finish. And what will happen then, I'll just do it, I will cancel it in a second. You'll notice a whole bunch of tasks will appear. If I click the Home button right here, scroll down to Tasks, and then I will see that task where it's deploying the OVF template, it's importing the package and deploying it at the same time. Now I'm not going to continue, I'm going to cancel that out because that's take a long time, and we've already created one for you to see. So we'll go back to our VMs and templates section in VMware. And now I'll click the AZ Migrate Ready. These two VMs you see here, these are just my jump boxes to get into the environment. But the one I created previously was called AZ Migrate 01, which I have here. And now I'm actually going to RDP into that machine. So I'm going to connect to it remotely. If I come out of this RDP session and open up my other window, you can see it's asking to do Windows updates on it, but I can just cancel that. And you can see I'm in the collector itself now. So when you RDP into it, the only difference you will see is that you have to set up your prerequisites, specify your vCenter server details, and specify the migration project. So if I expand the migration project, this is where I put in that project ID and key that you can see in the portal. So if I minimize this for a second, if we scroll all the way down, and you can see in our migration project, copy project credentials, and this is the ID and key that I've used here. So I'm going to take those and go back over to the machine that got deployed, the Migrate virtual machine that Azure's deployed. You deployed it in your VMware environment using that deploy OVA, and this is where I would put that project ID and product key. In addition, you will have set up your vCenter details. This is going to be, your vCenter server address, your username and login for vCenter itself, and you'll connect that, and when it's connected, it will go green. And just going back to some of the prerequisites that would have been done, you just have to make sure this machine can connect to the internet, it's connected to a time server, and it will take about 10 minutes or so to update Power CLI 6.5. You'll see that happen as soon as you connect into it. When all of that is complete, you'll basically kick things off, and you'll see collection progress happen, and you can see at this point, my collection is actually completed. 187 machines have had their data collected. Now, again, that's not the data from inside the machine, it's just the metadata from VMware about the performance and sizing of the machine. And so now what I can do, I can go back to our portal. I'm going to go back to home. I'm not going to use that assess that I was starting to do. I'm going to show you the one we completed previously. So I'm going to choose the AZ101 migrate-ready. We'll click in here and you can see 187 machines. You can click on this. It'll actually give me details of all those machines, the memory, etc. But now I can go ahead and create an assessment. So if I click create assessment, here I can choose to create a new group, so I can group machines by waves and select the machines. I can just say select all machines, and if I scroll down so you can see more, these are just the machines that were collected. I can choose some of them, or I can choose all of them. I'll choose all of them, and I can create a group, so I could call this like wave 1, or maybe these are just prod machines, and give it a name, whatever you think is relevant based on what you know about those machines. Now this part is very important for the exam. You'll see this button here, it says view all under assessment properties. So if we click this is where I can toggle all the different details. So which region am I going to put these VMs if I do migrate them? What pricing tier do I want to choose, standard or basic? What type of storage do I want to use, premium or standard HDDs? Do I want to take into account those reserved instances? Obviously, that's going to save money as well if I use reserved instances. Sizing, I can choose as on-premises or performance. If I select performance-based or as on-premises, how much performance history do I want to take into account? 1 day, 1 week, 1 month. And this is important. Which percentile do I want to use for that data? So if we use 95th percentile, the performance history, will include everything under 95% there. And the VM series, I can choose my different ones. So I can choose, DSV2, ES, etc. I could just unselect this. If I just wanted to choose DSV2s, I could do that as an example. This is part of what goes into the comparison. Now, one thing you remember from the lecture, we talked about comfort factors. So at this point, I can choose, if I want a 2x comfort factor, I would choose that there. So again, a 10-core machine, let's say perhaps was running at 20% CPU, then it would be typically 2 cores, but because of my comfort factor of 2x, it would be a 4-core machine that it chooses. And then some of the pricing things, any discounts applied, hybrid benefit, those things that you would deal with your Microsoft sales representative on if you had an EA account to get, different pricing, etc., if that was relevant to your specific situation. So with all of that, once you've decided what you want to do, you click save, and then you would basically run your assessment. Now, again, I've also created one of those ready for us to look at. So let's take a look at a pre-created assessment. Okay, and now we're over in Excel because I've actually got a pre-created one from a customer that I've sanitized for you to take a look at. So I've replaced all the machine names with machine 100 plus here, but they would have been, actual VM names, operating system names, if this was the real customer one. And then you can see things here along the top. So is it ready for Azure? So sometimes it's going to say, yep, it's completely ready, nothing required, or maybe it's ready with conditions. And that could be based on support and things like that for certain like Linux distributions as an example. Recommended size, this is the instance type it's recommending we go to, and it will actually tell you the compute monthly cost based on some of those toggles we selected. Storage cost, the operating system in question here, the boot type, BIOS, cores, so this is 4-core machine with 4 gig of memory. If it's got any good CPU usage data, sometimes you're going to see everything as 0 here from this actual assessment, and that's because we didn't grab all that performance data, we just immediately grabbed the specs of the machine. But if you wanted to get the performance data, you could do that as well, and it does require that you have sufficient login turned on in your VMware environment also. Storage, hard disks, SSDs, premium, all of this information is here for you. How many network adapters are on the machine? If you've got network throughput, that would show here as well. And the vCenter it's coming from, and the vCenter server inventory scope. So there's a concept in VMware called the data center object. That's where you would see the data center listed here, and the group name itself. Those are the groups that you could give it. So that's basically what there is to it, and everything here is pretty much what you need to know for the exam. The key thing is really around those comfort factors, knowing that if you're doing a 95th percentile, the 50th percentile, know that, make sure you understand that, and just know that you have to download that OVA appliance. You need that project ID, that project key, in order to connect that to VMware, and in turn connect it back up to Azure so it can send that metadata up for you. And with that, this concludes this demonstration. In order to fully understand ASR, let's take a quick review of the business continuity strategies. Well, for one, we have high availability that you probably heard about in the AZ100 or just when you're looking at virtual machines. And that's where we used availability sets or now availability zones, so we can make sure we have another instance of our application running in case of a catastrophic failure. In addition, we have the concept of disaster recovery, and this is where ASR really fits in because we can run our apps in a secondary data center if failure occurs. And this is also the same technique now that can be used for migration, because if we're able to recover it somewhere else, it's also a way we can migrate it somewhere else as well. And finally, we have backup also in the event that we need to restore data, perhaps the files become corrupted, or perhaps we do want to restore our data into a new machine in another data center or another Azure region. Backup is a fundamental way you can do that as well. But if we look more specifically now at Azure Site Recovery, also known as ASR, that's an acronym you should become familiar with, there's a number of key features. For one, you probably know it as an on-premises to Azure recovery tool or migration tool. It allows us to take VMware workloads, Hyper-V workloads, and replicate them to Azure for recovery or migration. It does Azure to Azure recovery as well, so we can take our workloads from a primary region in Azure and replicate them to a secondary target region. This allows for the case of a complete region failure. If we have an application that has to be highly available at all times and we want it to be recovered elsewhere, we can set that up also. One of the features I love the most about it is just the automation and orchestration integration. So there are recovery plans that you can build that dictate, say, the order in which services come up, but also you can run scripts or you can integrate with Azure Automation to access additional things that you want to run after services come up. These could be re-IPing, it could be just running something around services that you're starting up on your OS. Those are all things that are possible. And finally, there are RTO and RPO targets. There's this concept of continuous replication for Azure, and that's from VMware and Hyper-V as well. If we look at ASR replication frequency, there are three you need to know about. You can do 30 seconds, 5 minutes, or 15 minutes for your replication frequency. So every 15 minutes, it will replicate that data up to Azure as an example, but you can go as low as 30 seconds. For VMware to Azure recovery, let's look at what this means, because this is the most common scenario, and the scenario you definitely need to be aware of for the exam as well. We've got our VMware hypervisor running on premises. If you saw the Azure Migrate module that we covered, that showed you that, we could have loads and loads of VMs out there that we've sort of assessed and want to migrate them because we think, okay, there's a cost benefit or some good use cases to do that. Well, ultimately, we need to get them to Microsoft Azure, and that's what the VMware to Azure recovery or migrate option is essentially, allowing us to do. Well, the process for that is as follows. It converts the VM to a VHD, it uploads it to Azure, puts it in a recovery vault, and that's where you complete your migration. It's a very simple process in itself. You're taking a VMware virtual machine, which is based on what's called a VMDK file. We're converting that to a VHD and then running it on Azure Compute now instead of the Compute, rack-mounted servers that we would run in our data center. The migration process that you need to go through and do need to understand for the exam as well is as follows. You do need to prepare Azure, prepare VMware, and then set up recovery. And we will walk through all those steps in the subsequent demonstration so you can understand. So for preparing Azure, you need to understand the following. You need to verify your account permissions in Azure itself. So can you create a VM in a resource group? Can you create a VM in a selected network that you're going to connect this VM to? And can you write to the selected storage account? And again, we'll go through those in the demonstration. You'll create a storage account. You'll create a recovery services vault, and you'll set up that Azure network. Those are the prerequisites that you do need to have in place before you begin, and those are all on the Azure side. On the VMware side, we need VMware permissions also, which we do reference on the next slide, and you can also see referenced on the link below. We need to prepare an account for mobility service installation, so that allows us to install the agent in the machine. We need to verify compatibility, so you do need to make sure there's a whole support matrix, from Linux VMs, Windows VMs, all our post failover configuration. We just need to understand what's going to happen when we move our machine over to Azure. It'll replicate, it'll probably come on fine. In some cases, you just need to try it to see, but you do need to have a plan for that recovery as well. And that really is around this preparing connectivity to Azure VMs as well. Once you've recovered a VM in Azure, can you connect to it? Do you have hybrid network connectivity set up back to on-premises if that's something you need to do? Can my users, perhaps point to site VPN into Azure to access those VMs? Or do I have a jump box with a public IP? Those are scenarios that you need to understand, when you're thinking about your environment and how you're going to get those VMs over from VMware to Azure. Here are the account permissions. We're not going to go through all those in detail in the course here right now, but definitely take a look at this. It'll be referenced in the study material as well. But a few quick things. You do need to be able to discover VM objects in your VMware environment, and then to do full replication, failover, and fail back. You'll see there's a whole host of permissions that you need there on virtual machine configuration, creating virtual machines, allowing download of virtual machines, snapshotting, all those things, are required for this to be successful. So with that said, this is the overview of Azure Site Recovery and should give you, the basics you need to understand to get this going. And like I said, check out the upcoming demo and we'll walk through this in more detail. In this demonstration for Azure Site Recovery, we're going to look at preparing the Azure services that we need in order to start that recovery from our VMware environment. So to begin with, let's head over to the Azure portal. Okay, and here we are in the Azure portal, and the first thing you can see is I'm already in a new resource group called SL-Azure Site Recovery, and that's the resource group we're going to use to put in the objects we need to create. To begin with, we need to create a storage account. So we'll go ahead and go to All Services, type Storage, select Storage Accounts, and we'll click Add to create a brand new storage account. So we will put this in our subscription. I'm going to put in my Skyline's primary subscription. The resource group I'm going to select will be SL-Azure Site Recovery for this demonstration, and I'm going to give it a storage account name. So we'll call this SL-ASR1. I'm going to put that in North Central US. Performance, I'm just going to use standard disk for this one, and for account kind, the recommendation from the ASR team is actually to use GPV version 1, so we will select that, and then I can choose my replication option. In my case, this is just a demo. I don't need, geographic replicated storage. I'm just going to have locally redundant storage in the data center chosen. So we'll click Next to go to the advanced settings. Nothing we need to select there at all. If we wanted to do a virtual service endpoint, this is where we would do it for storage accounts, secure transfer required, and data lake stuff. None of that's relevant for us right now. Tagging, always a good practice, as you've probably seen in other modules that we've covered or other courses where we've covered tagging. Nothing we need to do right now. We can simply click Next to review everything we've got there, and we're just creating a basic storage account. Again, just make sure it's that GPV version 1, give it a name, put it in your resource group, and you're good to go. So go ahead and click Create. Okay, and that will begin deploying. While that's underway, we will get started on the next piece, which is the Recovery Services Vault. So we'll go back to All Services, and we will type in Recovery Services Vault, and you'll see Recovery Services Vault comes up. Click that, and you can see that storage account has successfully deployed. We'll close that out for now. And I've got a previous Recovery Vault in there already, but I'm going to go ahead and create a brand new one. You can have multiple Recovery Services Vaults in your Azure subscription. So we'll call this one SL-ASR Vault Demo. And I'm going to put that in the same subscription. I'm going to put it in the resource group again, SL-Azure Site Recovery, and I'm going to keep it in North Central US and click Create. That will go ahead and create our Recovery Services Vault for us. And finally, I do need to have an Azure network that I'm going to connect my virtual machines to when they get recovered in Azure. So I need to create one more service, which is our Azure network, and I'll just click Create a Resource this time. I'll type in Virtual Network, select Virtual Network. As you can see, while we're busy there, the Recovery Services Vault alert popped up to say that's been created. I'm going to go ahead though, click my virtual network here, and click Create, and it's now going to ask me some questions around virtual network creation. And we'll give that a name, so we'll call this SL-ASR VNet. We'll give it an address space, we'll just go 10.1.0.0, we'll do a /24 there. And that's going to give us up to 256 addresses in that virtual network. Again, I'm going to put it in that same subscription. I'm going to put it in that same resource group, SL-Azure Site Recovery, North Central US. I'll give it a subnet, so we'll call this Recovery Subnet. And I'm going to give it a range, so we'll go 10.1.0.0, and we'll start with a /26 as an example. We'll start to carve that VNet out. So this subnet inside of that VNet is going to allow me 64 addresses. These other settings aren't relevant for what we're doing right now. We're not going to create any firewalls, any virtual service endpoints, any DDoS protection. Everything is standard there, so we'll simply click Create. And that deployment is now in progress. So we'll head over to our resource group while that's going. And we'll go down to SL-Azure Site Recovery, click that. And in there, and it looks like that VNet's almost done. We'll probably see the alert pop up any second. We'll just click refresh, and we can see we have our SL-ASR1 storage account. I've got the vault, yep, and you can see that virtual network is completed. SL-ASR Vault-Demo, and my VNet, I've got SL-ASR-VNet, and if I click into that virtual network, it should all be completed. If I click the subnets, we'll see that subnet, the recovery subnet, is there as well. So with that, this completes this demonstration, and in the next demo, we'll look at our VMware environment and how we set up a VM for recovery into Azure. In the previous demonstration, we set up the necessary requirements on the Azure side so that we can perform Azure Site Recovery. In this demonstration, we're going to look at the additional steps we need to take to set up recovery from VMware. So let's begin in the Azure portal. In the Azure portal, we're in the resource group SL-Azure Site Recovery that we created in the previous demonstration. And you can see I've got my storage account, Recovery Services Vault, and Virtual Network there. I'm going to go ahead and click the Recovery Services Vault first of all. And once it comes up, you'll see you have the options of Backup and Site Recovery. To select Site Recovery, any replicated items that are in effect will show up over here, and recovery plans, etc. will be at this place as well. At this point, on the left-hand side, you'll see a Getting Started section for Site Recovery, which we'll click first of all. And at this point, you can see it says for on-premises machines, prepare infrastructure. So let's click that, and then we choose our protection goal. Where are your machines located? In our case, on-premises. Where do we want to replicate those machines? Well, to Azure in our case. The other option would be to recovery site, but if we are trying to do a migration here from on-premises to Azure, which hypervisor are we using? So yes, it's VMware vSphere hypervisor, but Hyper-V would be an option as well as physical. If we click OK, it will then ask us for deployment planning and how we run the ASR deployment planner. You are required to do this. This gives additional information on bandwidth utilization and storage requirements, etc. So you can say you've done it if you have, or you can run it later on. It's not completely a requirement, but it is recommended that you do it so you can really understand the capacity requirements for your recovery itself. Click OK on that. Now we can go ahead and prepare the source environment. It says select configuration server. So right now 0 servers are found. We have to add a configuration server, which we'll do by clicking this plus sign for configuration server. And at this point you'll see we have to register our on-premises server from VMware, and that requires, just like with Azure Migrate, if you saw in the very first module of the course, around downloading that OVA file that we deployed to vCenter, same principle here. We have to download a virtual machine template. It's about a 20 gig file that you download and install in your vSphere environment. So let's hop over to VMware and have a look at how you deploy that. Okay, so here I am over in VMware, and I'm already connected to Virtual Center, also known as vCenter. If you're not familiar with that, vCenter is a management tool that's required to look at your VMware hosts, folders, VMs, etc. that are running, and VMware is obviously beyond the scope of this Azure course. But to begin, I need to deploy that OVF template or that OVA file that I downloaded. So I can go ahead, look at my downloads folder. If I go in there, and you can see I've already got Azure Site Recovery configuration server.OVA. That's the file I downloaded. As you can see, it's about 23 gig in size. If you're not familiar with where to get that from, just go back over to the portal and click this download link where it says download the configuration server virtual machine template. That's what that file is. So back in to vCenter here. And what I need to do then is go to Actions. I've got a folder here you can see called AZ Ready. That's the one I've already deployed to show you once this is done. But I'm going to go and select AZ ASR Demo. This is just a VMware folder in vSphere. And I'm going to go ahead and click Actions and click Deploy OVF Template. And when I select that, that will prompt me to select the file. So I'll choose Local File, click Browse, choose that Site Recovery Configuration OVA Template, click Open, click Next. And now I need to fill in some information, so I can call it, AZ ASR Demo 1, could be the name of my virtual machine I'm going to create from that template, because that OVA file is a virtual machine template that gets deployed. If I click Next, I will choose the host where I want to run that, so I can choose the cluster or the specific hosts again if I want to, but we'll choose the cluster. That means VMware will decide which host it goes on. Might take a moment to validate. And once it's validated, you'll just need to review the details and then select the storage. So we'll click Next to select storage. Again, I can choose thick provision, lazy zeroed, or thin provision if I want to. So I'm going to choose thin provision for right now. I don't want to provision all that storage up front. Click the Tintry T880. That's just my storage array that I've connected to VMware. And that's where I'm going to place the virtual machine. Click Next, select your network. In my case, I'm just going to choose VM network for right now. Click Next, and if everything's complete and you're happy with everything, then just go ahead and click Finish. Well, I'm actually going to cancel out of that right now because I do have one previously created. And if we go over to AZ ASR Ready and select this machine, this one's powered up now, and I can now connect to it. And once you click it, the usual thing pops up. This is a console into the virtual machine, and I'm going to accept the license terms there, type in a password. This is just the initial setup for the appliance as it's a Windows machine. So once you give it a password, then you'll be able to connect into it. So I'm actually going to RDP into it because it's a lot easier than using the VMware console itself. So we'll grab that IP address, which I get from the vSphere console, and then I'm going to open a new RDP window to that IP address. Okay, so here I am RDPing into that new machine. Now it should pop up automatically, but if not, just double click the Azure Site Recovery Configuration Manager, and this will ask you to enter a name for your machine. So I'll call it AZ ASR 01, and then sign in to Azure itself. So we'll click Sign In. log into Azure as normal. And once that's signed in, you'll see it continue, and just make sure you are connected to the internet for that step to work. But once you're signed in, it shows that it's connected, and I can see Skylines Academy there. Click Next, and it's going to configure the machine name, and ultimately it's going to add it to that Recovery Services Vault for us in a moment. So once all those certificates are completed, you just need to reboot, and that'll take about 30 seconds before it happens automatically, or just click the icon on the bottom right. Okay, now after that reboot, as soon as you log back into the machine, you'll be prompted with this window for Internet Explorer 11 that pops up. Don't need to confirm anything around the security settings there, but go back to the main tab that popped up, and this is the wizard that will actually help you connect it and finalize the connections back to Azure Site Recovery. So you're now connected to the internet. Now we've got to select our network interface card, so we can select the one that's popped up there, which is the only one I've got connected. If we scroll further down, just click Save on that first of all, and then Continue. And now we have to select our Recovery Services Vault, so we do need to sign back into Azure again. So it's got our account there. And it will prompt you for permissions for ASR, which I quickly clicked accept there, and click subscription. So again, now it's pulling all the details from Azure. So I've got my resource group for Azure Site Recovery, and now I will see my Azure Recovery Services Vault listed there as well. So again, this is exactly what we created earlier on when we were preparing Azure for site recovery. Now you note this, once configured, you cannot change the vault to which this configuration server is registered. So every configuration server that you deploy that's with that VMware appliance is registered as a specific configuration server for that vault. So go ahead and click Continue. You'll need to install some third-party software. Just click Accept, download and install, and then wait for that to complete before we can go on to the next section. So we'll fast forward here again. Okay, and that's completed. We'll continue. Just checking everything out there. Again, you're supposed to put a static IP address in, but we're just going to click Continue for right now. And now I need to add my vSphere, my vCenter that I want to basically connect to. So we'll add vCenter. Okay, now vCenter is added. We'll click Continue. And this way you can add virtual machine credentials, and this is for that mobility agent that needs to be installed specifically on machines themselves. I can add credentials here. In my case, I'm just going to choose Windows operating system. So these are just going to be generic admin credentials, so administrator and a password. And this is essentially a local user account on those machines that has backdoor access that I'm going to be using. But you do need to make sure whatever these credentials are, they need to have access to all the machines that you want to be able to migrate into Azure, because it's going to log into those machines to do various tasks. So we click Continue. Looks like you do not want to protect virtual machines running Linux operating systems. Do you want to continue? And that's just because I've only put in a Windows credential there. And in my case, I'm actually only going to be doing Windows machines. So I'm going to say, yes, I want to continue. So I click Finalize Configuration, and it will now complete that configuration step. Okay, and after a while, as you can see, everything is completed successfully there. The appliance has been successfully configured. So let's go over to the Azure portal and verify everything. Okay, so back in Azure, we'll click our Recovery Services Vault again and continue the steps that we were going through earlier. If we go to Site Recovery, click Prepare Infrastructure, choose our protection goal again of protecting on-premises machines to Azure with the VMware Hypervisor. Plan to do deployment planning later. And for source now, you can see select configuration server AZ300-Architect. That's the machine we deployed in our VMware environment, is showing as ready. Now the step 2, select vCenter server vSphere host. Well, vCenter discovery is in progress, so we'll fast forward again here while that completes. Okay, now that's complete, we can select our vCenter. Again, we've only got the one for this demonstration. Click OK. And now we have the option to prepare. So in this case, if we look, we've got our Azure subscription. So I'm going to use Skylines Primary, select the deployment model. I'm going to use Resource Manager. We're not going to do anything around Classic. And pretty much don't need to worry about Classic anymore. If you do hear it come up every now and then, Classic is before Azure went over to the ARM, which is the Resource Manager method for deploying resources. We need to make sure that we have at least one compatible storage account that exists. So it's found 2, which are available, and ensure that we have at least one virtual network, which we've got 1 that exists there. So we can go ahead and click OK. Everything is prepared on the Azure side. Now we need to go and create a replication policy. So let's go ahead and click Create and Associate. And we'll give a policy name, so we'll call this ASR Policy Demo. We'll choose the source type, which is already selected for us for VMware Virtual Machines, and the target is Azure. Here is our RPO. This is the recovery point objective. So this more specifically means if we did have a disaster, what level of data can we guarantee would be recovered? So 60 minutes means, okay, we might lose 60 minutes of data, or potentially 60 minutes or under, but our recovery point is 60 minutes. So that'll make sure that recovery and replication take effect in a way to preserve that amount of data. We then have recovery point retention. This is the number of hours the recovery points will be retained. And we also have app consistent snapshot frequency in hours, which you can select as well. And you click this drop down, and you can go from anywhere from 1 to 12, or just turn it off completely if we're not using app consistent snapshots. Then we have our failback replication policy name that's filled in automatically for you. And you can see here it says a replication policy for failback from Azure to on-premises will be automatically created with the same settings. So that's if we wanted to do a failback to VMware. Let's say we recovered in Azure temporarily because we had a disaster on-premises and eventually we want to fail back. That's where this policy is important. So we'll click OK, and that will go and create and associate that policy. So again, it'll take a little bit of time here while these things complete. So we'll fast forward again here for you. Okay, and that's all completed. So simply select OK, click OK again, and now we can replicate our application by clicking step 1 over here and configure our source. So our source on premises again, our source location is at AZ300-Architect. That's our collector server on premises that we deployed in VMware. Virtual machines, vCenter, and then process server, we'll choose that AZ300-Architect, which is basically the inbuilt process server. That's a service installed on that machine. At this point now, I'm going to click OK and configure the target environment for Azure. So if we go through, we've got our subscription, which is Skyline's primary, the post-failover resource group, I can select here as well, which I'm going to choose SL-Azure Site Recovery. The post-failover deployment model, so again, I'm not going to use Classic for anything. We're always going to be using Resource Manager. The storage account I can select here, so I can choose a different one if I want to, SL-ASR1. You will notice these values are pre-selected for you if you've gone through the step once before, but this is where you would change it. Same for your Azure network. You can configure this now or later, but we'll choose now, and I can choose the virtual network, in which case I've selected my VNet. So this is nothing more than just selecting that VNet that we created before, and then the subnet that we wanted to go to. So we've got that recovery subnet there. And if I click OK, now I get to choose the virtual machines I want to recover. So I've got a couple of machines in mind. They're 2 jump box machines, just basically Windows servers. We'll select those. Those are the machines I want to replicate. Click OK. And now I've got some additional properties I can select. So if I want to choose credentials for those machines, I'm going to use those admin credentials that I have. Click OK. Those are the ones I entered earlier. And then proceed on to the final step here, which is our replication settings. And that's that replication policy we configured. So I've got my RPO of 60 minutes, my recovery point retention of 24 hours, and if I was doing app consistent snapshots, it would be 60 minutes. And if I go ahead now, actually one more thing just to cover multi-VM consistency. Do you want to enable multi-VM consistency by creating a new replication group? And that's to allow like phased, recovery of groups of virtual machines themselves. I don't need that right now, but if you were doing actual real world scenarios, you would do things in waves and you would create, multi-VM consistency groups where appropriate. But I'll click OK. And now I click Enable Replication, and we will see those tasks in progress and fast forward here while they complete. One thing you can also do is select a task where it's actually enabling protection. So if we scroll up on the event log here, I can click Enabling Protection, and this will actually take me to the site recovery job, and you can see what it's actually doing. So you can see it did a prerequisite check, and now it's installing that mobility service and preparing the target. Then it's going to enable replication, start the initial replication, and then update the provider state. So again, we'll fast forward at this point, but just wanted to point that out in case you're trying to troubleshoot anything, at this stage. We'll just want to see, where it's actually at from that perspective. Okay, and I fast forwarded ahead again here, and you can see that for AZ300-Jump02, this is one of our Windows virtual machines that we're replicating. That is completed as well. All the tasks have been successful. The agent is installed, replication is enabled, etc. If we go back over now to Azure Site Recovery, so I'm going to go to my resource group, select Azure Site Recovery, and have a look at the jobs overall. And I've deliberately set one up to fail here. So if we go to ASR Vault Demo on the right hand side, which is our Azure Site Recovery Vault, and if we scroll down on the left hand side, we've got replicated items that you can see here. And there are 2 in this. You can see AZ Jump 02 showing as healthy, status protected. but AZ-Jump-01 did not replicate successfully. Well, what is the reason for that? And it says protection couldn't be enabled. If you click into this, and what you'll see in there is an error message, which basically is saying that the mobility service agent could not be installed, and that's probably because the username or password is incorrect. So the administrator account on that machine has a different password set up, and that's why it was unable to install the agent. And in that situation, you could go and install it manually, or you could provide additional credentials to Azure Site Recovery so you can remedy that. But if we go back over and look at the one that did complete successfully, so if we go over to AZ-Jump-02, at this point, we should get some additional status around its current RPO. As you can see, it's currently looking at 6 minutes right now, so we'll have data loss up to 6 minutes if we had to recover that machine. Replication health is healthy, and you can see on the right-hand side, we have not performed a test failover yet. So if you ever try to do a failover, it will warn you that you've not completed a test failover, and you should do that before you complete an actual failover. A test failover is just that, a test. The original machine will continue to run in the VMware data center, but a copy of it will essentially begin running in the Azure network that you specify. And to do that, you just click test failover on the top, and on the right hand side, this will pop up in a second. You'll choose a direction which is grayed out for you, obviously, because you're going from VMware to Azure. But if you had other data center options, then you would have choices there. But for right now, we're going to choose our recovery point, so it'll automatically select the latest processed low RTO option for you, but you could go to the lowest RPO option if you want. If you're unsure again of the difference between those, so RTO is recovery time objective, so that's the lowest time to recovery, and RPO is the lowest point at which we would have data loss. So essentially that's that 6 minutes, RPO there. But for right now, we'll just do low RTO, select the virtual network, scroll down and click OK. And at that point, it starts a test failover of AZ-Jump-02, and in a little while, that machine will begin running in Azure. So we'll fast forward again while that completes. Okay, fast forwarding again, and that's now completed. If we go over to the alerts on the top here, and we click the notifications, scroll up, and we can see starting the test failover of AZ-Jump-02. If we scroll down in the details here, again, it's a little hard to read sometimes, so we'll move this over. And you can see it did the prerequisites, completed the test failover, created the test virtual machine, and has successfully started that virtual machine as well. So if we go over to virtual machines, we should see that AZ-Jump-02 with -test on it, because again, this is our test failover. And if we connected it to a network that I had access to right here, we would be able to connect to that machine. But I can do all the other things I want to do, like restart, stop, etc., all the usual pieces that would normally take care of. Now, if I go back to Azure Site Recovery, so we'll go back to our resource group, and I will select Azure Site Recovery, select our Recovery Services Vault, and if I go in here and select that virtual machine, so if I go down on the left-hand side and look at your protected items, it's replicated items here, click that one, and then you can see if we go into AZ-Jump-02, we have that test machine running, which we now might want to clean up, right? If we're actually going to do a real failover, we wouldn't really be using the test machine, because the source machine is still replicating to Azure at this point. So what we would want to do is clean up our test failover when we're done. Just say testing is complete, test was successful, and then click OK, and it will go and clean all of that up for you. And with that, that completes this demonstration. I know this is a bit of a long one here. There's a lot to know, understand what's involved, not just from failover and recovery, but even just all the way through from migrate assessment. So you run in Azure Migrate, as you saw in the earlier modules, then you perform in full Azure Site Recovery and know about the different recovery options that you have. Most of the exam questions will probably be focused around VMware, but obviously we can't guarantee that. Things are changing all the time. But hopefully this gets you going.
Whenever we've been creating virtual machines so far in the demonstrations, we've been using marketplace images. These are provided for you in the marketplace. They have various properties like a publisher, an offer, and a SKU attached to them. Some may charge you different fees depending on the software installed. But we also have the option of custom images. These are essentially do-it-yourself images that you can create yourself for use in Azure. There are a lot of benefits in this. For example, when you deploy a Windows VM from Azure, it's often not patched to the latest patch level, and it might make more sense for you to build an image that's already patched and then use that for creating your virtual machines. So custom images have two ways in which you can create them. In Windows, we first need to do sysprep. In Linux, we use sudo wa-agent deprovision plus the user. Then we will generalize the image in Azure and then create an image. Let's take a look at how we would create a Windows VM image in this demonstration. Let's head straight over to the Azure portal. Here we are in the Azure portal, and let's go straight back into our virtual machine SL-VM01 that we've been using in the previous demonstrations. Let's connect into it via RDP. And here we are in our virtual machine. What we first need to do is sysprep the machine itself. So let's go into sysprep. This can be found under c:/Windows/System32/sysprep. In there, you'll see a file called sysprep. Double click it.
It opens up the system preparation tool, and you'll need to choose a couple of things. First of all, we want to enter System Out-of-Box Experience, OOBE, and secondly, we want to select the Generalized box. Finally, under Shutdown options, select Shutdown. Click OK. SysPrep will begin working, and once it's completed, it will shut down your virtual machine. You do not want to power it on again at this stage. We'll fast forward here and come back to this process once it's completed. Okay, so we fast forwarded here, and as you can see, we're out of our RDP session, and that's natural because the virtual machine had to shut down. You may notice this error up here. We recently resolved a problem with your virtual machine. If you select into that, you'll notice that it says the virtual machine is stopped as requested by an authorized user or by a process running inside the virtual machine. So this is perfectly normal. Let's go back out of there. And if we look, we can verify at the top, our virtual machine is not started right now. We can start it if we want to. Its status is currently set to stopped. And now all we need to do is create our image. So what we do is select the capture icon at the top. It'll ask us to give it a name for the image and what resource group we want to use. So I encourage you at this point, create a new resource group. In my case, I'm going to call it SL-VM images. And then you can also check the box to automatically delete this virtual machine after creating the image as well. So in this case, we're going to create the image in the new resource group and have Azure delete the machine straight away. Click Create. A task will begin. You can see that it tries to stop the virtual machine again, and it'll move on to subsequent tasks momentarily. And we'll fast forward again here and show you once it's completed. So as you can see here in Azure, we've now completed a number of the tasks. It successfully stopped the virtual machine, successfully generalized the virtual machine, created the image in our new resource group, and deleted our virtual machine. So if we go over to virtual machines again, close this notification window, you can see our Windows VM is no longer there. But if we go over to resource groups, we can see we have our new resource group, SL-VM images. If we go in there, we can see we have our image file. We select into that one. We can now create a VM directly off that image. So on the top left here, you select this icon and you can build a VM from that image. Now this is very useful as well because we could also install lots of packages. In addition to patching, as I mentioned, we can have agents, we can have other pieces of software and things that we just want to bake into the image itself, store it as a template here, and then deploy over and over again. And with that, this concludes this demonstration. Let's begin by looking at configuration management as a whole and why it's very important. Previously in our demonstrations, we were deploying virtual machines, we were configuring VNets, subnets, etc. But the virtual machine, when it's deployed, doesn't really have our software packages installed on it. Perhaps we bake them into the template, but then how do we keep them consistent? How do we add additional configurations on top of them? And so if you look at the virtual machine, we break it down into two main sections of configuration management. We have our OS settings, our antivirus and backup agents, infrastructure monitoring. This section is really focused around infrastructure settings, things that your Windows and Linux team will really care about for every virtual machine that gets deployed. On top of that, we have all of our application settings, application installations, app configuration settings, and application monitoring, amongst others. These are things that our middleware and application teams care about as well. In order to get a consistent set of configuration for your entire machine, we utilize a variety of configuration management tools to achieve this goal. This means that if we needed to redeploy the machine, as long as everything is set up in configuration management, we know that deploying the machine again, we will get the same machine over and over again. This is that concept of cattle versus pets that you hear so often in the IT industry today. If we look at this now from an end-to-end process, think about you might use an ARM template or Terraform or some other tool to deploy your infrastructure first of all, and we'll obviously cover ARM templates later on in the course. But think about it this way, the ARM template and infrastructure automation tools go out, deploy all of your infrastructure resources, network, storage accounts, network security groups, and your virtual machines. Everything we've done here is outside of the virtual machine itself. Now we want to configure inside of the virtual machine on top of the operating system. The virtual machine goes off and we use a variety of extensions here. VM extensions allow us to use things like DSC, custom script extensions, etc. to now configure inside of the virtual machine. Ideally, you'll use the VM extensions that make the most sense for your particular environment. If you're a heavy Puppet user and have a lot of teams using Puppet, it might make sense for you to all standardize around Puppet. Perhaps you'll use Chef, perhaps you'll use DSC, and maybe combine that with some scripts on top of it. The choice is really up to you, but there are multiple ways to achieve the same goal. If we look now at configuration management, these are the three extensions that are provided by Microsoft Azure. We have our PowerShell extension, which obviously we'll go over DSC in a moment, but we also have Puppet and Chef extensions available as well. The key difference being that Puppet and Chef are enterprise-level configuration management for multiple nodes. PowerShell DSC, while very good and tactical for us to go and deploy a configuration, doesn't have the same holistic management that something like a Puppet and Chef might have. So if you're looking more at the enterprise across on-prem, public cloud, Windows and Linux, definitely take more of a look at Puppet and Chef. But if you really just want to get a configuration up and running, PowerShell DSC is still a really good tool for you. One last thing to mention, PowerShell DSC scripts can be used inside tools like Puppet and Chef as well. So if you've got a configuration you've configured in PowerShell DSC, there's nothing stopping you porting that over and using that in Puppet or Chef. Now, while Puppet and Chef are certainly out of scope for this course, Microsoft does expect you to know PowerShell DSC and some of the key components. So to begin with, there are three major components with PowerShell DSC. Configurations, these are your declarative PowerShell scripts which define and configure instances of your resources. The next piece we have are the resources themselves. Microsoft refers to these as the make it so part of DSC. They contain the code that put and keep the target of a configuration in the specified state that you've decided on in your configuration. And then finally, we have the logical configuration manager. This is the engine behind DSC. It facilitates the interaction between resources and configurations in a sense to keep the system at the specified state. Now, if we look at a PowerShell DSC example, on the left-hand side, you see some code for deploying IIS and ASP.NET 4.5. First of all, we have the name of our configuration. In this case, it's Skyline's website. Next, we specify the target the configuration applies to. In this example, we're using localhost. Moving on, we have a declarative statement about what we are configuring. In this case, we're saying install IIS. This is the Windows feature, same as if you went into Windows and turned on the IIS feature from the server manager. We have another one here, a second declarative statement, this time to ensure .NET 4.5 is installed, and then we have our curly braces to close out the configuration. That's pretty much what you need to know for the exam. Look at configurations like this and be able to interpret what they're trying to do. We'll see in the demonstration that follows how to take one of these configurations and apply it to a virtual machine. In this demonstration for PowerShell DSC, we're going to take the code that we covered in the module and install it on a Windows virtual machine. In order to get started though, we're going to need some help from PowerShell. But let's begin by looking at our code in Visual Studio and then getting it ready for Azure consumption. Here we are in Visual Studio Code, and you can see I've got my configuration here very similar to the one we had in the PowerPoint. In this case, our configuration name is Skylines IIS. We're still going to deploy to node localhost. We're going to install the IIS feature, and we're going to install ASP.NET 4.5. Now, as I mentioned, we have to get the code ready for consumption. So first of all, we save this file. In my case, it's install iis.ps1. And if we go over to PowerShell, as you can see, my file's there, install iis.ps1. But now let me make it ready for consumption. So I use the command publish Azure RM VM DSC configuration. If you start typing publish -Azure RM VM, you'll see these come up pretty easily. So there we have it, publish Azure RM VM DSC configuration, and now we need two parameters to save it locally. First, we need the configuration path for the PS1 file, so let's type that in first. Secondly, we need our output archive path. In this case, I'm using a local file called sl install iis.zip. Once completed, if I look in the folder again, I now have my sl install iis.zip file ready for consumption via the Azure portal. It's worth noting that if I didn't want to do this locally, I could actually publish it to Azure Blob Storage, and instead of going to the Azure portal to upload the zip file, I could reference it in my PowerShell script. But in our case, we've created the zip file locally. We're now going to go over to the Azure portal and install it via the VM extension there. Okay, here we are over in the Azure portal again, and I'm going to use a new VM I created, sl-vm02. It's just a simple Windows virtual machine, just like we did in Module 1 of the VM section. And if we go in here and scroll down a little bit, you'll see something called extensions. If we select extensions, straight away on the right-hand side, you can see we currently have no extensions set up already on this virtual machine. Let's go ahead and click Add. And here you'll see the various extensions available to you. We discussed Puppet earlier and Chef, and those are available there, but in this case we're going to use PowerShell desired state configuration. Selecting DSC and selecting Create. We'll now be prompted for the modules and scripts that we wish to install. In this case, our module, if we select the File button here, will be our local zip file that we created using PowerShell. Next, we need to use the module qualified name of configuration. If you look at the information button here, it goes in the following format, module/function. In our case, we will use install iis.ps1 /skylines iis, which was the name of our configuration. Scrolling down, we have to put in the version of DSC that we wish to use. In my case, I'm going to use 2.26. With that said, we don't need to enter any of the other information there for the use case we're trying to perform. Go ahead and click OK. As you can see, deployment is now in progress and DSC is underway. Let's check back out in a little while to see if it succeeded successfully. As we can see now, PowerShell DSC is showing that provisioning succeeded. This took a couple of minutes to complete. If we now go RDP directly into the machine, and I have an RDP session already open, look in here and go to Manage, look at our roles and features, scroll down, we can see that the web server feature is actually installed. If we open up a web browser and go to localhost, we can see that IIS has been successfully installed. And with that, this concludes this demonstration on DSC. Now that we can see the value of the PowerShell DSC extension, what's really the benefit then of the custom script extension? Well, think of it this way. This allows us to execute VM tasks without logging into the VM. So if we wanted to log in and execute a PowerShell command or another script, that's what the custom script extension allows us to do. We can upload via the portal or download scripts from Azure Blob Storage or GitHub, reference those in the portal, and it's basically going to inject that script into the virtual machine and run it. And this can be automated using PowerShell as well. There are some benefits and drawbacks though. So if we think of the benefits, no local or domain credentials are needed to log into the Azure VM. The VM does not need an accessible IP address to remotely connect. It's very, very simple to implement. The drawbacks though, it must be enabled for each VM you want to run your script on. You have to enable that extension basically. VMs will need internet access if using GitHub or Blob Storage for scripts. And finally, it is relatively slow. It's not like you're logging into the box, type your script in, or load your PowerShell file and hit go. It takes a bit of time to execute, and if you have to troubleshoot it, it could be a little bit cumbersome. On the whole though, it's a great way as part of automated builds and deployments. If you had some custom scripts that need to run to do some post-configuration tasks and they're not really well suited for some of the desired state tools, it makes sense to execute them here. In this next demonstration, we're now going to deploy our Azure virtual machine using PowerShell. It's very important for the course that you start to learn a lot of the PowerShell commands, as there will be questions on them throughout. To begin with, let's look at some of the PowerShell virtual machine commands that you'll be expected to know. First of all, new resource group. To use this PowerShell command, you use the command into new-azure rm resource group. You then pass two parameters to it. -name is our first one, which is our resource group name that we would type in after that, and then location, which would be East US as an example, or North Central US, as I used previously when I deployed the virtual machine using the portal. Next, we've got our new virtual machine. This is a very simple command, new-azure rm VM. However, it only works if you give it a virtual machine configuration. You need to provide names for each of the required resources, so the resource group name that it's going to go in, the name of the virtual machine, its location, etc. In order to do that, you use the create VM configuration command, which is new-azure rm VM config, and pass it the VM name and other parameters as well. Finally, we've got some commands for starting and stopping the VMs. So to start a VM, it's simply start Azure RM VM and pass it your virtual machine, and stop VM is stop Azure RM VM. Now let's go and look at the actual code that will be necessary to deploy the VM. Okay, so to get started, we're back over here in Azure, and obviously we don't want to create it using the GUI, we want to create it using PowerShell, and Microsoft actually gives us a lot of these scripts on their website. So this link, which will be linked in the course itself under virtual machine scripts, allows us to create a fully configured virtual machine with PowerShell. So I strongly recommend for the exam, maybe give this page a quick read, but to really demonstrate it, scroll down to the sample script, click copy, and take that over and paste that into whatever your favorite editor is. In my case, I'm going to use Visual Studio Code, paste that in there. Obviously, this is the entire script here, so if we scroll up to the top and we'll walk through this. First of all, there's a number of common values that I need. I mentioned we have to create a resource group. So in this case, I'm going to create SL-70533, and I'm going to give it a slightly different name, so P-shell, so we can distinguish it between the other resource group we have for the 7533 exam. Next, I've got location, so I'm going to select North Central US. And for the VM name, I'm going to choose SL-VM02. Now let's walk through the script itself, and I'll magnify the screen here so you can see this a little easier. We first need to create the user object, so this gets us a username and password for the virtual machine, so we use the $cred equals get-credential. That's going to prompt us for credentials and store them in the variable called cred, C-R-E-D. We'll then create our resource group. You can see there that we're using that command I mentioned, new-azure rm resource group, and passing it the parameters that we want. In this case, it's taking the $resource group from above, which we've defined already, and the location we mentioned above. We're creating our subnet configuration with new Azure RM virtual network subnet config. We create our virtual network, and we create our public IP address and specify DNS name. Scroll further down. create our inbound network security group rule and our network security group. So if you saw before when we did it manually, that was filled in by default in the portal. Here we have to actually define it. So we create the rule, which is included as part of creating the security group. So you'll see that the first variable is NSG rule RDP. That's the variable we're saving it in. And then when we create the NSG, it references the security rules stored in NSG rule RDP. We create the virtual network card and associate with the public IP address in NSG. And finally, we take all of this and we create our virtual machine configuration. So here we have $vmconfig equals new Azure RM VM config, our VM name that we specified in the beginning, and the VM size. In this case, you can see in the script we have standard_D1, and I actually know that's not a valid instance type for that region. So I'm actually going to change that to a standard B2S instead. And I'll go through at the end of this just as PowerShell script you can use. If you want to know what SKUs are available in your region, there is a command you can use to check that. Then we've got the operating system, the source image. This is the actual image that gets deployed, using your CPU memory disk. You have to have kind of a template, a stored, image file of Windows that we want to use. In this case, I'm using Windows 2016 Data Center, but you could use other images if you wanted to, and we'll talk more about that later. And then we've got the network interface. And finally, we can now create a virtual machine. So in this case, we use new-Azure RM VM, as I mentioned in the PowerPoint slides, but now I select my resource group name, which is a resource group variable that we specified in the beginning, the location, and the VM configuration. If we go ahead and save that, and now go over and let's try to run that. And here we are, I've tabbed over to PowerShell. Let's go in first of all and log into Azure. So we do that by typing in login-Azure RM account, and you can just type login-A and tab through if you need to. And when you hit that, it'll prompt you to log in just like you normally would. Okay, now that's complete. I can go ahead and run my script. So in this case, my script is called deployvm.ps1. And first thing it prompts me for are those credentials. So remember we had that variable which was indicated by the $cred. Let's go ahead and type in the username and password that you want to use there. And now it will go ahead and start deploying our virtual machine. So this may take some time, so we'll speed things up here and show you once it's completed. Okay, so you can see there that everything was completed successfully. The status code response is true. If we go back over to the portal now, and we can see we've got our 7533 PowerShell resource group. Select in there, and we should see successfully we have our new virtual machine SL-VM02 and all the associated objects as well. Now if we want to delete that, we can go back into PowerShell, and we can now use the following command: remove -Azure RM resource group. Followed by the name of the resource group. Hit enter. It'll ask us if we're sure we want to remove it, so hit Y for yes. PowerShell now continue and delete the resource group and all of the objects inside of it. So again, great for when we want to just delete everything. We don't want to have to go through and delete all those objects in the resource group manually. We can just come in and delete the entire resource group. Obviously use this with caution, but it will delete everything in there for us. And with that said, we'll speed this up and show you once it's completed. And here it is. You simply get this response that says true. If we head back over to the portal, go over to our resource groups, and we can see it's no longer there. And with that, that concludes this demonstration. Okay, so now that we have a basic understanding of the Azure Resource Manager model, let's take a look at ARM templates themselves. These are the things we really care about from a deployment standpoint. And the first thing to think about is ARM templates are really the mechanism that we apply infrastructure as code. So the example on the screen there, don't worry too much about the code yet, we'll get into that later, but we define a JSON file full of code that says, hey, this is how I want my infrastructure to be deployed, and then ARM is the mechanism by which we do that. We download templates from the Azure portal if we want to, so if we've built something manually in the UI, we can download a template from everything we deployed. If you go into your resource groups, you'll actually see your deployments there that you can grab the code from. In addition, you could simply author new templates. If you're pretty comfortable with the language and you know to go to the providers like Microsoft.Storage, Microsoft.Compute, certainly could author new templates from scratch once you're pretty comfortable. However, you'll probably find it's much easier to start with quick start templates provided by Microsoft as a quick way to get going. And quick start templates are available in the two links below. You can see there we have the azure.microsoft.com resources templates link, and then we have the GitHub link as well. And I'm going to go to the GitHub link first of all. Now if we select this one, you can see on the GitHub page, if we scroll down, loads and loads of examples for us. Azure Container Service, Application Gateway, Azure DNS. Almost every single Azure service created, somebody has probably created an ARM template for it, and it's available on GitHub. So there's plenty here to actually choose from. The next thing we need to know are what are the different types of files that we will use with ARM. Well, we have our ARM template file itself. This is the main file that describes the configuration of our infrastructure in JSON syntax. If we want to, we can also have an optional parameters file. This allows us to separate out parameters that we want to pass into the template, so rather than typing them in as we deploy the template, we can simply create a file full of those parameters. And finally, we have our deployment scripts. So these are things like PowerShell, etc., that can actually take the ARM template, or it could be that we deploy the ARM template via REST API, but this is our mechanism for taking the infrastructure as code and applying it to Azure. Next, we have our ARM template constructs. So as you'll see in the demos, when we open up an ARM template, we have a number of sections. For one, we have the parameter section. This allows us to define those inputs that we want. And again, we can pass them in at the time of creation or via a parameters file. We also have variables. So these are values that you can use throughout your template. So if there's something that we use over and over again, it doesn't really make sense to type it in every section of code. We can simply declare it as a variable and reuse over and over again. Then we have our resources. This is the main part really of defining the resources we wish to construct in Azure, so we'll use resource definitions for that section. And finally, we have outputs, which are also optional, and these are values that are returned after the ARM template deployment is completed. For example, perhaps we want to output a public IP address or something like that, then we would output those from the ARM template. So that gives you a brief overview, and I encourage you to just check out the subsequent demonstration. That will guide you through ARM templates, creating a basic one, and working through the various pieces that we've covered here. In this demonstration, we're going to build upon the overview we just covered on resource providers and use PowerShell and the Azure CLI to query resource providers in our subscription. So first of all, we're going to head over to the Azure portal and bring up a bash shell. Here we are in the Azure portal, and we're going to select the Cloud Shell at the top, and immediately it will request a bash shell for us that we can run our Azure CLI commands against. Okay, that's connected and we're signed in. And the first thing we can do is simply type this command AZ provider list, and in order to make it a little bit more readable, we'll do --out table. And this immediately will now bring up all of the different providers, whether they're registered or not, to our subscription. The other thing we can now do is if we want to say just get details for a specific provider, we can go ahead and clear the screen and do AZ provider show, select our namespace. In this case, I'm going to use Microsoft.compute. Add a query. Resource types. .resource type. And we'll also output this as a table. Okay, and as you can see, the big difference is now we're getting a whole bunch of resources listed out as opposed to just the providers, and everything we're seeing on screen is related to Microsoft.compute. So for example, you can see virtual machines at the top and virtual machine scale sets. And this just gives you an idea of some of the queries you can run if you're trying to do some querying directly on providers to find out what's possible, what resources are available in them. These are the commands that can help you from a CLI perspective. Now flipping over to PowerShell, and I've already connected to my Azure subscription, we're going to do the same thing but just using PowerShell commands. So the main command to know here is get-azure rm resource provider. And then we can say list available. And then we want to select some items from there, so we'll say select object. And in our case, we want the provider namespace and the registration state again. Hit that command, and same thing appears. We can see all of the providers, whether they're registered or not. And then if we want to just get the details of Microsoft Compute again, we can do get Azure RM resource provider again, followed by the provider namespace. In our case, Microsoft.compute. Hit enter. And there we go. Similar to the CLI commands, we can see all of our compute resources, whether they're registered or not, and the various locations. And that concludes this demonstration. Not too much you need for the exam there, but just making sure you know, okay, the resource providers, Microsoft.compute. Hopefully this kind of solidifies some of your knowledge around how you would query this using CLI or PowerShell. In this demonstration, we're now going to go about creating and deploying ARM templates. And to begin with, we're going to start out in Visual Studio Code.
Okay, so we're in Visual Studio Code and we can see the basic layout of an ARM template that I've got on screen at the moment. And if you look at it, you can see there's 6 major sections, 4 of which we covered previously, but notice the syntax for each of them. So for the schema, we simply reference the deployment template.json schema that's available from Microsoft. If you're unsure where to get this, if we head over to the Microsoft Azure website, and we can see under resource group authoring templates with the link on screen that the schema is listed there, and this is the location of the JSON schema that describes the version of the template language that we're using. And if you ever want to grab the latest template format, you can go to this link and grab it from there. But we'll head back over to Visual Studio. Next we have our content version, so we could simply give this version 1.0.0.0, and it's always 4 numbers that we need to put in there, and this is up to us to version if we want to. And then we have those 4 major sections. You'll notice parameters use the open curly braces, the variables use the same, resources are defined in the square brackets there, and then outputs, same in the curly braces. But let's actually go ahead and look at an actual example. So I've opened up an Azure ARM example that we can see, and this is one you can get from those quick start templates that I referenced earlier in the tutorials. And again, we can see we've got our schema, our content version. I've not declared any parameters or variables yet. Everything I'm doing, I'm declaring in the resource block that you can see in the middle of the screen. So let me just walk you through this section one at a time. So the first piece I've got is the name of the resource. So in this case, I'm going to concatenate, so that's add storage, plus a unique string related to the resource group ID. So this is going to create a new storage account name directly for me. The type, this is the resource provider we're utilizing. So again, I'm using Microsoft.storage as my provider, and I'm using the storage account's resource type from there. Then I've got my API version. So this helps because as Microsoft evolves their services, they will update the APIs, and you're able to reference those by using the API version in this particular area. Then we have our SKU. So these are some of the things that are required as I provision my storage account. So in this case, I'm using standard LRS for locally redundant storage. My kind is storage. That's the type of account. This particular piece related to storage, and you probably saw that in the storage accounts section of our tutorials. And then the location I want to put it in, so North Central US. Any tags, I haven't declared any at the moment, and any additional properties. And that's basically the entire ARM template, and I've saved it as ARM example.json. So let's go over to PowerShell and see how we would deploy something as basic as this, which is to create a storage account. Okay, so I'm over in PowerShell now, and the first thing I need to do before I can use the PowerShell command, which in this case will be new Azure RM resource group deployment, so feel free to Google that now if you want to. But before I can use it, I do need to create a resource group. So in this case, let's create a brand new resource group. So I'm going to declare it as a variable, so $rg equals, and I'm going to do a new Azure RM resource group with the name SL-ARM demo in the location North Central US. Okay, so that's created. If I do $rg, I should see I've got my SL-ARM demo resource group name there. And now let's go ahead and do our deployment. So in this case, I'm going to do a new Azure RM resource group deployment. And I need to select a resource group name. Now this needs to be the string for the resource group. So what I can do is reference the variable $rg period the resource group name, followed by the name of our deployment. So this could be any name you want to give it, so we can just call this deployment 1. And then the last thing I need is my actual template file, so I reference this with -template file. And you can just tab through these if you want. So in my case, ARM example.json, hit enter. And that will go ahead and start deploying. And what we can do now is go over to the Azure portal, go over to our resource groups. You can see our SL-ARM demo there, and refresh a few times. And after a little while, we can see our storage account has been created. Okay, but now we decide we want to take that same ARM template and we want to make the SKU name for the storage. So, we used standard LRS before. We don't want to declare it in the ARM template. We want to offer it up as a parameter. So let's go back over to Visual Studio Code. And what we need to do first of all is take a look at our area in the bottom here where we've got SKU name standard LRS. Now instead of us declaring it directly there as a string, we're going to reference it as that parameter I mentioned. So first we need to do is eliminate this and say we want to reference a parameter. So quote parameters and then we'll call the SKU name the parameter we're going to reference. And we'll just give that a capital N so we can see it more easily. And that's the parameter we're going to reference, but nothing's obviously going to work yet because we haven't declared this parameter. So let's go up to the parameter section and let's add a new parameter right here. So let's call it SKU name, followed by a colon, and let's open up our curly braces. And let's give this type string. And that is it for this file itself. Now, we know we want to pass that parameter in, but how do we do it if we want to declare it in a file as well? So let's go ahead and create a new file. And let's go ahead, and the first thing we need to do is copy the schema across. So we can go back over to our ARM example. Let's grab the top section. Put that in there. I'm just going to set this to JSON. And now, if we change something at the top, we know the template is deployment template. Well, in this case, it's actually going to be deployment parameters. We can leave the content version as is. We can leave the parameters initial section as is. But where we've got the SKU name, all we need to do now is change this to value. And now we can give it the different SKUs that we want. So in this case, we're going to say standard, and let's do LRS again. So we'll deploy a new account with standard LRS, and we can add one more. So we don't need this comma here because we don't have another parameter we're adding. But let's get rid of that and check everything through. That all looks good. So let's save that. So let's call this Azure deploy parameters.json. I've actually already got one in there, so I'm going to override that. And we've got that saved. Let's just make sure we save our ARM example. And we're ready to go ahead and deploy now. So let's go back over to PowerShell. And same thing, but with a few variations that we need to incorporate. And I've just cleared the screen. And what we need to do is if we reference our previous deployment, we can still see there with the ARM example.json. But the only thing I'm going to add is a template parameter file. So we use dash template parameter file. And now if I tab through, I can see all my different JSON files, but I'm going to use my Azure deploy.parameters.json and hit enter to deploy that, and I should see a second storage account get deployed also with standard LRS, but this time I haven't declared it in the resource body, I've declared it in this parameters file. And last thing we just need to do before we hit enter is go over to Azure and just delete the previous storage account we created because we gave it a unique name of storage combined with the resource group ID, so it's not going to be able to succeed. It'll think we're talking about the same storage account. So let's go ahead and delete that first of all. Okay, and back over to PowerShell. Let's go ahead and hit enter now. And let that deployment go off. And now back to the portal into our resource group. And let's refresh. We can see on the right hand side it's currently showing one deploying, one succeeded, so we should see it any moment. And after a little while, there we are. We can see that our storage account has appeared with the same name because it's still using that unique string with the resource ID, combined with, if we go into deployments, we can look through here and look at deployment 1 again, and we can see our template and look at everything that was inside our ARM template, as well as look on the left under parameters. We can expand that out and see that we used the parameters file and we included the SKU name that way. And hopefully that gives you a good background on ARM templates. That concludes this demonstration. For the exam, just know that you need to be able to sort of read and interpret ARM templates, and in some cases they'll give you questions where you have to kind of take pieces of code and choose which one makes the most sense for the question. Okay, so by now you know how to create ARM templates or start with the quick start templates from Microsoft and massage them to get your result. But what happens when the templates become really, really large, and what if you want to share things between teams? Well, the answer to that is linking templates. So you might start out with your main template and then have like an optional resource template for, say, virtual machines that you want to add. Then you might have a shared resource template for things like maybe your network or storage you want to share amongst other templates. And perhaps you have member resource templates that you want to consume. These might contain reusable scripts or custom scripts in them. But how do we actually go about achieving this? And linking templates is done in a couple of ways. Your inline method, which is where you create an entire ARM template
in the body of an existing template. So your main template's there, and then you just start a new ARM template right inside the body. Alternatively, you can use the external method where you link to an external template. This could be located somewhere else, could be on GitHub, for example. And what you do here is you can have your parameters still inline as you link to the external template, or you can still link to an external parameter set. So just think about that for a moment. You could have an external ARM template you're linking to and an external parameter set, or an external ARM template you're linking to, but you declare your parameters inline. This from an inline example, if we look at it there from the properties perspective, we immediately declare a new template resource and immediately start with another schema, content version, parameters, variables, resources, etc. Again, we're just creating an ARM template inside of our main template. This from an external example, very similar, but if we look at our properties section at the bottom there, we have a template link to a URI where we've located our next template. So in this case, I've got a new storage account.json template stored in blob storage there. And then I've also chosen to use my parameters as another external link. So I'm referencing an external parameters file as well. So pretty good stuff from a linking and ARM management perspective. Another thing to keep in mind are some of the key ARM functions, and you're expected to know these for the exam. So for example, you need to be aware of the copy function. This enables us to declare a resource, then just say, hey, we want to copy it 3 more times, and we'll see that in a subsequent demo. We also have copy index. This is a way of us saying, okay, well, we want to name something, and we want to name it according to the iteration that's going through the loop of our copies. You'll see this in the demo again, but know that copy index, could be used to concatenate against a string and make it unique by copying that index value in there. And finally, we've got the depends on function as well. And this just tells us that a specific variable depends on another one or another piece in the ARM template that we've created. But again, I advise you to kind of check that out in the subsequent demos. It will kind of bring that home for you. Just know about these functions for the exam. In this demonstration, we're now going to use the ARM copy function to create multiple copies of the storage account that we created in our previous demonstration when we created the storage account via an ARM template. So let's begin by going over to Visual Studio Code. Okay, and the first thing we need to do is go in and look at our resource block, and you can see this whole section that I'm going to highlight is the section we want to copy again. And let's say we want to do it actually 5 times. We want to say create 5 new storage accounts, but we don't want to type this code in 5 times. We don't want to paste it there again and again and again. So the first thing we need to do is, if we just look at the name, we are going to run into a slight issue because our unique string, which is based off the name storage plus the unique string based off the resource group ID, is only going to be unique 1 time. So we want to do it 5 times. So the first thing we need to do is add in a function at the beginning, and it's called copy index. So we'll add a parenthesis, copy index, and put in our brackets and put a comma in as well there. And that's now going to take the index for the count, which we'll get to in a second, add it in front of the word storage, and then I'll still add our unique string as well. Our parameters, we haven't changed anything there. They're still being passed by the Azure deploy.parameters.json file. That's for the SKU name where we define standard LRS as the SKU for our storage. But we do need to add our count now. So this goes ahead and iterates, let's say 5 times. So we go down to properties at the bottom, let's put a comma after that so we can declare copy, then put our colon in, our curly braces, and let's give this a name. So we'll call this storage copy, and then we're going to give it the count, which we said would be 5 times, and that is it. So let's go ahead and save that. And what I've done, if we go over to PowerShell, and I've already created a new resource group, so I'll show you that with the variable. So $RG, you can see I've got a new one called sl-arm counts, which we'll look at in the portal in a minute. And I'm going to go ahead and use the exact same command in PowerShell to go ahead and deploy that. The only thing I've changed there is the deployment name to count deployment, but everything else is basically the same. So let's go ahead and run that. Now, if you get an error like the one on the screen, just go back over to Visual Studio Code and check you've got all your commas in there. We added some variables. In fact, I can see it already there in the copy function. We forgot the comma after storage copy. And so we'll save that again and try one more time. And we can see that's going off now. So we'll go over to the Azure portal, and we'll go into our resource group sl-arm counts. And looks like 1's already there, so it's gone through the loop 1 time. Let's refresh. So 2 and 4 are there as well. And if we refresh again, we can now see all 5 are there. So 0, 1, 2, 3, 4, because the loop starts at 0 and we counted 5 times. That's why we've gone from 0, 1, 2, 3, and finally 4. And with that, this concludes the demo. Hopefully this gives you a good indication on how the count loop works. Look for it in the exams and some of the ARM code that they give you on screen. One of the really cool features Microsoft has added is our ability now to save deployments as ARM templates, and they've added this to the curriculum as well. So let's go over to the Azure portal, And in the Azure portal, let's just find a resource group. We can actually take this one, SL-storage, that we used for some of the other demos. And you can see here, if we scroll down on the left-hand side, we've actually got a few things in this resource group. We've got storage accounts, VMs, etc. But if we, on the left-hand side, if we click automation script, you actually see it generates the ARM template. You can see on the left all the resources, the VMs, these sections in the ARM template, network interfaces, all of it is here, parameters, etc. And we can essentially download this ARM template, copy it from here, deploy directly from it again. But notice that 2 resource types cannot be exported yet, are not included in the template. You can click this to see those error details, and you can see it's because file sync service, file shares that do sync in, storage sync service it's also known as, are not yet supported by this automation script download capability. So if we back out of that again, you'd still be able to download it, but you wouldn't get those services in there. But now think about the benefits of this. You can go ahead in the portal, deploy things manually, and then if you want the ARM template to see what it would deploy, if you try to do it more automatically, you could click download and get it. You'll probably have to do some massaging of the template, but essentially that gives it to you there, so you can use, as you probably saw in the other ARM template modules. So with that, pretty cool feature, and you just need to know where to do it on the exam. You'll probably get a question on downloading it, and then they might even give you some code to kind of look at that came from a download. So just make sure you're familiar with ARM templates as well, and not just the ability to download them from the portal. In this demonstration, we're now going to go ahead and look at implementing runbooks with Azure Automation. There aren't too many questions on the exam specifically around Azure Automation, but it is important to understand how you would set up an Azure Automation account and know about some of the runbooks that exist, and certainly you can expand upon this and create your own runbooks as well. Runbooks are really nothing more than automated workflows, so various tasks that you want to occur in a sequence, that's where the runbooks come in. So to get started, let's head over to the portal and go ahead and create our Azure Automation account. So in Azure, the first thing we need to do is select Create a Resource, scroll down to Monitoring and Management, and select Automation on the right-hand side. Go ahead and give your account a name. Select your subscription, and use an existing or create a new resource group. Next, you'll need to choose a location. Note that not all the regions are available here. So if you're in the US, you'll predominantly use East US 2, which is there for you. So go ahead and select that. And this part is very important. You have the option of creating an Azure Run As account. So this essentially creates those service accounts for you that you will use to execute and run your various runbooks. So runbooks don't really run as a user. You would generally run them in the context of another account. And by selecting yes to this creates that account for you. So generally speaking, you simply want to select yes for this unless you've already built service principals and accounts using another method in your enterprise. But with that done, go ahead and click Create. That will initialize the deployment, and within a minute or two, that automation account should be ready for you. Okay, so we're notified that that completed successfully. Now we can go ahead and go to our automation account. We just type automation in the search at the top and select our automation account. And here we are. And a few things to point out first of all. On the right-hand side, we've got a typical overview pane, various job statistics. So this is around the workflows that might be running, workflows that have failed, workflows that have completed. But to begin, let's scroll down on the left-hand side and take a look at some of the runbook options. So if we look at runbooks, we can see this is where we can add a runbook. We can browse gallery. There's some runbooks already published here from the tutorial section for us. We can go to the runbooks gallery and take a look at various runbooks that have been published, and you can choose here from the source. So you can choose between the PowerShell gallery or the script center. You can filter by PowerShell script if you want to look at graphical runbooks or PowerShell workflows, as well as if you just want to restrict your filtering to Microsoft published ones or include community ones as well. So a lot of people in the community build Azure Automation runbooks and they publish them up to the gallery, and then you can simply take them from there and begin to use them. So if you do want to use anything from the runbook gallery, simply select it. There are a lot of them in there for starting and stopping VMs, scheduling and doing it in all different ways. Let's say you wanted this one, you'd simply select it, and then you would go ahead and import that into your library basically, and you can give it a different name if you want to. You can also then go ahead and edit it and change things around if you want to as well, but this is a good way to get started pretty easily. What we're going to do though is go ahead and just create a very basic runbook to begin with. So I'm going to go back to the automation account, go over to runbooks, and go ahead and click add a runbook. And we're simply going to click the quick create option, create a new runbook, and give it a name. So we'll do a Hello World runbook in this example. And then for our runbook type, we will choose PowerShell. And you will notice that they've recently added this Python 2 option here. So if you do want to author runbooks in Python, that's a new option that's currently in preview. But for now, we'll simply select PowerShell as our option, and you can give it a description if you want to. Then click Create. And then what you'll notice is that the runbook is created, and you'll see the Edit PowerShell runbook page that opens up. And on the left-hand side, you can see we've got various commandlets. So if we want to pull from PowerShell commandlets, Azure RM compute commands, they're all in here. We can kind of expand them out and use these commandlets to kind of build up our script as we want to. So it's just an easy way to kind of get around if you don't want to kind of go looking up PowerShell commandlets. But for right now, we're going to do something very basic. We're just going to go in on the right-hand side and type in param. So we're going to declare a parameter that we're going to ask the user for, and we'll put in the first parameter. We'll make sure it's not required, so we'll set a default parameter. Okay, and then we'll do the parameter as type string, and we'll call it name. And so if we go down below, we can simply put our script to say hello $name with an exclamation point at the end. And we can go ahead and save that, and then if we want to, we can publish it. But for right now, let's just go ahead and test it out. So we'll hit the test pane, and on the right hand side, we can put in a parameter if we want to. So you can see, because we've got that input parameter, it's asking for the name, but I can go ahead and run it without. But one thing to point out, as you can see, so first thing, when you run a runbook, it has to be queued up. So it waits for a cycle of compute that it can then, put this runbook script on and then run. In this case, it's completed already now. But if I wanted to put, hello students, we could do that. And go ahead and hit start again. It's queued up, waiting to execute. Completed, and you can see hello students. So definitely, if you're familiar with PowerShell, this should be right at home for you. Otherwise, just go ahead and look at the gallery, take some other runbooks from there and utilize those, until you kind of get familiar and get what you actually want to do. A lot of people do use these as automation runbooks as a response to events. So there's a lot of new services like Event Grid coming out too, where you can say, okay, when this event happens, fire off this runbook, or you can also just, from other monitoring alerts, fire off runbooks as well. Like, let's say you had low disk space on the C drive of a Windows machine, and it's because you had a bunch of logs that you put there and you probably shouldn't. You could have a runbook go in there and actually just kind of remove those for you periodically or in response to that event. Speaking of periodically, if we go back to our runbook itself and go ahead and publish this runbook. So that's one thing you do have to do before it's available to use. So let's go ahead and publish it. This allows you to also do some element of versioning control as well. But you will see that you have this option that appears now where you can now view the code, edit still, go back into that screen we were just at, but the schedule option is also available to you. So you can select schedule and you can link a schedule to this runbook. So we can click that and create a new schedule as well. So if we wanted this runbook to just occur at a periodic period of time, like maybe every morning at 9 a.m., that's where a lot of people do like these startup VM ones, that's like 6 a.m. before everybody comes in. They make sure everything's powered on and ready to go, and then shut down for developers, at 5, 6 p.m. whenever they go, depend on different time zones, etc. But this is a way you can schedule it to run, when you decide to do it. And with that, this concludes this demonstration and hopefully gives you a good overview of Azure Automation and how to implement runbooks. In this demonstration, we're now going to build upon what we discovered in Azure Automation and extend it to Azure Automation DSC. If you remember from the Virtual Machines module, we created a desired state configuration module in PowerShell for installing IIS. Well, Azure Automation allows us to automate the installation of these DSC modules across multiple machines and also check that they remain in a consistent state. So let's head over to the Azure portal to begin. In the Azure portal, as you can already see, we're in our automation account that we created in the previous module. And if we scroll down, we can see we have these options under configuration management for DSC nodes, DSC configurations, a gallery again in preview currently, and DSC node configurations. So the first thing we need to do is add one of our configurations. So we go to DSC configurations and we can go ahead and add a configuration. And in this example, I'm simply going to select the one we used in the virtual machines module. So I've got the Skylines IIS.ps1. In fact, if I right click it and edit it, that opens up and you can see we have our configuration called Skylines IIS. We have our node of localhost where we simply are enabling the Windows feature IIS, and we're going to enable ASP.NET 4.5 as well. So we can close that down. We're not going to make any changes to our DSC configuration. We simply want to apply it now from Azure Automation DSC instead of going to every single VM and putting it into that VM extension like we did in the virtual machine module. So I can select the PS1 file here and go ahead and select that, and it will populate this name. This has to match the configuration. So you can see in that PS1 file, my configuration name was also Skylines IIS, and I can give it a description as well. If I go ahead and click OK, that will create that configuration, and now I can select that configuration and I can choose to compile it. So I have to do this before I can put it onto one of my servers. And you can see it says, are you sure you want to compile this configuration? Any node configurations generated will be automatically placed on the Azure Automation DSC pool server. And this is the server that's going to essentially connect to the virtual machines and make sure all those configurations remain consistent. So we're going to go ahead and select yes to this. And that's going to compile that configuration. You'll see a job get queued up at the bottom here, and we'll fast forward a little bit here. It takes a few minutes for all this to complete, and then we will have our node configuration ready for us. Okay, and as you can see, that compilation job is completed, so we can exit the screen and go now to DSC node configurations, and you'll see that we have skylines.is.localhost. That's the configuration that we compiled. Now all we need to do is associate it with virtual machines that we want to apply it to. So I've got a test virtual machine all ready to go. If we go over to DSC nodes, you can see there's no machines already in there. We can simply select add an Azure VM, and it is possible to also add non-Azure VMs as well. But in my demo, I'm going to choose Azure VM, and then we'll go ahead and select Windows VM 01. Select this one and choose to connect it, and you can see it's actually deallocated right now. So first thing we need to do is go ahead and power that machine back on. So let's go over to virtual machines, go to Windows VM 01 and start that machine up. And again, I'll just fast forward here while that comes up and then head back to Azure Automation. Okay, that machine has successfully started back up, so let's go ahead and try that again. Let's hit add Azure VM, select Windows VM 01, and we now have the option to click connect. So we'll select connect, and this connects it to this node configuration that we select in this drop down. So I'm going to choose skylines.is.localhost. I can choose how often I want to refresh. I can choose the configuration frequency, and I can choose the configuration mode. And this is very important. You can see the option here of apply and monitor, apply only. So that means it just pushes the configuration, as opposed to apply and monitor, which pushes it and will check it for consistency. And then a big one, which you need to be ready for, and certainly a lot of people will start with apply and monitor, but apply and auto correct means if somebody logs into the server, changes are set in manually that conflicts with the DSC configuration, when Azure Automation DSC goes and checks the configuration against the pool server, it'll say, nope, this isn't correct. I'm going to override what the person did manually and set the configuration back to how we set it here in Azure Automation. But I'm going to choose apply and monitor in my example, and a few other things here. You've got allow module override. If you select this controls whether new configurations downloaded from Azure Automation DSC pool server are allowed to override the old modules already on the target node. So if you've got old modules that you've already put on from a different version and you want to override them with this one, then that's something that you would select as well. Reboot if needed. That's if some of your configurations require that reboot, then it can execute that and then continue configuration. The last thing to mention is just that you do have this option of primary and secondary key. So there is the concept of keys in Azure Automation to basically know which Azure Automation is registered to and authenticated to run against those machines, and you can rotate those keys much like any other key. I'm not going to show you that just yet because I want to complete this configuration, but if you go back to Azure Automation, you'll have a section there called keys. You'll have your primary key and your secondary key, and you can rotate them. So you would basically then use your secondary key before you push and change your primary key, basically. If we go ahead and select OK, that now connects that VM in and will apply that DSC configuration. So again, I'm going to fast forward here because it does take about 5 or 10 minutes for that IS and ASP.NET configuration to apply, and we'll come back once we've got some data to show you. Alright, and after a little while we can now see that that VM is now connected, and you can see it's connected, and there's an extension version there as well, so it's using the DSC extension to get connected in. And if we go back to Automation DSC now, if we go back to the account, and if we select DSC nodes, which we're actually already still on, you can see our Windows VM on the right hand side with status compliant. If we select this, we can now see, if we scroll down, status compliant, different times it's checked. These are the initial checks going on there, consistency in progress. And what you'll notice is every 15 or 30 minutes, depending on what you set your time interval at, you will see that these reports come in to say whether or not this VM is compliant with the configuration. And so this is the true power of Azure Automation DSC, because not only can we define a node configuration for our virtual machines, we can assign it to multiple virtual machines all in one go, and then we can continuously validate whether or not they are compliant. And this can also help with login, auditing, etc. And it can also all be fed into log analytics as well, which you'll see in the other modules. And with that, this concludes this demonstration and hopefully gives you a good sense of Azure Automation DSC and what you can do with it. In this demonstration, we're now going to take a look at Azure files in the Azure portal and then how we would connect our machine to that Azure file share. So let's head over to the Azure portal first of all. Okay, and the first thing we're going to do is go ahead and create a new storage account. So we'll click Add. and choose our subscription and our resource group. So I'm going to choose the SL-storage resource group. Scroll down, give it a storage account name. So we'll call this SL file demo, and make sure that's not taken. There we go, got the green check there on the right. And scrolling further down, location, North Central US. We'll just use standard tier for performance here. General purpose version 2 is fine for our account kind. I can choose my replication option here. So because I'm using a file share, maybe I don't want that just to be locally replicated. Maybe I do want to use something like read access geo redundant storage, which if you saw in the other module, that's going to create 6 copies of that data and put it in other regions as well. And because I'm going to be accessing this data pretty frequently, I'm going to use the hot tier for my access method. So we'll click next, which takes us to the advanced settings. Nothing we need to do at this stage. We could put some tags in if we want to as well at this point, but otherwise let's review and create. So we'll go ahead and click create, and that gets our new storage account created. Okay, well that's created, so we'll go to the resource, which is our storage account, and in here we can create our file share. So if we scroll down on the left hand side, we will choose the file service files, and in here click new file share, and let's give it a name. So SL file share 01, and we'll give it a 10 gig quota, and it really is that simple. That is our file share now created, pretty quick. And now we can click the context menu and go to connect, because we want to connect to this file share, and it will now give us a couple of ways to connect from Windows as well as from Linux. If you scroll down there as well, it actually gives you the scripts directly in there with the keys and everything already filled out for you. So in my case, I'm going to connect by creating a PowerShell drive on my Windows operating system that I'm on right now. So I'll click this copy on the right here. If I wanted to map the drive, I could use netuse, which is this bottom option here, but the top one does a PowerShell drive. So now what I'll do is I'll open PowerShell ISE, right click it and run it as administrator. And I'm going to go in now and paste that script. And if we look at what it does for a second, you can see the first thing is just storing the account key that's going to access the file share. I'll pass in a credential object, so that way when I do new PS drive, I can reference the credential object with the account key, and that's going to connect me into that file share. So if I go ahead now and click run script, it will run that PowerShell script, and you can see it's created a Z drive for me in PowerShell. So now I can simply go to Z drive and nothing on there, obviously. It's just an empty file share at this point. But that's all there basically is to it as far as, getting a drive connected and getting access to, a whole bunch of files. And with that, that concludes this demonstration. In this demonstration, we're now going to take a look at Azure File Sync and how we can use it to cache files closer to perhaps people's data centers or regions when we have, say, a central file share. So this is a great example because you could deploy Azure File Sync on a machine running in your data center where your users will map drives to, and then it is basically archiving or tiering, I should say, files up to the Azure file share service that's running in Azure itself. Now, a couple of things to note before we jump into the demo. One is you do have this web page I highly recommend you go to. We'll put the link, in the course for you, but there are a number of prerequisites that need to be available. For one, there's region availability for Azure File Sync. So we need to have an Azure storage account and file share in the same region that we want to deploy Azure File Sync. So if we look at the region availability and we scroll down, you can see some of the things we've done in the course so far were in North Central, but that's not available. So we're actually going to use Central US, which is based in Iowa, for our file sync and file share in this case. If we go back, a few other things as well. So we'll go and create that first of all, the storage account, the file share, and then we also need to have a Windows server with an appropriate version of PowerShell and the Windows management framework already set up. I've actually already deployed a Windows 2016 server for us ready to go, so we will use that, throughout. And if we scroll down, there's a few other things that you also need to be aware of in preparation for using file sync, aside from, just turning off IE enhanced security configuration, temporarily there. There are two options to install file sync, the portal or PowerShell. We will do it via PowerShell. If we click this link here, we're basically going to grab this entire script that they give us, which just makes it far, far easier because it actually goes and downloads the file sync agent for our particular OS without us having to go clicking around, downloading everywhere. It's just going to do all that for us. So make sure you have this link ready to go before you begin if you're going to follow through in this demonstration. But with that, let's head over to the Azure portal, and the first thing we'll do is let's create that storage account in Central US. So in our subscription and our storage resource group still, we'll call it SL File Sync 01, and again we're going to change that to Central US. Performance is fine as standard, GPV2 is fine, RAGRS if we were wanting to make sure that this had redundancy built into the storage. And I'm going to just click through the next options. No additional custom settings that we need to put in place for this one. So it completes the validation and click create. And we'll fast forward here to when the storage account is completed. Okay, that's complete. So we'll head over to our storage account and we can see it there. We've got SL file sync 01. And what I'm going to do first of all is the second part of the prerequisite was to create a file share. So we'll go to file service, into files, and create that new file share, which we'll call SL file sync share 01. And we'll just give a 100 gig quota there temporarily and click create. And that's our file share created as well. Now what we need to do is go ahead and RDP into that Windows server where we're going to install the file sync service. So I've got my virtual machine ready here, SL file sync VM01, and I'm going to connect to this one. Okay, and I'm logged into the server and server manager's coming up. And the first thing I need to do is go ahead and turn off that IE enhanced security configuration over here. Set both of those two off and click OK. Next, I'm going to open up a PowerShell client. So I went to start, typed in PowerShell there, and right-click and run as administrator. Okay, now I just need that script that we got from the web page. And we run that script after pasting it in, and you can see it's downloading the client and we'll continue on with the install. And we run that script after pasting it in, and you can see it's downloading the client and we'll continue on with the installation there. So we'll fast forward a little bit here as that completes. Now once that completes, you should actually get a pop-up window to complete the installation and register with the Azure service. But if you don't get it, it could be for a number of reasons. One, you might not have the Azure RM modules installed, so go ahead and go to PowerShell. Run that as administrator. And do install module name Azure RM and hit enter there. That will install the Azure RM PowerShell modules for you. You may get this prompt to install a NuGet provider, so just go ahead and select yes for that if that's the case. And you may also get a pop-up saying it's an untrusted repository. Same thing, just select yes for that as well. Okay, and with that complete, the next thing we need to do is go ahead and start the sync agent. So we'll go to this computer, go to C drive, program files, Azure, storage sync agent, scroll down, and you'll see something that says server registration. Right click and run that as administrator. Okay, and you can see that saying sign in and register the server. So we'll click sign in. And it will prompt us for our Azure login. Okay, and now you can choose your subscription. So we can see I have my Skylines primary one. Let's go to query that now, and then we can pull the resource groups inside there. So SL-storage. Now you can see we don't have the storage sync service yet. We only created the files. So what we need to do is go ahead and create the storage sync service in that resource group. So back in the Azure portal, back into that resource group, SL-storage. And let's go ahead here and create storage sync service. It's actually under Azure File Sync, not Storage Sync. Click Azure File Sync and click Create. So we'll give it a name, SR File Sync SVC for SL File Sync Service. We'll put it in that storage resource group, and that is in Central US. And click Create. And we'll fast forward again until this completes. Okay, and that's completed. So we have this new service, SL File Sync SVC of type Storage Sync Service, which we can click here. And we can get some details on it there and go ahead and create our sync group, which we'll do first of all. So let's give this a group name. So we'll call it Skylines Sync Group. choose our subscription, select the storage account. In this case, we've got SL file sync, and again, that had to be in the same region. And then we should be able to select our file share that we created earlier, SL file sync share 01. Go ahead and click create now. And that's our first cloud endpoint that we have there. And now let's go back over to the server to continue. So again, we'll select here. It probably won't let us immediately do it, so we'll have to either try to go into another resource group and back in and see if that does the query again. It does, so we can do SL file sync SVC now. And here you can see we've got our subscription, resource group, and our file sync service. Click register. Sign in again here. Okay, and you can see registration is successful. You have now established a trust relationship between your server and the selected storage sync service. To manage the server and set up sync, use the Azure portal or PowerShell now. So we can click OK and close these down. Okay, and next I'm going to go back over to the Azure portal, and in here I'm going to create what's called a server endpoint. So I click Add Server Endpoint, and this is all within our sync group, and I can choose that registered server SL file sync VM01. Choose a path, so I'll choose D:, which is the temporary drive on that Windows server, and we'll call it Skylines. And I can choose whether or not to enable cloud tiering, so that'll tier files off to the cloud, when space becomes low. And with that, I'm choose disabled, I'm going to click create, and this will take a little bit of time, probably a couple minutes or so, but essentially it's setting up the sync between the server endpoint and the cloud endpoint. And while that's going, we can actually go over to the server, go to this PC, look at the D drive, and very shortly we should see that Skylines folder appear here. There it is. And what we can do now is take some images that I've downloaded already. These are just some pictures from the internet, so I'll grab these, we'll get them ready, and as soon as everything is completed, we'll drag those into the Skylines folder. But we're still waiting for the health to go green, so we'll just wait here until that's completed successfully. Okay, and after a while, that's all completed successfully, and we can see that everything is healthy now. Let's go back over to our machine, and here we are, and let's take our image sample, grab all of these, and throw them into the Skylines folder. Everything is copying across there. If we go into Skylines, we'll see all those images. And now, if we go back over to Azure, and we look at this file sync share 01, we'll click this one, and click SL file sync 01. This will take us to that file share that we created earlier on. And that's the storage account. If we scroll down and click Files, we should see our file sync share 01. And there we can see all of those image files are now in that file share as well. And so the point of this is that you can essentially have a file share located on a server that's syncing up to the cloud, but any changes are instantly accessible. If you lost that server for whatever reason, something went wrong, everything is available for disaster recovery. You could set up another Windows server, create it as another server endpoint, and Azure will sync those files back down to the endpoint. And with that, that concludes this demonstration. Hello Cloud Gurus. First of all, just a huge congratulations for completing this course. There is so much information to cover and it's always changing, so thank you for coming along with me on this journey. I would suggest taking some time now to familiarize yourself with the Azure console and get some more experience using it before going into the exam, as this will really help to cement your knowledge. I wish you the best of luck and invite you to come back to share your experiences with the exam in our forums. You can also check out all the other Azure content available to continue your journey to becoming a Microsoft Azure Master. Keep being awesome, Cloud Gurus.